So, you want to become a creative developer who builds modern apps people actually remember. Maybe you've seen those websites that make you stop mid scroll, the ones that feel crafted, intentional, and impossible to ignore. But you're not sure where to start. First, you'll spend a week debating whether to dive into GSAP, Framer Motion, Anime.js, React Spring, or another one of those tens of different tools. Then another 2 days go by for tweaking your dev setup, only to face a blank canvas with a console error screaming WebGL context lost. You'll pull in shaders, loaders, and controls, then burn 4 hours debugging the one import that's tanking your scene. But hey, nice job. Your first 3D element exists. It doesn't respond to anything, but it's there. Or, instead of wasting days lost in this tutorial maze, why not dive into this one course where you'll build 3 creative web applications from scratch, loaded with stunning animations and immersive 3D elements. Hi, I'm Adrian, and welcome to this fresh course where you'll master GSAP and Three.js. Each project is designed to spark your creativity, strengthen your portfolio, and move you one step closer to getting hired as a creative developer. Fully beginner-friendly, all in one place. Don't look any further. We'll kick things off with a GSAP crash course, where I'll break down what GSAP really is, why it's so powerful, and some pro tips, tricks, and most common mistakes that beginners make. You'll also learn how to seamlessly integrate GSAP with React, Vue, Next.js, or any other front-end framework. Once you got down the basics, we'll dive into building a real-world project, Mojito Cocktails, a landing page with scroll-triggered animations, immersive parallax effects, and silky smooth transitions. It's the kind of site you drool over on awards. By building this, you'll learn how to understand what GSAP is and why it's a game changer for web animations. Integrate GSAP seamlessly with modern frameworks and create scroll-triggered animations, parallax effects, and smooth transitions. Next, you'll put your new animation skills to the test by working on a MacBook Pro landing page clone, a site that looks and feels like Apple's masterpiece. Along the way, you'll explore Three.js from concept to real-world implementation, with a focus on React 3 Fiber and Drei, so you can bring interactive 3D elements to life in a React environment. You'll learn how to develop cinematic hero sections with scroll-synced video backgrounds, interactive, photorealistic 3D MacBook models, parallax-masked video rendering that feels alive, advanced scroll storytelling that guides users through an emotional journey, and performance-optimized responsive design across all devices. Finally, you'll combine everything you've learned to create a portfolio website that could easily get featured on awards, blending stunning 3D animations with a user-friendly layout. You'll build a minimal yet effective navigation bar, a hero section with a 3D room model, animated text, and a call to action, a project showcase in a clean bento grid layout, animated timeline to visualize your career journey, technology cards with interactive 3D icons, testimonial grid with hover effects, functional contact section with a form and 3D desk model, and finally, a clean footer to wrap it all up. By the end, you'll have a portfolio that not only looks amazing, but functions smoothly, showing off your skills in a way that's impossible to ignore. Pretty good, right? It's a complete learning journey where you start with the fundamentals and progress to creating modern web apps packed with animations and 3D elements. And as you go through each one of these projects, here's what I prepared for you. Full open source code bases, custom Figma UI kits, deep dive guides for GSAP, Three.js, Tailwind, and more, access to our Discord for support and feedback, all 100% free inside of the video kits linked below. And if you're worried that this might be too advanced, don't be. I'll walk you through everything step by step, from animation and 3D fundamentals to integrating 3D models with Three.js, adding scroll-triggered animations, and immersive parallax effects. All you need to get started is some JavaScript, React, and Tailwind. And if you're not quite there yet, you're in luck, because I've got free crash courses for all of these right here on the channel. And if you want to dive even deeper, I've got an ultimate animations course on jsmastery.com. I'll share more about it as you continue going through this course. Click the link down in the description if you're interested. And keep in mind that you're not just watching another tutorial. You're building real, impressive apps with today's best tools. So whether you're job hunting, freelancing, or building your own ideas, this course gives you the skills and confidence to make it happen. So grab your favorite drink, open up your IDE, and let's animate your first project. Think front-end development is dead, AI is taking your job, and no-code tools are putting you out of business? Think again. Sure, AI can spit out cookie-cutter UIs, but it can't craft experiences worthy of awards or create interactions that make people stop and say, how the heck did you just pull that off? This is where real front-end skills and real front-end developers step into the spotlight. Hey, I'm Adrian, and today I'll show you just how alive and essential front-end development still is. You're gonna master smooth cinematic animations that transform websites from, well, it's working, to mind-blowing. Your journey to becoming a standout developer starts right here by mastering GSAP, the powerful animation library trusted by top-tier agencies and creatives worldwide that as of recently became completely free. People pay thousands for these skills, but today you'll get them for free. I'll teach you what GSAP actually is and why it's so powerful, some pro tips, tricks, and common mistakes, and how to seamlessly integrate GSAP with React, Vue, Next.js, or any other front-end framework, with plenty of engaging demos to keep things exciting and hands-on. And because absorbing all of this info in one go can be tough, I've put together a free GSAP cheat sheet you can download right now. Keep it handy whenever you're building out your next jaw-dropping animation, so I'll leave the link down in the description. But theory alone won't cut it. That's not how I roll. Once you're comfortable with the basics, we're diving headfirst into creating a stunning real-world project. Mojito Cocktails, a landing page so smooth, it just might slide off your screen. Think scroll-triggered animations, immersive parallax effects, and silky smooth transitions, the kind of stuff you drool over when browsing awards. Before we dive in, this crash course will give you a solid start with GSAP and show you how to create beautiful, fluid animations like this cocktails website we're building today. But if you want to truly master GSAP and learn how the world's top companies build those mind-blowing, real-world animations you see on sites like GTA 6's landing page, well, that's why I've created the ultimate GSAP course. Inside the full course, we go way deeper. You'll actually build a full-blown GTA 6 landing page clone from scratch using advanced GSAP techniques, scroll-based animations, timelines, performance optimizations, real project structure, and tons more. You'll also get access to this special app that references all of the animations you've learned so far, and it also contains some challenges. But within the lessons is where the real magic happens. Here, you'll be able to see exactly how they behave in real time and how things work behind the scenes. The crash course you're watching right now will give you a taste, but the full course will turn you into a pro. So, if you're serious about leveling up your animation skills and want to learn how real companies build these experiences, the link is below. Now, let's get started. Now, before we dive into the build, I want to make sure you have a solid foundation. I've prepared a fast-paced, hands-on GSAP crash course to get you up to speed with everything you need to know and to show you just how intuitive and powerful this library really is. So in the next few minutes, you'll learn how to animate elements using GSAP from, to, and from to methods, how to control your animations with scroll trigger, how to stagger animations for maximum visual impact, how to animate text like a pro using split text plugin, and how to sequence animations one after another with GSAP Timeline. Think of this as your GSAP toolbox. Once you've got this down, building real-world, jaw-dropping experiences will become so much easier. Let's jump in. I prepared a quick workshop for you, and I've linked it for you in the description. Download it, open it within your Visual Studio Code, and then we can install all the necessary dependencies by running npm install. So let's go ahead and run the application by running npm run dev to see what we have on it. And then we can hold the command key and click on this link to open it up. As you can see, I prepared 7 different demos that teach you 7 most important GSAP concepts. So let's dive into the first one by clicking right here, and let's explore GSAP.2. GSAP.2 method is used to animate elements from their current state to a new state. It's similar to GSAP.from, but the difference is that the GSAP2 method animates elements from their current state to a new state, while GSAP.from animates elements from a new state to their current state. And of course, you can read more about it if you head over to the documentation page. Basically, you can see how it works right here. You target a specific element by providing the identifier, and then you specify the properties that you want this element to take after the animation runs. So we are changing the rotation and the X position throughout the duration of 1 second. So now you've seen the demo, right? You could have done on your own without me. But see this box right here. Now we'll animate it together to solidify what we just learned. So going back to the code, we can split our terminal and install a new package by running npm install gsap, as well as add gsap/react, which will allow us to start adding those animations. Once that is done, we can head over to our pages and then gsap2, as that is the first element we want to animate. In this case, I want you to animate the box that we have right here below. So if you scroll down, you can see a div that has a class name of VW, HW, and then BG Blue 500, which makes that a box. And here we have an ID of blue box. So let me teach you how to animate using GSAP in React. Right below this to do, we can say use GSAP, coming from GSAP React. This is a special hook which looks and behaves a lot like useEffect. Essentially, you define a callback function and then a dependency array on when this has to run. And within it, you can use GSAP to then animate the elements you want. So we do that by saying GSAP, which you have to import from the original GSAP package, .to, and then the first parameter to the .to method is the target you want to animate. In this case, we can target it by ID by saying blue box. Then the second parameter are variables which you want to animate. So you can expand an object, and let's do something like x is 250 pixels. So we animate from x of 0, of course, by default, to x is 250. So now if you go back to your page and reload, you can see how nicely this animates. And just so we can see our animation happening in real time at all times without needing to reload the page, we can add a repeat of -1, as well as a yo-yo property set to true, which will make the animation reverse on every other cycle. So as you can see, now it's going back and forth. Let's pull this to the side so we can continue animating while we're writing the code at the same time. There we go. That's much better. Now, let's also give it a bit of a rotation property of 360, and you can see now it completely rotates. We can also increase the duration to something like 2 seconds. If you do that, it's going to move much slower, and we can also give it a special ease property, which defines how the animation happens. As you can see immediately, you get a lot of different properties you can choose from. For example, bounce in. If you save it, you can see now it kind of bounces in and then stops. You also have bounce out, which is going to make it bounce at the end. There's a lot of these different easing curves that you can decide to use. There's also circle, back, and so much more. In this case, let's use elastic. As you can see, it looks like it's on a spring right now, which you have to pull and then move back and forth, which gives it a very interesting effect. But with this in mind, you just learned how to use one of the fundamental methods in GSAP, which is GSAP.to property, which accepts an ID, which is an identifier, and then properties you want to apply to the element you're targeting. You also learned how to apply animations using the use GSAP hook and GSAP within React. So with that in mind, let's go back to the homepage and navigate to the second method of the day, GSAP from. As the name suggests, GSAP from is used to animate elements from a new state to their current state, similar to GSAP to, but the difference is that the from animates from the new to the current, while GSAP to animates from their current to a new state. Of course, you can find more information within the docs, but for now, let's implement it in action. I'm going to go back to GSAP.to and copy this entire part. Then I'm going to navigate to GSAP from and simply paste it right here below. Of course, not forgetting to import the use GSAP as well as GSAP. Now, if we modify the method from to from and modify the ID from blue to green and save, you can see that it started moving from the back and then going to the front. In this case, let's explore a bit of a different ease, one I like to use often, which is power1.in.out. This one starts with a lot of power and then slows down, as you can see it right here. But the most important thing is that now it starts from the position 250 pixels in. If I reload, see how it started from the right side, moving to the left. That is the only difference between from and to. The next method of the day is GSAP from to, which, as the name suggests, is used to animate elements from a new state to a new state, similar to from and to methods, but the difference is that here you can define both states. So if we scroll down, we can copy the entire thing we have here and navigate to from to. So let's paste what we copied, import the hook as well as GSAP. We can modify the method from to, and you still pass a specific identifier, but this time you have two different objects you can modify. We have the first object, which is the from object, and then we have the to object, which accounts for the two properties we want to implement. So let's try to animate it from an x of 0 and a rotation of 0 with something like a border radius of 0% as well. And we're going to animate it to 250, repeat -1, and let's also add a border radius of 100%. And we can also modify the ease to something like bounce out to explore another one. Now, if we modify the identifier from green box to red box and save it, now you can see how it turns from a square into a circle and then comes back. So we're modifying the rotation and the x and the border radius to 0 at the start, and then at the end, we set it to 100, which essentially makes it a circle. This is pretty useful when you want to modify both the start and the end of an animation. With that in mind, those have been the 3 base GSAP methods. But let's explore what else we have in store. Next one on the list is the GSAP timeline. And the GSAP timeline is used to create a timeline instance that can be used to manage multiple animations. Again, it's similar to from, and from to, but it is used to manage multiple animations, while all of these manage just one element from their current state to a new state. Of course, we can open up the docs to learn a bit more about it. And in this case, you can see that they consider it a sequencing tool that acts as a container for the other animations we have explored. It allows you to have complete control and manage the timing of an animation. So instead of doing something like this, first do x100, then do y50, and then change the opacity to 0, you can create a timeline, and then you can modify the elements to move on that timeline. You can also control the whole thing easily by pausing it, resuming it, reversing it, and so much more. So with that said, let's animate this yellow box and also include the play and pause button. So we can navigate over to GSAP timeline. And you can see at the bottom, as we always do, there is a div that has an ID of yellow box. So first things first, when creating a timeline, we have to define it by saying const timeline is equal to GSAP, which you have to import from GSAP, dot timeline. And then you call it like this. Next, you can also pass the options object to give it some properties, like repeat -1, repeat delay of something like 1 second, and yo-yo to true. We already learned what this does. It simply makes the box move left and right. It simply makes the animation repeat, so we don't have to reload the page to check out the animation. Now that we have the timeline defined, we can use the same use GSAP hook we have used not that long ago, define the callback function, as well as the dependency array. Now within it, we can use the timeline.to property instead of using the GSAP.to property. And it works in the same way you have seen it before. It's just timeline.to, you then define the identifier, which in this case is the yellow box, and the second parameter are the variables you pass to it, such as the x is 250, rotation is 360, border radius is 100%, duration is 2, and then ease is back, dot, and out. Again, this doesn't matter too much right now, but we're just playing with the way that the animation actually executes. So if we save it now, you can see how it goes from one end to another and comes back. Now, what we can do is we can also say timeline dot to, again, target the same yellow box, and then provide another set of variables we want to apply to this animation, such as x 500, scale of 1, rotation of 360, border radius of something like 8 pixels, duration of 2, and ease of back, dot, and out. Now, if I save this, you can notice that it's yellow and then it goes further out of the screen. I'm going to zoom this out a bit so you can see the full animation. First, it goes to 250, waits a bit and moves to the end, and then it returns. Now, this is a bit similar to using the from and to, or the from to, but what this allows us to do is to add additional animations in the middle. So we can say timeline.to, once again, where we target the yellow box. And this time, we can, for example, do the y of 250, scale of 2, rotation of 360, border radius of about 100%, and duration of 2, as well as the ease, back, dot, and out. Now, if we save this, we have added a third animation to the mix, where now it will actually go down out of the screen, move back, and then it's going to come back again. So these animations are happening in a row, one after another, which gives you a lot of possibilities to control the entire timeline. Now, another thing you can do here is, of course, play and pause it, because you have complete control over the timeline. So let's head over to our play and pause button, which is right here, and let's expand this on-click functionality. We can define an if statement and say if timeline.paused is true, then we want to trigger the timeline.play, and also else vice versa. Then we want to run the timeline.pause. So if we do this and save, now you can click play pause and completely pause the execution of the animation. Then you can trigger it again, and it works. So I think you can see the benefits of running animations within a timeline. You have more control. Now let's move over to the fifth method in the GSAP repertoire, stagger. GSAP stagger is a feature that allows you to apply animations with a staggered delay to a group of elements. By using the stagger feature, you can specify the amount of time to stagger the animations between each element, as well as customizing the easing and the duration of each individual animation. This enables you to create dynamic and visually appealing effects, such as staggered fades, rotations, movements, and more. And of course, you can find more within GSAP stagger documentation. They even prepared a little video. But in essence, it is as easy as using the stagger property. So let's explore it in action by navigating over to the stagger file. In this case, if you scroll down, you'll notice that we don't have a single box with an ID of box. Rather, we have multiple divs that all have the same class name, stagger box. So instead of simply using an ID, we'll use the class name as an identifier. So same thing goes, we can use the use GSAP hook, create a callback function, and then we can use the GSAP.to method. And in this case, we can import GSAP from GSAP. Now, you might say, hey, we already learned to, but we haven't used stagger. Well, stagger is just a property you can apply to any animation. So we'll use to show this out, to explain the stagger by targeting the .stagger -box, and then we can provide the options. In this case, we can do the same thing we've done before, such as Y of 250, rotation of 360, border radius of 100% to turn it into a circle. We can add a repeat of -1, as well as a yo-yo of true. Now, if we save this, you can see they all follow the same animation as we're targeting all of the elements simultaneously. But what if we want them to animate one by one? Well, in that case, we can provide a stagger property of 0.5, let's say. So now we can save it, and you can see that now, after half a second, each one of this animates, one after another. But it doesn't end there. We can also apply more complex stagger properties by defining stagger as an object. Here, you can provide the amount, which is the amount of time to stagger the animations between each element, and we can say something like 1.5. Then you also have access to something known as a grid. Grid selects the number of columns and rows in a grid. So you can say something like 2, 1. Then there's also the axis, and you can choose the axis along which to stagger the animations. In this case, we can say Y, but you could also say X, in which case they all happen at the same time. Next, you can also apply the ease, which in this case, we can do something interesting like circ dot in out, and now kind of they happen in a circle. And finally, this is the most interesting one. You can define the from, which is the starting position of the staggered animation. So instead of starting from the start or the end, we can say center. So this will make it start from the central staggered box. As you can see, now it happens from the start and moves until the end. And you can also see how they're doing 2 and then 1 and so much more. So you have complete control over how you want to stagger your elements. This is great. So now you know how stagger works and how you can use it when you have multiple elements which you want to animate, and let's call it a dance of sorts. The next feature on our list is the scroll trigger, which is used to trigger animations based on the scroll position. So as you scroll, you can animate specific things once you reach a specific point in time. So for example, scroll down to see the animation, and then only after you reach a specific point, we want the animation to start. So let's first open up the documentation page, and I always advise you to read the docs for anything you're doing. There's also a quick video right here. And the simplest way is to attach a specific target, which when it enters the viewport or the screen, then the animation happens. Or you of course have much more control over when the animation triggers. In this case, we can go back and go to GSAP scroll trigger, and let me show you how to implement it. First of all, it's very important to note that GSAP scroll trigger is a plugin, which means that we have to initiate it at the top by saying import scroll trigger from GSAP all, and then you can do GSAP, which we have to import from GSAP, .register plugin, and then you pass that scroll trigger. This will make it work. Next, with triggers, you also have to define a reference. So we can say scroll ref is equal to use ref coming from React. This is not GSAP related, this is just React. Then we can use the same old use GSAP hook coming from GSAP React, which we can define like we have done so far. Now, in this case, if you scroll down, you'll be able to see that we have some boxes right here. Now, if you scroll down, let's attach that ref to our boxes. So if we scroll here, you can see that we have two boxes, the scroll pink and scroll orange, and we can attach a ref to this div wrapping both of them by saying ref is equal to scroll ref, like this. Now we can scroll to the top and we can start animating. So first, let's get access to those boxes by saying const boxes is equal to gsap.utils.toArray, and to it we pass the scroll ref .current.children. So this is how you can get the children using a React ref. Next, we can also run the boxes .for each. So for each box, we want to do something, and that something will be a simple GSAP.to animation where we target each individual box, and for each one, we apply some specific properties. In this case, we can say X is something like 150, rotation is 360, border radius is something like 100%, scale is 1.5. We have learned that already, right? So now if we scroll down, you can see that they basically already turned into circles, even though we didn't see it at all because we were at the top when the animation was happening. Not too useful, right? Typically, you want to have some animations when you scroll up to a specific point. Like if we're here, we can see it, sure, but the user will come from top and then we'll start viewing this at the bottom. So this is where scroll trigger animations come in. To this GSAP2 property, we can apply a scroll trigger, which is an object to which you can pass a trigger, and then this one will be a box. So one specific box comes into view, we want to start the animation. Let's see that once again. If I start scrolling down, already it's a circle, but that's because we're missing something important. We're missing the start of the animation, which we can define as bottom, bottom. So when the bottom of the box hit the bottom of the viewport, then it will animate. And we can also define when it will end. And it will end when the top of the box hits 20% of the viewport. We also have something called scrub, which we can set to true, which makes the animation smooth. And below the scroll trigger, we can also define the ease of power1 dot in out. And the reason why the scroll trigger animations are not working is because I misspelled it as scroll instead of scroll with a double L. So if we fix this, now check this out. I'm going to scroll to the top, reload the page, and start scrolling down. So now, as we enter the viewport slowly, you'll see how this starts as a box because that's what its styles say by default, and then slowly it starts moving to the right, and it starts applying the rotation, border radius, and scale as we scroll. Check this out. Interesting, right? And also, it goes back immediately. Now, another thing is that since we're mapping over those boxes, we can apply a bit of math to each one. So instead of just moving it x 150 for each one, we can multiply that by boxes dot index of a specific box. So this will already apply it a bit differently because the second one has an index of 1. And we can also give it some default value like +5. So now if we start scrolling down, you can see how nicely they animate and exit out of the screen. We come back, they are back. And of course, you can keep playing with these value like top 30%, which will make them go away much sooner, or like something like top 10%, which will make them in the screen for a longer period of time. It's up to you to start playing with this. And I just noticed we don't need a comma right here. It's just bottom, bottom. So like this, yeah, that's great. Another thing you can add when you're animating using the scroll trigger is if you go all the way to where you end the use GSAP function, which is here, you can also provide a second parameter of scope is scroll ref, like this. That way it will know exactly when the animation has to happen. So now I'm sure you have already noticed how useful GSAP is, specifically simple properties like GSAP2, staggering, and so on, but only when you pair it with scroll triggers, which we'll do a lot within this video, and it's also covered in a lot of depth within our ultimate guide, which you can find in the description down below, completely for free. You notice how it all starts coming together when you combine all of these properties. And finally, we have GSAP text, where I'm going to teach you how to animate text elements with GSAP. So to animate text, you can use all the methods we have explored so far. The only thing you have to do is integrate the text plugin. You can see it in the docs. Basically, you can add the GSAP2 and then add the text you want to animate. You also have some special properties for animating text elements. So let's head over to text. And you can see an H1 here that says GSAP text, but it's nowhere to be found on the screen. It's kind of like it's being hidden, right? And that's because it is. At the start, the opacity is 0. So let's go ahead and animate it in. We're going to use the same old tips and tricks like use GSAP coming from GSAP React, where we have our callback function. Then we will define GSAP.to, which we have to import from GSAP. We target the text element by ID of text, and then we provide some properties like ease, which will be power1.inout. Once again, you can go without this, or you can find the ones that you like and then add different eases. And then I'm going to add opacity of 1 as well as y of 0. So this is nothing new, right? We're just changing some properties using GSAP2, and you can see how nicely it slides in. Great. Now, let me also teach you how to animate the paragraph. You can see this para class name right here. It combines all of these properties that you can see. So let's add a gsap.from2 in this case, and we can target the .para, which is the paragraph. And then, as you know, with from2, you have to define two different objects. And at the start, this text is visible. We didn't apply an opacity 0 like we did here. So you can apply it here in from. Opacity 0, y of 20. And then, of course, it's going to break until you provide a second object where you can reset the opacity to 1 and y to 0. So now you can see how nicely it fades in. We can also apply other things we learned, such as the delay between the elements, as well as the stagger of 0.1. So now different paragraph elements are going to animate one after another. And with that, we came to the end of this little GSAP workshop. All right, you just flew through the fundamentals of GSAP and saw firsthand how quickly you can make things on your site move. And we're just getting started. Now it's time to put your skills to the test by building a real project from scratch, a visually stunning landing page for a brand called Mojito Cocktails. We're talking scroll-triggered animations, immersive parallax effects, and elegant transitions that'll have your site looking like it belongs on awards. We'll build 4 additional sections loaded with even more animations. You can watch the whole thing on jsmastery.com with interactive live demos for hands-on experimentation, bite-sized challenges to reinforce key concepts, quizzes designed to lock in your learning, step-by-step Git commits to track your progress clearly, and deep dives later on. So first, you build this entire cocktail website to get you going with GSAP. But then we take a step back and dive under the hood of how GSAP works and how you can become a top 1% GSAP developer. The link is in the description. But if you want a taste, let's bring this project to life first, starting with setting up the app. Before we start developing this amazing animated GSAP Cocktails landing page, I first want to go over the tech stack that we'll use to make it happen. Of course, the star of the show will be GSAP, which as of recently became completely free for everyone. It is one of the only and the best JavaScript animation libraries out there. And in this video, you'll learn how to build this website using it. But if you want to take it to the next level, go ahead and check out the Ultimate GSAP course, link down in the description. Now, I invite you to use any framework or library you want to build this application. For example, you could use Next.js, or maybe you could use Vue. But in this case, I'll be using React. Either one works. You can follow along and build it using your library. But the simplest way to spin up a React application is using a build tool called Vite. So head over to vite.dev and click Get Started. And then if you scroll a bit down, you'll see the installation command to spin up your project. So let's copy it and head over within your IDE. In this course, I'll be using WebStorm. WebStorm is a powerful IDE that as of recently became completely free for non-commercial use. Before, you needed to pay a lot of money to be able to get all the features that you can get out of an IDE as to when compared to a simple text editor, but now you can download it completely for free and follow along and see exactly what I'm seeing. So later on, if you see some cool feature right here built into my IDE, well, you know it's coming from WebStorm. Oh, and with WebStorm, you can also get access to Junie, which is a smart coding agent that does more than just recommend the next line you want to type in. It is so smart that it can modify the entire code base given your prompt, increasing your productivity more than ever. Once again, the link for Junie as well will be down in the description. I'll be using it later on throughout this course, so it might be good to just download it right away. With that in mind, I'll just paste the npm create vite add latest command into my terminal. I just created a new empty folder on my desktop and called it JSM GSAP landing. And I'll add the / at the end because I want to create a new React project within the current repo. So press enter. It'll ask me whether I want to install the following packages. So I'll say yes, and now we'll have to answer a couple of questions. First, I'll say ignore files and continue. Then I'll choose my framework, which will be React. And then we have to choose the variant that we want to use. In this case, I'll go with JavaScript. And that's it. Now we just have to run npm install. And as you can see, my WebStorm automatically tells me that it can do that for me. And once the packages are installed, you can just run npm run dev to spin up this project right within our localhost 5173. If you do that, you should be able to see just a very simple Vite and React boilerplate. But now we want to clean it up so we can create a clean slate so we can start working on our animated GSAP website. So back within our code, let's remove the existing app.jsx within the source folder. Also remove the app.css file and remove the entire assets folder since we won't be needing these default assets. Also, remove all of the styles from index.css because we're going to replace them with our custom Tailwind classes very soon. And now, just so we can show something on the screen, create a new app.jsx and run RAFCE right within it, which will quickly spin up a new React arrow function export component that looks something like this. If you did that properly, back on your localhost 5173, you should be able to see just a single app text. Now, let's also install the most important dependency needed to run this project, and that is, of course, GSAP. So I will actually open up a new terminal window, and I'll call it terminal, and I'll rename our first one to app, because in this one, we want to keep running the app, and here we want to run additional commands. So let's install by running npm install the GSAP library, add gsap/react, and we'll also need an additional library called React Responsive, which will help us with the animation logic and the layout behavior based on the screen size. And press enter. This will now install these packages, and you can immediately notice that GSAP is super lightweight because it got installed in 1 second. Now that we installed GSAP, we have to put it to use. And we can do that by using its 2 plugins. So right here on top of our app, I will say import, and I'll get here the scroll trigger as well as split text plugins coming from GSAP all. And we want to register these within the app by saying gsap.register plugin, and then we want to pass the scroll trigger as well as the split text. We want to do it within the app because these GSAP plugins aren't automatically active. You have to register them. And this line makes sure that both plugins are ready to use globally across your application. You only need to do this once, so putting it in the app file is a great choice. The scroll trigger plugin will allow us to animate things based on the scroll position, like pinning, scrubbing, or triggering, and split text will allow us to break text into individual words or characters for detailed text animations. Great. So now that the GSAP basics are set up, let's also set up Tailwind. TailwindCSS is a utility-first CSS framework packed with great utility classes that are going to simplify our styling, but still allow us to make our application as unique as ever. So let's follow its getting started guide to quickly install it. We're using Vite, so that is super simple. We just have to copy this command and paste it into our terminal. That is npm install TailwindCSS and add TailwindCSS/Vite. Once you install it, you want to configure the Vite plugin by modifying the viteconfig.ts file. So let's copy this import and let's head over into vite.config.js. And alongside the React plugin, right after it, we also want to add Tailwind CSS, which is coming from TailwindCSS/Vite. After that, we want to head over into our index.css and say add import Tailwind CSS, which will allow us to use all of the Tailwind styling functionalities. And to test whether the Tailwind CSS installation is working, Within this div, let's create a new h1 and give it a class name of something like text-3xl and text-indigo 300. And we can make it say something like hello GSAP. Now, just before we test it out, let's also make sure that we have access to this GSAP coming from the GSAP library. There we go. And back within the browser, you should be able to see a text that is larger, colored, and says hello GSAP. Let me zoom it in for you so you can see it a bit better. Perfect. Now, to be able to style the rest of this application more easily, we can immediately make our life easier by creating a couple of classes called utility classes. See, a utility class is something that looks like this. You say add utility, and then define the name of that class name, such as Flex Center. Then you apply a specific number of class names that would be added together as soon as you use this Flex Center. For example, you want to make it a Flex Container, Justify Center, and Items-Center. So if you do this, head back over into App, and now give this div a class name of Flex Center, which is not a default class, but it is a utility class we have added right now. You can see that now it's fully centered. So to make the styling of our application more convenient, in the description down below, I'll provide a link to a video kit for this project. Then, if you scroll a bit down, you'll be able to see a complete index.css file. Copy it and override your current index.css. First, we import a custom font from Google Fonts at the top. Then we import TailwindCSS, and then we add an additional font face, allowing us to load a local font from our public folder. Then we give it a name so we can reference to it later on within our TailwindCSS classes. I'll show you how we can add it to our public folder very soon. After that, we define a theme. You can define different colors, such as the primary yellow color, or maybe an off-white. And then we set different fonts. We do a bit of a cleanup on the HTML and body tags, where we set the width to 100, change the background color to black and the color to white, and set the scroll behavior to smooth. And then we have a bunch of these utility classes, which are on their own, not providing anything special, but are making the styling of our application simpler. For example, if we want to apply a gradient with all of these classes, we just have to say text gradient. There are a couple more of these ones, such as the masked image, and then the components themselves. So if we want to automatically style a nav, as soon as we use this tag, we'll automatically apply specific class names to it, and the elements within it as well. For example, the p tag within the navbar will automatically have this font applied. As we use some of these classes later on, such as this noisy class, which will add a background image that'll make the background feel a bit old school, well, I'll show you that we use this class and then explain exactly what it is doing. But for now, what matters most is that you have access to this index.css file right here within your code. Now, if you close it and get back to your app file and give this div an additional class name of h-, which stands for height, but then if you use square brackets, we use this in Tailwind when you want to provide a custom value, such as 100 VH, which stands for full vertical height. If you apply this change and save it, and then go back in the browser, you should see that now our text should be very big. Well, at least it would be big if you zoomed in at 500 like I did, and it should be entirely centered on a dark background, which means that you have successfully implemented all the styles and set up the initial configuration of the application, which means that immediately in the next lesson, we'll be able to dive into the first part of the UI, which in this case is a simple navbar. But now that you have actually set up the application, that's something to be proud of. And to start forming good habits, it is recommended that we always commit something to GitHub, no matter how small the feature is. So since I want to teach you the best practices, let's actually create a GitHub repo for this project from the start. Head over to github.com/new and create a new repo, which I'll call GSAP Cocktails. Make it public or private, whatever you prefer, and click Create Repo. Next, you'll have to follow the following steps in order to be able to push it. But I think we only need to copy this get remote at origin because it contains our unique URL. So copy this entire line, go back to your application and open up your terminal. Here, type git init, git add dot, git commit -m, initial commit, git branch -m main, then paste the get remote at origin, and finally say git push -u origin main, which will push the code you have so far on your branch. So if you head back over to GitHub and reload the page, you can see that your code is now live right here under the initial commit. Now, we're doing this for a couple of reasons. First of all, to create good GitHub habits where you can actually push your code after every feature. Second of all, if some recruiters take a look at your projects, it's not good to just see a final commit with all the code. Rather, they want to explore the commit history to see you have actually been committing consistently, which means that you yourself have developed the project. If you do it properly, it should look something like this, where for my previous project, I have about 20 commits where you can see where we have implemented every single feature. And another reason why I'm doing this is because on jsmastery.com, you can watch this same course, but split into lessons. So if you find this course and click resume where you left, at the bottom of each lesson, such as this project setup we're on right now within YouTube, you can check out the lecture summary, the transcript, some notes, but also a special commit for each one of the lessons. So you can know exactly which code has to be implemented for that lesson. That'll look something like this. Like if you implement a navigation bar, you can see that we're only adding the navbar and nothing more. That way you can follow along, and even if you get lost, you'll be able to get back on track. Oh, and by the time you're watching this video, the ultimate GSAP course will have been released. So go ahead and check it out, as it might provide you some additional insights into how GSAP works, and then you can build out this cocktails website and truly understand the behind the scenes of the animations that GSAP powers. So great job on completing the most boring part of this course, the setup. Now immediately in the next lesson, you'll develop your first UI component. Let's start with the first piece of our UI, the navbar, the component that will set the stage for the navigation and include a smooth scroll animation powered by GSAP. So create a new folder right here within the source folder and call it components. Then within components, create a new file and call it navbar.jsx. And within it, you can run rafce to quickly spin up a new navbar component. Now that you've created it, head back into the app.jsx, clear this div that we have right now. Instead, create a main tag, which means that this is the main part of our content. And within it, just render a self-closing navbar component coming from ./components/navbar. If you've done that properly, you should be able to see just the navbar at the top left of your browser. Now I'll put my browser side by side with my editor so we can see the changes that we make live. Let's head over into that navbar, turn it into an HTML5 semantic nav tag with a div, and within this div, we can render an anchor tag that'll have an href pointing to #home. So once we click on it, it'll lead us to the hero section. I'll give it a class name equal to flex, items-center, and a gap of 2. And right within it, we can render a p tag that'll render the name of our imaginary cocktail bar. For now, I'll do something like velvet pour. There we go. And this will be a part of our logo. I'll add the logo soon, but before that, head over below the anchor tag and create a new UL, an unordered list. Within it, open up a new dynamic block of code and create an array that'll have different objects within it. Each one of these objects will have a title of something like about us, and it'll also have an ID so that we can scroll to it, which will be something like about. And now we can create a couple of these objects right here, each one within its own line. But if you do that, you'll quickly notice that your application or your code would get pretty cluttered. So instead, I like to do those within a new file called constants. So right here within the root of our application, create a new folder and call it constants. And within constants, create a new file called index.js. And within it, we can create a new const nav links and make it equal to an array where we can have those multiple objects, each one having an ID of cocktails in this case, as well as a title. And now we can do the same thing for example, the about section. So ID is about and title is about us. Now you want to export that just so we can use it within the other file. And if you head back over to our navbar, now you can just simply say nav links. Make sure to import it from constants index.js, .map, and you can now map over each one of these links. And then for each one, you can automatically return an li, a list item. Now, what do I mean by automatically return? I mean using parentheses right here instead of curly braces. Because if you used curly braces, then you would have to add a return keyword right here. But if you use just the parenthesis, it'll return this automatically. This li, since we're mapping over it, has to have a key, and the key will be equal to link.id because it's unique. And within the li, we can render the anchor tag with an href of dynamic template string of hash, and then the link ID. And it'll render the link.title within it. So if I save this, you can see that now it says Velvet Pour, and we have cocktails and about us, which are the two links within the nav links array. Now, on top of just having the two links, we want to have more of them. And just so we don't have to type all of them by hand, I actually want to provide you with the complete constants file. So open up the video kit, scroll down, and there, just below the index.css, you'll also be able to find the constants index.js file. Copy it and paste it right here. You'll notice that alongside the nav links, which we have right here, we also have a couple of other things that we might want to render later on, such as the cocktail lists, mocktail lists, profile lists, and feature lists. These are all just different arrays of text that we want to display on our landing page, just so we don't have to type them by hand and put them within our JSX. We're keeping them in one single place so that if you maybe give this website over to a cocktail website owner, they can come into this file and just change their opening hours themselves. They don't necessarily have to dive right into the code and mess with the code right here. Perfect. Oh, and within this video kit, you can also find a Figma design. So go ahead and click on it, and you'll be redirected to a Figma design that our JSM designer has prepared specifically for you completely for free, where you can find the entire design of this application right here, and you can go ahead and develop it on your own if you want to, or you can follow along with this course. One thing that you'll notice right here is that this website has a lot of assets, starting with the small ones, such as this logo right here next to the Velvet Pour, which is the title of the company on the top left. Also, these leaves, maybe this primary video that we want to animate, as well as some other leaves and more photos that we want to display of just people having a good time and enjoying our cocktails. So in order to be able to get all of these assets, you could go ahead and explore the design, click on it multiple times until you get to the actual image, and then you can just export it as a PNG, JPEG, or something else. That's totally okay. But these assets have long names, and it's easy to get lost into all of this naming, and it will take some time. So I took some of my time to save the time for you, and I collected all of these assets into a single zip folder that I shared within Google Drive. Once again, the link will be down below the lesson or within the video kit. So just go ahead and download it. Once you do that, unzip it, and you'll see that in there you have a couple of different folders. Just take this public folder and drag and drop it right within your source folder. Once you do that, you'll be able to see the different fonts that we're using, as well as some images that we'll use later on within our application. So if you head back over to the navbar, right within our p tag, where we have our text, we can also render an img with a source of /images /logo.png, and we can render an alt tag of logo. If you do that, you'll notice that you can't access your logo just yet. That's because in Vite applications, the public folder should be within the root of the application, not within the source folder. So just delete the default one that is already over there, and then move this new one into the root of your application. As soon as you do that, you'll see an error. So head over into your app terminal, stop it from running, and then rerun it again by running npm run dev. As soon as you do that, your assets will be taken into account, and now you should be able to see a little logo right here on the top right, and not just a broken image. Also, you can head over into your index.html, and instead of saying Vite SVG, you can say images, logo.png, so that your favicon gets updated as well. And there you have it. This is our navbar. If you expand it, you can see that it looks great on desktop devices as well. But now what we have to do is that when you scroll, we actually want to apply this glassy background so that when the text goes over some other text, it is still fully visible and not interrupting our viewing experience. Of course, we won't be able to test it just yet because we cannot scroll as there's no other content, but I can show you how we can implement it. And this is actually going to be the first time we're going to use GSAP in this application. Right at the top of our component, I'll say use GSAP. And you can import this from @GSAP React. This is a helper hook that allows us to very easily use GSAP within our application. You can define a callback function right within it, and then you can define a timeline by saying const nav tween. Now, why did I call it a tween? Well, tweening in animation is short for in-betweening, and it's the process of generating images that go between different keyframes. That's a very technical explanation, but it'll start making more sense as we start implementing it. And of course, if you want to truly understand how it works behind the scenes, then go ahead and check out our GSAP course, link down below. But for now, I'll also get access to the original GSAP library by importing GSAP from GSAP, and then I'll say .timeline. So we're starting to build a GSAP timeline that will be based off of a scroll trigger, and the trigger will be the nav. Specifically, we'll start it from the bottom to the top. What does this mean? Well, these two properties control when the scroll animation starts and ends. And the first part is referring to the element's position, so the position of the nav, and the second one is referring to the viewport position. In this case, when the bottom of the nav bar reaches the top of the viewport, that's when we actually start applying a specific class. So now that we know when the animation will start applying, we can say what will happen. So I will say nav tween dot from to, and this from to is a method that ensures that the nav always starts from a known style, which is going to be transparent, and it ends with a specific effect. So the first parameter is the target that we want to animate. Then we have the duration. Then we have the from variables, the to variables, and the position. So I'll say nav. Then I'll say that we start with a background color set to transparent. And then I will say how it will end. We want to end it with a background color of hash 0000000, which is black, but I'll also end it with 50, which in hexadecimal is 30%. So it'll have the opacity of 30%. I'll also give it a background filter, which will be set to blur 10 pixels. And finally, I'll give it a duration of 1 second. And you can also choose the ease, which I'll set to power1.inout, which is how that animation will actually play out. This will create a smooth animation. Now, it looks like I didn't properly close this background color, but as soon as I do that, you can see that it's no longer complaining, and now it's pretty clear what's happening. So later on, once we add additional sections, and when we allow the user to scroll down, as the bottom of the nav bar reaches the top of the viewport, that's when it'll actually turn from a transparent background to a dark, blurry background that allow us to read the text, even though it's showing on top of the other elements. Great. So now that we have the nav bar, let's move over to the most important part of this course, and most likely the reason why you clicked on this course in the first place, and that is the hero section with this sick animation where the ice cube falls into the cocktail and animates as we continue down the screen. let's get started focusing on the most important section of this course, this animated hero section. First, we'll start just on the layout and the structure, and then later on, we'll animate it using GSAP to create this smooth and interactive experience. So back within our code, create a new component and call it hero.jsx. Run RAFCE right within it, and then just import that hero section right within our app below the navbar by saying hero and auto importing it right here. WebStorm does that nicely automatically for me. Now let's develop the structure of the hero section by wrapping it in an empty React fragment, and then within it, creating a new section with an ID equal to hero so we can scroll to it, and a class name equal to noisy. As you can immediately see, this noisy class name adds a background image that makes it seem a bit old school. So if you want to see how this noisy exactly works, head over into our index.css, and you can see that it is just applying a full-size noise background image. Within it, we can render an h1 that will have a class name equal to title, and it can be the name of a cocktail, of your bar, or whatever you want it to be. I'll go with something like mojito. Sounds interesting and looks good. Then, right below it, I'll render an image with a source of /images /hero left leaf.png with an alt tag of left leaf and a class name equal to left leaf as well. Now you can see that leaf right here at the bottom on mobile devices. I want to duplicate this image right below, and what I'll do is just rename all of the keywords to right instead of left. So hero right leaf, the alt tag, and the class name of right leaf as well. If you do that, you'll see another leaf appear right here. Next, below these images, let's render a div that'll have a class name equal to body, and within it, another div with a class name equal to content, because we're going to put the majority of our content within this div. So let's create another div that'll help us with the layout. So we can give it a class name of space-y-5 to create some spacing in between the elements. It'll be hidden on small devices, but it'll be showing on medium and larger devices. So we can set it to block. Within it, I'll render a p tag of cool, crisp, and just classic. And another p tag below it with a class name equal to subtitle. That'll render a text of sip the spirit with a break of summer. Yep, that definitely sounds good. Now we cannot see it on a mobile device, but if we expand it just a tiny bit, you can now see cool, crisp, classic, sip the spirit of summer. And on larger devices, it'll actually get moved to the bottom left. So we have enough space to show our primary part of the page. Great. So now let's head below this div that has the space of y5, and let's render another div that'll have a class name equal to view cocktails and a p tag right within it that'll have a class name of subtitle. And here we can put some text. Now, I don't want to just imagine some text or generate it using AI, so I'll head over into my Figma design and just copy this piece of text that I can see right here. Every cocktail on our menu is a blend of premium ingredients, creative flair, and timeless recipes designed to delight your senses. This wasn't written by ChatGPT, not at all. And below this p tag, we can render an anchor tag that'll have an href pointing to hash cocktails, and it can say view cocktails. So now if we go back, you can see that we have both the left and the right side, and this will eventually lead to the bottom page, but we have still left some space for the primary part, which is that drink. Now, before we show something right here, let's first focus on the animations. See, if I head over to the final website, you can see that first of all, the primary text animates, then we see the text at the bottom left, and finally then the text at the bottom right. So let's animate it. Right at the top of the hero section, we can use the use GSAP hook. Make sure to import it from GSAP React. Create a callback function. And as the second parameter, give it an empty array, which means that this will only have to run at the start. Next, we can define a couple of different animations. First, I'll define one called Hero Split, where we can use the Split Text GSAP plugin that'll break our text into smaller pieces so we can animate them individually. So I'll make it equal to new split text, which we have to import. So I'll say import split text coming from GSAP all. And don't forget to import the GSAP itself by saying import GSAP from GSAP. Perfect. Then I'll say that we want to target the .title class name and we want to split it into both characters and words. So I'll say type will be chars, characters, and words. Now we can do the same for the paragraphs. So I will duplicate this. I will say paragraphs or paragraph split and make it equal to new split text, where we're going to split the subtitle, class name, into just lines. Not characters, not words, but lines. What does this mean? Well, if you take a look at the finished website, notice how we split the first one by each letter, and the other ones are split line by line. So we don't animate the characters themselves, but only line 1, line 2, 3, 4, and so on. Perfect. Now that we have split those characters of the hero section, we can actually apply some animations. So I will say hero split dot chars or characters dot for each character, we want to apply a class name by saying char dot class list dot add, and I'll apply a class of text gradient. This text gradient is a utility class within index.css, which adds a bit of a dark gray color to the text. It'll be applied before animating. So if I reload, you should be able to see that now the letters seem to be a bit more 3D as they have a gradient, very slight one, from the bottom to the top. Now let's use GSAP to animate each one of these characters by saying gsap.from hero split dot chars, and we want to first set where they're coming from. So they're starting from y% of 100. They're starting from a duration of 1.8 with an ease of expo.out. Expo.out gives a smooth, springy feel. And finally, a stagger of 0.006, which means that each character will come in after another, creating a wave effect after 0.06 seconds. So now if I reload, you can see how already the letters start coming from down below and move up, and they align very nicely. You can totally slow this down by staggering them by 1 second, for example. And now you can see exactly what is happening. Although, please, I beg you, never do this in real production websites. Even though it might be cool, you want your websites to feel fast. And if you have long animations, they're just not gonna feel fast. So I found 0.006 or 5 to work very nicely, just so it's visually interesting, but it doesn't negatively impact the user experience. Next, let's animate the lines of text of these paragraphs. So I'll say gsap.from paragraph split dot lines. We want to animate it from opacity of 0 initially, y% of 100, duration of 1.8, ease of expo.out, stagger of also 0.06, and a delay of 1. What this delay does, and it's super important, is that it means that it'll start 1 second after the headline animation finishes. So now if I reload, you can see that these lines will start animating only a second after this finishes. If you remove the delay, then everything will happen at the same time, which is just too much to see. So we want to delay it purposefully so we have this nice animation. Great. Next, we want to animate the two leaves in the hero section when the user scrolls. But for the animation to trigger, the page needs some scrollable content. So head back over into the app.jsx and let's just add a temporary div with the full height just below the hero section, which will allow us to test the scroll-based animations. So I'll say div with a class name equal to h dvh, which is a full height, and a bg of black. So now you can see that we can scroll into nothingness. This allows us to test the navbar effects that we have, but it'll also allow us to test the scroll on the leaves. So now we can go back to the hero section, and below the animations of the texts, we can add the animation for the leaves by saying GSAP.timeline. This one will be based on the scroll trigger, and we have to watch the trigger on the hero section. So once we reach it, we will start when the top of the homepage hits the top of the screen, and we will end when the bottom of the homepage hits the top of the screen. And we can also add a scrub to this, which means that the animation progress will be directly related to the scroll, which will make it feel natural. So what animation do we actually want to give to it? Well, we can say dot to dot right leaf. We'll give it a y of 200 and 0. And then I'll apply another dot to, this time to the dot left leaf. I'll give it a y of minus 200 and 0 as the second parameter. Now, if you save it and reload, as you scroll down, you'll notice that the top leaf moves up as we scroll, and the right leaf moves down as we scroll, creating this very interesting effect. Pretty cool, right? Almost feels like we're in a jungle. So what we have done so far is animated the title as well as the paragraphs below. We animated the characters and added staggered motion. And then we used the scroll trigger to animate the movement of these leaves based on the scroll. These kinds of animations add polish and elevate the user experience, especially on hero sections where the first impressions matter the most. So I'll go ahead and commit this right now by saying git add dot git commit dash m. Implement the first part of the hero section and git push so that our members on jsmastery.com can follow along without any issues. With that in mind, in the next lesson, let's focus on what matters, and that is animating the actual video on scroll. Let's focus on the most important part of this course, and that is adding the drink animation effect, which is actually just a video that is playing frame by frame as the user scrolls through the page. So in this lesson, I will demystify these complex animations and show you that oftentimes they're basically just very smart ways of using videos or images. And then the final effect ends up looking something like this. So let's go ahead and make it happen. Back within our hero page, we want to render a full screen video. It'll be muted and inline so it behaves well on all browsers and devices. So I'll head below the section that has a class name of noisy, that is this one right here. If I click it, notice how WebStorm automatically selects it right here at the bottom. And then just below it, I'll render a div that'll have a class name equal to video absolute, which means that we don't want it to interact with other elements on the screen, and an inset of 0. Now, this video class name, if you search for it, you'll see that we have actually declared it within our index.css, where we apply a full width, we change the height on medium devices, and we just apply some additional properties such as object bottom and object cover in order to render that video well. Next, right within this div, I'll render the self-closing video element with a source equal to /videos/input.mp4. Why input mp4? Well, because if you head over to public videos, you'll see that this is the video that we have. I'll also make it muted so we don't play any sound. You rarely want to play sounds in your web applications. Sometimes there's good opportunities to do that, but in most cases, just leave them on mute. I'll also say plays inline, so we don't actually show an additional video-like element, like the track bar where you can move through the video or increase or decrease the volume. We want to hide all of that. And I'll say preload to auto because we want it to load automatically as the user opens up the page. And of course, we want to be able to work with this video. We want to do something to it. So we have to attach a reference to it, which I'll call a video ref. Then right at the top of our hero page, I'll say const video ref is equal to use ref coming from React. And while we're here, I also want to figure out if we're on a mobile device. So I'll say const is mobile, and I'll make that equal to use media query, which is this React responsive package we installed before. And I want to give it a max width of about, let's do 767 pixels. So if it's up to that, then it's going to be mobile, else it's going to be web. Now we can head below the use GSAP hook that we have already created, specifically below the GSAP timeline where we have animated the right and left leaves. And we want to figure out where the animation will start and end. So for example, we can say something like const start value, and then we can say that it'll start at center 60%. And we can also say the end value will be equal to something like bottom top. Now, these values will be different for mobile devices because there is less space. So right here, before assigning value, I'll first check whether is mobile is true, and if it is, I'll give it a different value, such as top 50. And same thing for the other one. I will say if is mobile. In that case, I'll say 120%, and then top right here for the second property. So what do these values mean? Well, top 50 means that when the top of the video, always remember that, right? The first property is referring to the element we're animating. So when the top of the video reaches, and then this is talking about the screen, okay? So when the top of the video reaches 50% down the screen, the animation starts. Similarly, when the center of the video reaches 60% down the screen, the animation starts. That is on desktop. In this case, we have the percentage at the start. So this means that when the top of the video goes 120% past the top of the screen, meaning far off the screen, we end the animation. And bottom top means that when the bottom of the video reaches the top of the screen, then the animation ends. We dive much deeper into these values within our GSAP course, but I think this is going to be good enough for now. And now that we know the start and the end values, we want to animate the video. You know how at the start I mentioned Junie, which is the smart coding agent that makes you a more efficient developer? Well, I want to put it to the test right now. So you can download it and follow along with me. The link is down in the description. I'll press Command-Shift-P and then search for Junie, which will open it right here on the right side. And remember how at the start of the video, I said that it's going to be very hard for AI to replicate some of these beautiful animations. Well, that is entirely true if you don't know how to approach them. But as I said, this entire animation is nothing more than animating a video on mouse scroll. So if you know that, then you know that it's not some kind of magic. You have demystified it, and therefore you're able to turn it into something that you can easily develop. And if you know how to approach it, then AI can also do it for you. So let's try to write a task for Junie to do it for us. I'll say create a GSAP timeline that animates the video as the user scrolls through the page. And I think this is good. I mean, this is a very limited prompt. It contains half a sentence, but let's see what Junie can do with that limited info. It'll say sending LLM request. So first, it created a plan, and I want to go over that plan with you. It says check if scroll trigger is properly imported, create a GSAP timeline that animates the video based on scroll, use the video ref, use the start and end values, add appropriate animation properties, ensure that the animation works on both mobile and desktop, add a check, and it's doing all of that in real time, as you can see right here. It's actually animating things and testing whether it works. So we can see the changes right here in real time. The animation code has been updated to use a new video timeline reference, ensuring proper handling of video loading and playback. The video now plays when in view, and the animation is updated based on the duration. Successfully updated, ready to play whenever the user scrolls. And that's it. A GSAP timeline has been successfully created to animate a video as the user scrolls through the page, utilizing the video ref for targeting and responsive behavior. With the start value and end value, the implementation is error-free and all tests pass, ensuring a seamless video experience. Well, we'll see about that. But the actual code is here. So now let's see whether it works. If I head back and reload, you can see that the animation starts automatically. It actually slows down a bit, and that's it. And then it replays. Also, if I scroll down, you can also notice how the glass is getting smaller, and it's actually working incredibly well. But it looks like it wasn't precise enough. We wanted a parallax effect where we control the entire video flow. I'm going to teach you how we can do that. But hey, this might even be better. This doesn't require a user to scroll. Rather, they can just take a look at this amazing animation right here. Still, we want to tweak it just a tiny bit and allow this glass to flow onto the second section and then end the animation there solely based on scroll, not on autoplay. So Junie did an amazing job right here. But now, from scratch, we'll go over it together, and I'll show you how we can make this animation work for our specific use case. In this case, we won't be triggering the hero section, rather, we'll be triggering the video. The start and end values are corresponding to the start and end values we have created right here. And then scrub is turned on, which means that it'll make the video play on scroll. We also want to allow something called a pin to be set to true. This will keep the video stuck on the screen while you scroll. So as you scroll, the video doesn't move, it'll stay in place. Next, instead of using these methods directly on the timeline or calling the .from_to, I will just remove all of these and also remove this update animation when the video metadata is loaded. Instead, I'll just say video ref .current .onLoaded metadata. I'll create a callback function, and I'll have to properly end this part right here. And within it, I'll say video timeline ref .to video ref .current, and we want to change the current time of the video to be equal to video ref .current .duration. So this way, we're updating the current time based on the video duration. And alongside this, I also want to head over to the video and turn off the autoplay that we had here. We also don't need the loop because we're going to move it with the animation up and down. So now, if you head back over to your app, it won't play by default, but as you start scrolling, you'll notice that the glass moves down. But wait, this is looking worse than what Junie did initially. Oh, I think I know why that is. Here, we have to actually create a new variable for the timeline, not refer to the timeline ref. So I'll say const TL as in timeline, and then we'll use that TL right here when you say video timeline ref, just TL.to. This will actually tie the current time with the duration. So if you get back right now and reload the page and start scrolling, you'll see that the animation is being applied on scroll. Perfect. Now, if we compare this with what Junie initially did, well, to be honest, I cannot really tell which one is better. This one actually plays it both on scroll, but then it also continues the animation later on. So once we actually finalize the second section, I think Junie's might actually be better. So Junie has passed the test. But just to stick with our design, I'm gonna bring us back to our final solution. Now, you can notice that on my end, the animation feels very smooth. On your end, it might feel a bit choppy, something like this. And if you use your mouse to scroll, then it depends on how your mouse wheel is actually sending the signals to your computer. If I use the touch bar on my MacBook, it is very smooth, but with the mouse scroll, it is a bit less smooth. So that is the difference. But again, why should we make it feel like it's skipping frames? This is actually happening because most videos only have a keyframe every few seconds. But for scrub-based animations, we need every single frame to be a keyframe. And we can fix that using a free, open source command line tool for processing video and audio files called FFmpeg. So just head over to their website and download it. Once you download and install it, We just have to run one single command. And I'll actually link it somewhere below this lesson or within the video kit. So you can just copy and paste it. Or feel free to type it out by hand. And if you're new to this, don't worry, you don't have to learn this at all. We just need one single command. You don't have to know how to use this software. Now, first of all, you'll have to run this command within where our video is contained. So we'll have to cd into public, and then once again, cd into videos. Once you're there, you can copy it and run it. In my case, it says that the output file already exists and asks me, do I want to override? I'll say no, and you can say the same thing. That's because I already provided this new output file for you, which has one frame attached to every single keyframe, so it makes the animation smoother. So now we can head back over to our hero page, scroll down to where we have the video, and instead of displaying the video's input, I'll display the output.mp4. So if you reload and try to test it, it'll be a bit smoother even with your mouse, but if you have a touch bar or on phones, it'll feel even smoother, which means that the video is now fully optimized for the scroll trigger playback. Now, why are we scrolling this glass into an abyss of nothingness? That's not what we want our user to see. Instead, we want to scroll it into the pricing of other cocktails that we offer, which is this section right here. So let's head back over into our homepage. That is our app right here, and delete this div, which for now just helped us to scroll. But now in the next lesson, I'll show you how we can add the cocktail section. So just remove this div. Let's also commit it to GitHub. First, you'll have to cd 2 times to get back to where our project is. Then type git add dot to stage all the changes, and git commit -m implement hero scroll animation, and then git push to push it over to GitHub. To get started with our cocktail section, let's head over into our components folder and create a new file called cocktails.jsx. Run rafce to quickly spin it up, and then let's import it right below our hero within our app.jsx. So that is cocktails. Perfect. This is how our current animation looks like on mobile. We'll definitely improve it as we go, especially this extra light scroll bar, which we don't really need right here at the top. But for now, let's focus on the cocktail section. So just scroll down, head over into it, and let's start implementing it by turning this div into a section and giving it an ID that we can scroll to. So I'll say cocktails and a class name of noisy as well, because we want to match it with the top section. Next, right within it, let's also render an image with a source equal to /images /cocktail left leaf.png with an alt tag of left leaf and an ID of C as in cocktails left leaf. That'll look something like this. Then just below it, I want to duplicate it and create one for the right leaf. I'll call it R leaf and C right leaf. As you do that, you won't see any changes. There's still going to be only the 2 leaves that we implemented before, but none on the cocktail section. That's because we haven't yet properly animated them and put them where they need to be on the screen. But for now, let's focus on the list of the cocktails. So I'll head below this image and render a div with a class name equal to list. And within it, I'll render another div with a class name equal to popular. Within it, I'll render an h2 that'll say most popular cocktails. And then below it, I'll render the UL where we can map over those cocktails. So within this UL, map over cocktail lists.map. And this cocktail list is coming from our constants where we have all the most popular drinks. So I'll map over each drink. And for each one, I will automatically return an li, which is a list item, with a key of drink.name. And then within it, I'll render a div with a class name on medium devices margin E, which is inline end of 28. When you want to position something in the ends of the screen, I found this property to position it very well. Then we want to render an h3 that will render the dynamic drink name, and a p tag, which will render the drink.country, so where is it from, and drink.detail, so some more details about the drink. Finally, below the div, I'll render a span with a dash or a line, and then I can render the price. I'm noticing that we're mentioning drink one too many times, so we can just destructure everything from the drink, such as the name, country, detail, and price. And now you don't have to mention it multiple times. You can just say what you want to get from it. If you do that and save, you'll see that now it looks something like this. For example, we have Chapel Hill Shiraz, which is about $10. Not sure what this one is. Oh, it's a bottle. Okay. But even though it's a bottle, it's still very expensive. For that kind of money, maybe it would be better to just head over to jsmastery.com and get yourself a monthly subscription instead of spending money on cocktails. But hey, to each their own. And here I will end this div of popular. But what we can do now is just duplicate this entire div. And for this one, I'll call it loved. And I'll say most loved. Mocktails are like cocktails, but without any alcohol in them. So basically like sodas. And I'll map over the mock tails list. I'll also extract all of the properties, and I'll always make it just ME28. No need to do it only on medium devices. And now you're gonna end up with something that looks like this. Now, of course, this looks so much better on larger devices. So if I head over to tablet, you can see that now we can actually see the menus appearing on top left and top right of the end of the animation. And the leaves are right here at the bottom left and bottom right, but they're not being rendered properly. That's because I misspelled the cocktail right here. So if I spell it properly, you should be able to see two huge leaves appear at the bottom left and bottom right. But as we applied a little animation to those two so that they appear like a parallax moving up and down, we can also apply a little animation to those two at the bottom. So let's actually do that to recap our understanding of GSAP. See, in React or Next.js applications, you can use GSAP through the helper libraries. For example, a library that exposes a use GSAP hook called @GSAP React. Still, you also need to import the original GSAP library from GSAP, but the GSAP hook makes it easier to use. So you just say use GSAP, you declare a callback function, and you close it right here. Within it, you can start defining your timeline, which you can then move up and down. So say const parallax timeline is equal to gsap.timeline, where you can define the type of trigger for that application. In this case, I'll say it's a scroll trigger, where we will trigger the cocktails section. So here, we want to say that we want to start once the top of the section reaches about 30% of the viewport or of the screen. Similarly, we want to end the animation when the bottom of the cocktails screen, or hash cocktails, reaches about 80% down the screen. And we can turn on the scrub to be true, which means that we want to animate it on scroll. The timeline just defines when the animation will happen, but we haven't yet said what will happen with those leaves. And by the way, if you're wondering how I came up with 30 or 80 or top or bottom, it was just a bit of trial and error. You have to play around with it and see what works. So now that we have this timeline, I'll say parallax timeline dot from. So we move it from what specific class name? From C left leaf, and we want to give it X is -100 and Y is 100. So we move it to the left on the X-axis and 100 pixels up on the Y-axis. And we also want to apply another dot from, this time for the C right leaf, and X is going to be 100 and Y will be 100. So they're going to move in the opposite directions. Basically, we're targeting those IDs that we have given them right here. So now if you scroll down, and if you scroll very slowly, notice how this one on the left comes up first, and then the one on the right also comes up. So it's like you're moving your cocktail into a jungle. And that's it for this parallax scroll on the leaves. These subtle movements like this make the page feel more alive without it being too distracting. So let's check it out one more time on desktop. we can see all of the nice animations, particularly the one where we animate each letter of the word mojito. And then as we scroll down, the ice falls into the glass, and we can see more cocktails that we can order. And then the bottom leaves appear, greeting us into the jungle. So amazing job on finalizing two super exciting sections of the cocktails website. Let's not forget to commit it. So I'll head over here and say git add dot git commit -m implement cocktails section and push it. And if you want to quickly deploy it, head over to vercel.com and add a new project. You'll see that GSAP Cocktails has had some changes, so you can just click import. It'll automatically recognize that it is a new Vite project or whatever other framework or library you used. You can also choose your project name right here, and you can just click deploy. Now it'll take a couple of minutes for the project to be deployed, and then you'll be able to check it on the internet and share it with your friends or put it on your portfolio. Check out these animations on top. You were able to see some light if you were fast enough to spot it, and it looks like our project got successfully deployed. So click on it right here. In my case, it's live on this URL. For you, it's going to be something different. But what matters most is that now you can copy that URL and share it with your friends and potential employers, or just put it in your portfolio. Okay, so now that we're here, let's see if it still works exactly like it did locally. If I scroll down, the ice still falls into the glass, and we can see the prices, and we're in the jungle. This works great. On mobile, it looks like this. The text is still fully readable. You can quickly scroll to it by clicking here. And we do have some extra space right here, but as soon as you start scrolling, that space is filled with these leaves, and then we can see the cocktails. Of course, applying GSAP animations to screens of different sizes, such as mobile or tablets, is a whole other game, because we have to know exactly how to apply a specific animation so that it works on that specific device. And of course, that's covered in a lot of depth within the Ultimate GSAP course. Let's get started working on the About section of our cocktails page. In this one, we'll have a little title right here saying that we pay attention to every detail, and then say a bit more about how we serve our cocktails and who do we serve them to, as well as show some nice graphics of people having fun in our bar. And of course, this will come with a great animation. So first the title will animate, and then after the title, we'll get all of the images one after another. So we can get started working on it by creating a new component within the components folder, which I'll call about.jsx. And I'll run RAFCE to quickly spin it up. We can immediately import that right within our app below the cocktails. So I'll say about and end it right here. And as soon as you do that, we now have this new section right here below the drink. So let's develop its UI by giving this div an ID of about so we can scroll to it. And within it, we can create a new div with a class name equal to margin bottom of 16, on medium devices, padding x of 0, and usually padding x of 5. Then we can render another div right within it with a class name equal to content. And then within the content, we can render another div with a class name equal to, on medium devices, call span of 8. So we can prepare some space for this heading text that we'll show right here. And then we can render a p tag that'll have a class name equal to badge. And it'll say best cocktails. And below it, we'll render an h2 that'll say where every detail matters. And then we can also render a span element that'll just render one dash with a class name of text-white. Then let's actually space this out nicely. So after the dash, still within the h2, we can say from muddle to garnish, which is just some cocktail jargon saying that we'll prepare everything. Now we can go below this div, and we can create one more div just below it with a class name equal to sub content. But I can already see that something is wrong here, and that is that our cocktail drink video is actually moving down. Oh, no, never mind. Now it's good. So let me just reload. And as I scroll now, it should kind of get stuck right here, and then we should have a clean section. which allows us to focus on the sub-content. So within it, I'll create a p tag, and here we want to display some text. Now, the simplest way for me to get that text is right here from the design. So I will copy this part where we say that every cocktail we serve is a reflection of our obsession with detail. Then, right below this p tag, we can render a div, and within that div, we'll have another p tag with a class name equal to, on medium devices, text-3XL to make it very large, text-XL typically, and font-bold. Within it, I'll display a span element of 4.5, and then outside of it, out of 5. And then below this p tag, I'll render another smaller text, so I'll give it a class name equal to text-sm, text-white 100. And if we have done that properly, we can enter a piece of text that says more than, and then we can type a specific number of customers. Perfect. Now on our current website, you should be able to see something that looks like this. But of course, let's focus on the grid where we can display additional images. So I'll head below a couple of divs actually. 1, 2, 3, 4. So we're gonna exit this sub-content right here. And then here we want to display another div that'll have a class name equal to top grid. Within it, I'll display a div with a class name equal to, on medium devices, call span 3, with a div that'll have a class name of noisy, and it'll be self-closing. And then we can render an image that'll have a source of images, abt, so that's the about section, .png, but make sure to say abt1 because we'll have multiple, with an alt tag of grid img1. Now, if you save this, you should be able to see this little image, and if you remove the noisy class, it'll be in full clarity, but we do want to have this special bar type feel. Now, we can duplicate this div a couple of times. So I'll take this div, duplicate it once, and one more time, and I'll space them all out nicely within this parent div that we have, the top grid. In the second one, I want to say call span 6, so it'll be taking more space, and I'll render the about image 2. And then for the third one, I'll say call span 3, about image 5, and save it. And now we can see 3 of these different images. Now I'll create another div that'll have a class name equal to bottom grid, and within it, I'll duplicate one of these divs that has the div and the image inside of it, and I'll say call span 8. So this one will be long. It'll render the about image 3, and just below it, I'll duplicate it once again, and I'll render another call span 4 with the about image 4. Why do we have 8 and 4? That's because the full width is 12. So in this case, we have 3, 6, 3, which is 12, and here we have 8 and 4. And if we save this, on mobile, we show all of them one after another, but desktop is where this truly shines. So as we scroll down, here you can see this new layout grid that we created. But now is the time to animate it so that everything fades in naturally when the user scrolls in view. And at this point, you should already have a pretty good idea of how we can make it happen. Right at the top of this component, I'll use the use GSAP hook by saying use GSAP coming from GSAP React, and I will just open up a new callback function within it. Then we can start defining our different animations and timelines. First, I want to split the title into words. So I'll say const title split is equal to split text dot create, and we want to call it about h2. So basically here we're targeting the h2 element inside the about div, and we want to split it by the type of words. Now don't forget to import GSAP coming from GSAP, as well as import in curly braces split text coming from GSAP all. We also need to create a timeline that allows us to choose when we start with the animation. So I'll say const scroll timeline is equal to gsap.timeline. It'll be a scroll trigger animation, and the trigger will be attached to the about element, so to the entire section, And we'll start it when the top of the About section reaches the center of the screen. And now we can start animating it by saying scroll timeline dot from title split dot words, and we want to give to it some initial styles, such as it'll start from the opacity of 0. It'll last for 1 second. It'll start from the top, so Y% will be 100. We can choose the easing of the animation, so we'll use the expo out, and we can choose the stagger between each different words of 0.02 so that the animation is pretty fast. To this, I'll also attach another dot from. This one will be concerning the top grid div as well as a bottom grid div. So we're targeting both the top and bottom row separately. To both of them, I'll give the opacity of 0, duration of 1, ease of power1 dot in out, and a stagger of 0.04. I found this value to work the best. And then you can also apply a second parameter to this from, which is a string of minus equal to 0.5. What this will do is it'll make the animation start half a second before the previous one ends. So both animations will overlap a bit, which feels smoother and faster. So now if we save it, and if you reload, notice how each word falls into place one after another very quickly, and then immediately while that is happening, we can also see the top and the bottom row kind of start coming up together. It is very subtle, very quick, and seamless. No flashy animations. And at this point, I think you have a pretty good idea of how we're applying all of these animations. So with that in mind, let's not forget to commit it by saying git add dot git commit -m, implement the about section, and git push to push it over to GitHub, so that in the next section, we can focus on this amazing, pretty different art section. This is going to be all about how we're creating those cocktails. And we'll actually lead the user through the story of the creation through an image overlay. So as they scroll, they'll be able to see the full story. More on that in the next lesson. Let's dive into the art section of this course. It's pretty exciting, to be honest, because it's one of the sections that is different from the other ones. To this one, we just applied a timeline and showed the elements one after another in a specific time frame. But for this one, we'll actually unlock the entire section that's behind it using something known as a mask. So if you check out the final version, it'll look something like this. We go to the section that we have developed just before, and then as you start scrolling, you can see the art section, and you think that's it, right? But then as you continue scrolling down, you'll notice that a mask of this image appears, and it seems like you're entering into the world of this barman creating the cocktail just for you. So let's build it. I'll create a new component right within the components folder, and I'll call it art.jsx. Within there, you know the drill. I'll run RAFCE to quickly spin it up, and then I'll import it over within our app. That's going to be art, just like this. And then we can enter into it and start creating it. So first things first, we have to give this div an ID equal to art so we can scroll through this section later on through our navbar. And then within it, let's render a div with a class name equal to container, margin X of auto so we center it horizontally, height of full, and a padding top of 20. Within it, we can display an h2 that'll say the art. And we can give it a class name equal to will fade. Now, if we reload our application and scroll down, you can see just the art headline right in the middle. But now below it, let's render some more content. So I'll render a div that has a class name equal to content, and within it, it'll have a UL, an unordered list, with a class name equal to space-y-4 to create some spacing, and will fade as well. And within it, we can map over good lists.map, where we get different kinds of features, as well as the index for each one of these features. Let me show you what those are. These are coming from our constants, And we're talking about a list of some features that we offer. For example, hand-picked ingredients, signature techniques, bartending artistry, and freshly muddled flavors. So for each one of these, we'll render an li, a list item, that has a key equal to the index, as well as a class name equal to flex, items-center, and a gap of 2. And for each one of these, we'll render an image that'll have a source of images check.png with an alt tag of check. And then we can render a p tag that'll render the actual feature. So now we can see those 4 right here in the middle of the screen. But now let's render the main star of the show, which is the cocktail image. So I'll head below this UL, still within the content part, and I'll render another div that'll have a class name equal to cocktail -img, and within it, I'll display an image that'll have a source of /images /under img.jpg, an alt tag of cocktail, and a class name of ABS center, so absolute center, masked img, size-full, and object-contain. So if we save it, you can see this little image appear right here. But actually what's happening, if you take a look at the masked image class name that we're applying to it, you'll see that this is actually taking that image and then positioning it nicely in the center and applying a mask. So basically we're applying a mask image, and let me show you how that one looks like. It is within public, images, and then we can search for mask image. And you can see that it is just a single regular drink. But then we also have the regular image, the one that we used, which is the under image. So let me show you how the under image looks like. It's this one, the whole image. But did you know that natively in CSS, you can take one image and then choose another image, such as this one, to be the mask? And if you do that properly, if you say mask image, then it'll take the shape of that other image. Pretty cool, right? Now we can head below this div and create another UL. This one will actually be exactly the same as this UL. So I'll just copy it and paste it right here. Space Y4, but instead of good lists, we'll map over the feature lists, map over it, give it item center, but I'll also give it justify start and a gap of 2. And to this p tag, I'll also give a class name equal to, on medium devices, wfit, and typically w60. So now on mobile, they look exactly the same, but if you expand it, you'll be able to see it on the right side. And now let's also render the text below it. So I'll head below this UL and below one more div, and I'll render a div with a class name equal to masked content or container with an h2 that has a class name equal to will fade. We'll target these later on using GSAP to fade them. And I'll say SIP worthy perfection. Below this h2, I'll render a div that'll have an ID equal to masked content. Beneath it, I'll render an h3. And here we can just copy from the design, made with craft, poured with passion. So I'll just paste that in this h3 right here. And I also want to copy this text right here for the p tag. Right below the h3, this isn't just a drink, it's a carefully crafted moment made just for you. So you're turning everything into an experience. So now if you head back, you can see this, but you cannot see the h3 and the p tag because they have an ID of masked content. So we'll only show them as the user scrolls through the site. So now let's bring this entire section to life. As the user scrolls, we'll pin the section, fade out the initial content, scale and reveal the image mask, and finally fade in the closing message at the bottom. All of this will be linked only to one thing, and that is the scroll of your mouse wheel. So let's animate it right here at the top of this section by first figuring out if we're on mobile or not, because based on our width, we might need to position our elements a bit differently. For that, I'll use the use media query and set the max width to about 767 pixels, same as before. If it's below that, we're going to consider it a mobile device. Then we can use the use GSAP hook, and right within it, we can define the start value of our animation. So say start is equal to, if we're in mobile, we're going to start it when the top of the component reaches the 20% of the viewport, else we're going to start it on top, so as soon as we reach it. Once again, this required for me to play with it a bit to figure out the best values. So now that I know, we can just type them here. And now we want to focus on the timeline itself. So I'll say const mask timeline is equal to GSAP, which we have to import at the top. So right here, say import GSAP from GSAP, and then you can say GSAP.timeline, and we can craft a new timeline based on the scroll trigger, where we'll trigger the entire art section. We'll start the animation once we reach the start point that we declared above, and we'll end it once the bottom of the section reaches the center of the screen. I'll apply a scrub animation right here, and I'll set the scrub to 1.5, which will be smooth scroll control, which means that the animation progress will follow the scroll, but with some delay. And I'll also say pin and set it to true. This will keep the art section fixed in place while scrolling through the animation. That is very, very important, so just say pin right here. So now that we have defined the timeline, we actually have to declare the animations. So still within the use GSAP hook, I'll say mask timeline dot to dot will fade, and we want to change them to opacity of 0, stagger in between the elements of 0.2, and we can use an ease of power 1 dot in out. This is one of the most commonly used ones. So this is for the will fade elements. So if I head back and reload, as we scroll, you can see that all the elements will fade. And then as you scroll up, they'll reappear. So now that we have this dot to for the fading elements, we can also apply a dot to for the masked image, where we'll change the scale to 1.3 to make it bigger. I'll change the mask position to be center. I'll give it a mask size of 400% to make it bigger, duration of 1 second, and I'll leave the same ease of power 1 dot in out. So now if I save this and reload and scroll down, you can now see that the mask actually widens throughout the duration of 1 second and shows our barman. And finally, we'll also want to show the masked content. So say to dot hash masked content that'll have the opacity of 1, duration of 1, and an ease of power 1 in out. So now as you continue scrolling to the end, you'll be able to see this new H2 and a P tag appear at the bottom, finalizing the section. Pretty cool, right? And this opens up so many possibilities of having one image being hidden behind the mask of another, and then it expands and it invites the user in. This is such a powerful and effective section. And on mobile, it'll look something like this, where it still makes a lot of sense. Sure, we could go ahead and reposition some elements to appear a bit better, but even this right here is pretty amazing. So let's go ahead and commit it by saying git add dot git commit dash m, implement the art section, and then git push, allowing us to focus on our menu section next. But so far, great job on implementing this masked scroll. This has been great, and I'm super excited to finish it off with this one. Let's get started with our menu section, where in the middle of the screen, we'll have a drink that we show so that people get a visual representation of what they want to order. And also, let's be honest, these drinks are looking pretty cool, so once they see it, they're more likely to order it. Then we mentioned the title of this recipe, as well as some more info about it, and we have left and right arrows that allow us to animate this drink in place. Let me show you what I mean. On the finished website, you can now click to swap between these different drinks, see more information about them, And you can also use the right and left arrows to move between different drinks. And you can see how it nicely animates or slides in from left to right. So back within the code, let's create a new component within the components folder, and let's call it menu.jsx, where you can run RAFCE to quickly spin it up. Then, as usual, let's just import it within our app file, where I'll simply say menu, and make sure that it comes from components menu. Then we can head over into the menu, and we can turn it into a section with an ID of menu, so we can scroll to it from the navbar. I'll also add an area label by and set it to menu heading so that the users know that they can swap between different sections within this menu. Once again, I'll display some leaves. So I will have an image with a source of /images /slider left leaf.png with an alt tag of left leaf, as well as an ID of M as in menu left leaf. And I'll duplicate it below and change all the mentions of left to right. So I'll say right leaf right here, and finally M right leaf. Perfect. And below those two leaves images, I'll display an H2 that'll have an ID of menu heading with a class name of SR only. What this will do is apply this class name where we are resetting the positioning of this heading so that we can play with the animations later on. And I'll simply make it say cocktail menu. Now, if we head back over to localhost 5173 and scroll down, below the art section, you can see that we have the left and top right leaves, and in the middle, we'll later on animate the title of the menu. But for now, we can focus on the menu itself. So below the H2, let's create a new nav element that'll have a class name equal to cocktail -tabs with an area label of cocktail navigation. And within it, we can map over the cocktails saved in the constants folder. So if you head over into constants, index.js, and you search for cocktails, I believe it's these four, which we can call slider lists, or you can just rename it to something like all cocktails, whatever you decide to use. Make sure to also change it right here at the bottom. So whether it's slider lists or all cocktails, whatever it is, just make sure to import it right here at the top from constants, and then map over them by saying .map, where we have each individual cocktail, as well as the index of that cocktail. And for each one, we can open up a new function block, not an immediate return, because first I want to figure out which one is active. So I'll say const is active, and it'll be active if the index corresponds to the current index of the cocktail that we're on. But where are we going to get the current index? Well, we can save it to the state. So right at the top, I'll say use state snippet, and I'll call it current index, and set current index at the start set to 0 because we're in the first cocktail. We immediately have to turn this into a client rendered component. So I'll apply a use client directive at the top because we're using a use state hook, which is coming from React. And then based off of this active class, we can show some different information. So I will always return a button, and this button will have a key equal to cocktail.id. It looks like I misspelled the cocktail right here, and it'll render the cocktail name. So if we do this and scroll down, you can now see the names of 4 different cocktails that we're mapping over. But let's style it a bit differently so that we know which one is currently active. So I'll give this button a class name, and I'll make it dynamic, where we will check whether is active is currently true. And if it is, I'll give it a text white and the border white. And if it's not true, I'll give it a text white over 50 and border white over 50. If you want to, you can also put this into multiple lines, just so it's a bit easier to understand what's happening. Perfect. And now you can see that the classic mojito is currently turned on, whereas the other ones are not actively selected. Now, we also have to give this button an on-click element. which I'll do right here below the class name. And within it, we'll create a callback function that'll call the goToSlide function, to which we have to pass the index of the slide we want to go to. So we can also create this function right at the top, const goToSlide. It'll accept the index, and we can then figure out which index we're trying to go to. So const new index is equal to, and now if we just let it to be index, well, in that case, we would go from 0 to 1 to 2 to 3, and then we wouldn't have any more cocktails because that's it, we have 4. And if the next time the user clicks 4, well, then it's going to lead them to the 4th, the 5th, 6th, and so on. But we don't have that many. So in this case, I'll show you a neat little JavaScript trick of using a modular operator. So we can check whether the index plus the total number of cocktails, and we have to get the access to the total number of cocktails by calling the allCocktails.length. So if the index that we're currently on plus the total cocktails is equally divisible by total cocktails, and it returns a number that is not 0, well, then we simply set it to the index. Else, we'll return it to 0. So it'll restart once again once we reach the number that is greater than 4. If that explanation wasn't clear, we can refer to the MDN docs, checking the remainder operator, which returns the leftover when one operand is divided by the second one. So for example, if you try to evenly divide 13 by 5, you're going to get 3, because we can only divide 13 by 5 2 times evenly, which is 10, and then 13 minus 10 is 3. So if we evenly divide by 4, like this, and then if our steps are 0, and then we go to the second slide, which is 1, 2, 3, and then once we reach 4, it'll actually bring us back to 0. And then we restart from scratch. 1, 2, 3, 4. Pretty cool, right? So we have essentially created a slider that moves infinitely to the right, but resets at 4. And if you want to learn more about the reminder operator or any other operator within the JavaScript language, well, we cover it in much more depth within the Complete Path to JavaScript Mastery course. But for now, let's actually change the state so that it points to this new index. So I'll say set current index to be equal to new index. Perfect. Now, if we test it out, you can see that you can choose a different cocktail with your mouse, but we don't yet have the arrows to switch between them. So let's do that next. Right below the nav element, I will create a new div and give it a class name equal to content, within which I will then create a new div with a class name equal to arrows. Then within it, I'll create a new button, and this button will have a class name of text-left, so we align it, and an on click, it'll call the callback function where it'll go to slide that is current index -1. And within it, we can simply render the previous cocktail name. So for now, I'll just say prev cocktail name. Later on, we'll have to figure out what that cocktail name is. And then we can also render an image with a source of /images/ right arrow .png with an alt tag of right arrow and an area hidden of true. Great. So now we have this arrow right here, and you can see that it actually swaps between all these different cocktails and it never stops. That's because we use the modulo operator. Now we can repeat the same thing by duplicating this button just below. This one will render the next cocktail name. So I'll say next cocktail name, go to slide, current slide +1 instead of -1. And I'll use the left arrow right here and call it left arrow. So now we have those two different buttons that allow us to switch between the cocktails left and right. Now let's go below this div that is containing these two buttons, and let's render another div which will render the cocktail that we're trying to show. It'll have a class name of cocktail, and it'll render an image with a source of current cocktail dot image with a class name equal to object-contain. But hey, how do we know which cocktail is the current one and which ones are previous and next ones? Well, let's figure that out. Right here at the top of our component, I will say const get cocktail at, and then we have to get the index offset. Is it going to be the first, the second, the third, and so on? And here we can automatically return all cocktails where we get into the current index plus the index offset plus the total cocktails. And then we also use a modulo operator by the total cocktails. So at any point, we know exactly which one is the current one, which one is the previous, and which one is the next. With that in mind, we can extract those variables by saying const current cocktail is equal to get cocktail add 0. So that's the current one. Next, we can have the prev cocktail, which is going to be get cocktail add -1. And then we can have the next cocktail, which is going to be get cocktail add 1. And now we can use this prev cocktail dot name to show which cocktail we're going to go if we click on the left arrow. And here we can use the next cocktail dot name to know where we're going to go for the next one. And here we can use the current cocktail dot image to show it. So now if we scroll down, you'll be able to see that we have the Curacao Mojito, and then we have the Raspberry Mojito if we go right, and we can also see the image of the current one. Now, I want to show some more information about the cocktail that we're currently on. So just below this div that has a class name of cocktail, I'll display another div that'll have a class name equal to recipe. This one will have a div, and it'll have a reference pointing to the content ref, because we want to animate this very soon. So right at the top, I'll create a new reference that we can attach to that recipe part of the cocktail menu. So I'll say use ref, import it, and then say const content ref is equal to use ref, imported from React. Perfect. This div will also have a class name equal to info, and within it, a p tag saying recipe for, below it, another p tag with an ID of title that'll say current cocktail dot name. And then below this div, we can render some more details. So I'll render a div with a class name equal to details, where we will render the h2 that'll render the current cocktail dot title, and below it, a p tag that'll render the current cocktail dot description. So if we save this, you can see that now at the bottom, we have this info that says that this is a recipe for a classic mojito with simple ingredients made with tequila, lime juice, and orange liquor. So this is looking so much better right away. Let's also check it out on desktop to see it in its full glory. Looks like the arrows are not positioned well. So if you head back, looks like I called it arrow, but the class name needs to be arrows for it to get this flex item center and justify between styles. So if you change it, you'll see that now it has a much nicer layout where we can actually click on these cocktails and immediately get new information, or we can just click on the arrow or the name and immediately see the next one in line. Makes the choosing so simple. I think I'd go with this one right here. But now, when we switch between different cocktail slides, we want to show a beautiful transition of a cocktail sliding from the left side to the center, and we also want to animate the text as it's sliding in. And here's a little pro tip. I told you before that every single animation has to make sense outside of just looking cool. So in our case, the first one is to make them really interested into our bar, where they can see all of the different drinks that we offer. Then we have this section right here, which brings them even closer to ordering a drink by getting the barman to come towards them and offer it to them. And then finally, with the menu, the goal is to make them feel as the drink is already sliding across the table, coming right toward them. That's going to make them super likely to order it. This is called emotion-driven design, and it's used in a lot of different websites nowadays. And it is particularly useful when it comes to animations, because you don't want to implement the animation just for the sake of adding it. You want to add it to welcome the user to the jungle, for example, by moving these leaves up and down. You want to use them to make the users feel something. So let's add those animations. First, we'll animate this title. Then we will slide the drink across the table. Right at the top of our component, I'll use a use GSAP hook. And I'll create a callback function as before, but this time I'll also provide something within the dependency array. And that's going to be the current index. Why and what does this do? Well, when you provide something, a specific variable within the use GSAP hook dependency array, it'll rerun all of the animations that are within it whenever this variable changes. So whenever we change the slider from one cocktail to another, we want to rerun the animations for that other cocktail. So let's start with animating the title by first importing GSAP right at the top by saying import GSAP from GSAP. And then we can say GSAP dot from to. We want to animate the title from the opacity of 0 to the opacity of 1 throughout the duration of 1 second. So now if you click on one of these list items, you can see that the title slowly animates. But of course, let's focus on the drink now. That's the main star of the show. So I'll say GSAP dot from to dot cocktail image. We want to start from the opacity of 0 and most importantly, the X% from -100 so that it's outside of the screen. And then we want to change the X% to 0 to bring it back to the middle of the screen with the opacity of 1 throughout the duration of 1 second and ease of power 1 in out. So if you save this, you can see that now the cocktails nicely slide in. And even though we cannot see the bottom of the text right here, at least not on mobile devices, it is all fully visible on desktop. So let's animate it as well by saying GSAP dot from to dot details h2 from y% 100 and opacity of 0. We want to bring it to y% of 0 and opacity of 100 with the ease of power 1 in out. And we can do the same thing for the p tag. So we'll duplicate this GSAP dot from to and change it from details to p tag. Perfect. Now, if you move over to the second cocktail, you can see that both the p tag and the h2 fly in from below to above. Of course, we want to check out how that looks like on desktop. So as I click it, you can see that it looks even better. It is super quick and just works so well. Oh, and if you want to, as an extra assignment for this section, you can also add a parallax effect to these leaves right here on bottom left and top right. So they move slightly up and down, similarly to what we have done in the last 2 times. And with that in mind, we're done with the menu section. So in the next one, we can focus on the last section of this application, which is the footer section. But it won't be a very simple, boring footer section. We can actually make it as part of our contact page as well. So we can say where our bar is located, some contact information, as well as the opening hours, and of course, our socials. So let's do this next. And finally, we are ready to dive right into our footer, which is more than just a footer. It is also a contact page. So back within our application, head over into the components folder and create a new file and call it contact.jsx. Within it, run rafce, and let's just import it within the app.jsx by importing the contact section. If you do that, we can get started by creating it right away. I'll use a semantic HTML5 footer tag and give it an ID of contact so we can very easily scroll to it. Right within it, I will display an image that has a source equal to, and once again, we're dealing with some leaves. So I'll say images footer right leaf.png with an alt tag of leaf right. And I'll also render an ID of f right leaf, which we'll use to animate it very soon. I'll duplicate it and change this over to a left leaf in all three instances. And right below it, we can render a div with a class name equal to content. And within the content, we can render an h2 that'll say where to find us. Now, if you save this and scroll to the bottom, you can see the where to find us section. Now, I'll collapse this just so we can see it right here. And it looks like the left leaf didn't render properly because I misspelled left. So let's fix it in all three places. And now you can see both the left and the top leaves. Now, below this h2, let's render a div. And within it, let's say h3 visit our store. Or here we can say bar. Then below it, a p tag where we can render an address. I'll head back to the design so I can copy this random address in the US. Below it, we can render another div that'll say h3 of contact us. And then we can also paste the phone number, which I will copy within a p tag, as well as the email address, which will be right within another p tag. Finally, I'll render another div that'll have an h3 that says open every day. And then below it, we can map over the opening hours dot map where we get each individual time. And for each of these times, we can automatically return a p tag that'll have a key equal to time.day. And within it, we can render the time.day colon and then time.time. So we render both the day and the time. So if I head back, now we can see visit our bar, contact us, and open every day. We can head below this div and render one last div for our socials. So I'll render h3 and say socials. And within it, I will render another div with a class name equal to flex-center and a gap of 5. And we will map over the socials right here, which are coming from the constants. So make sure to import them. And for each one of our socials, we will automatically return an anchor tag so we can actually visit it. That'll render the image with a source of social.icon. So if I save it, you can see 3 different icons. And now we can style them a bit by giving it a key of social.name, an href of social.url, so we can point to it, a target of underscore blank, so it opens up in a new page. And with it, we have to provide a rel of no opener, no referrer, just like this. And finally, an area label for screen readers of social.name, so we know what we're clicking on. So now you can see that we have this footer section. If I expand it just a bit, you'll see that it looks even better. We now have those 2 leaves on the left and the right sides. And of course, we are ready to apply a couple of animations. I'll collapse our code just a bit, just so we can see the entire part of the footer. And I'll head right at the top of this contact section where I will use the use GSAP hook. And we will run it just at the start. Within it, we want to split this title into multiple words by using the split text plugin. So I'll say const title split is equal to split text, which we have to import at the top by saying import split text coming from GSAP all. And don't forget to import the GSAP library itself by saying import GSAP from GSAP. On the split text, we can call splitText.create, and we pass what we want to split. So that's the h2 within the contact section. And we want to split it into a type of words. Now that we've split it, we can create a timeline and tie it to the scroll position. So say timeline is equal to gsap.timeline based on the scroll trigger, and the trigger will actually be once we reach the contact section. So the start will be once the top of the contact section reaches the center of the screen. And we can also define the easing. So that's going to look like this, ease of power1.in.out. And that's our timeline. So now we can focus on actually animating different elements within that timeline. Specifically, we can focus on animating each word in the title right here. So say timeline dot from. We want to take the title split dot words and animate it from the opacity of 0, from the Y% of 100, which is outside of the screen, and with a stagger of 0.02. If you apply this and reload, nothing will happen yet. That's because I said word right here instead of words. So if you fix it and reload, you can see that it slowly starts coming up and down. We'll see it better once we go to full screen. But for now, let's focus on the other animations as well. So I'll just chain another dot from to this timeline, this time focusing on the contact H3, as well as the contact and the P tag. And I'll do the same thing. Opacity 0, Y%, and stagger. And finally, we want to animate the leaves. So I'll say .2, we want to go to hash F right leaf, move it over by 50 pixels in the top direction throughout a duration of 1 second, and with an ease of power 1 dot in out. And we can now duplicate this over for the F, as in footer, left leaf. So if I save this, you'll see that now on scroll, those leaves move, but it'll be much easier to see it if we check out the full screen. Scroll all the way to the top and reload, and now nicely scroll to see our footer section. Let's go through the art, through the menu, and finally check this out. Where to find us, everything nicely falls into the place. Although this leaf is not moving, that is the right leaf. So let's see, F right leaf. How did we call it right here? F right leaf, that is looking good to me. Oh, it looks like it does move, but a bit later, once everything else moves. So there's one trick that we can do, and that is to this timeline, right after this .2 animation, so after we close this left leaf thing, we can then add this little character that says before. What this means is that the element with ID F right leaf moves up by 50 pixels, and at the same time, the element with ID of F left leaf moves down by 50 pixels. So they move together. So now, as I scroll, you can see that this leaf right here just moved. And if I reload and check it out on mobile, see how all of the elements of the footer nicely load. But in this case, there isn't enough space to show the right leaf here as well, so I just hide it. And that is it for the footer or the contact section. So what I'll do is close the files, open up my terminal, and run git add dot git commit -m implement contact section, and then git push. So now the full application has been pushed over to GitHub. This has been such an amazing project. But now is where the real learning begins. Sure, we have implemented a couple of animations across all the different sections, but I need you to fully understand how GSAP truly works behind the scenes, and I want you to be able to implement these complex animations on your own in your future applications that you will be working on, not just replicating what we did together in this course. Of course, building this project already gave you a nice foundation to build your GSAP skills on top of. But now we're going to dive into the ultimate GSAP course, where we're going to dive deep into every single little GSAP property so that you truly understand how it works behind the scenes. Once again, congratulations on coming to the end of this course and developing this project, but now is where the real journey begins. Enjoy, and congrats! Everything begins with dimensions, which allow us to define the space around us. This concept goes back to ancient geometry and the work of great mathematicians. But don't worry, I won't turn this into a math lesson. I know you're here for the Three.js course. Still, it's important to understand the basics, because Three.js uses some math and some physics you maybe didn't like in school and wondered why you needed them. Honestly, you don't need to know much. Only some of it. So it's good you're here, as I'll teach you only the most essential things you need to know without any extra fluff in the simplest possible way so you can build any 3D app you can imagine. So let's dive into dimensions. While Doctor Strange might know many, we, mere humans, still only recognize 4 different dimensions. The 0th dimension is a point with no size, like a single dot on a map. The 1st dimension is a line with no width or height. The 2nd dimension is a shape with length and width but no depth, like a sheet of paper, or those 2D games like Super Mario or Street Fighter we used to play as kids. The 3rd dimension is a space where shapes or objects have length, width, and depth, giving them volume. Humans are 3D shapes. We have height, width, and depth. Unlike 2D graphics, 3D graphs provide a much more realistic and immersive experience with many more elements. And finally, there's the 4th dimension. Can you guess what it is? It's time. Time is the 4th dimension we use alongside length, width, and height. Examples are animation and video games, where a 3D object changes shape or position over time, or Loki using the Tesseract. That's it. There are no more dimensions at this point. Maybe new ones emerge in the future, but for now, we're good. Talking about 3D graphics, they're fairly new. In the 1980s, CGI, or computer-generated graphics, was first used for 3D renderings in movies and simulations. A decade later, the graphics industry advanced 3D technology by creating APIs like OpenGL, which offered a more standardized way for rendering 3D graphics. In the early 2000s, 3D graphics became so popular that there was a strong push to integrate them into the web browsers. Then, WebGL's revolution in rendering 3D objects on the web began in the early 2010s. It allows us to render 3D graphics directly in the web browser using JavaScript. WebGL is super impressive, but developing applications requires immense 3D graphics knowledge and many lines of code. You'd need hundreds of lines of code just to create a simple 3D cube in WebGL. I mean, just look at this. It feels like a nightmare. But then, Richard Cabello, better known as Mr. Doob, must have felt the same way, which led him to create Three.js, a JavaScript library built on top of WebGL that simplifies the development of 3D objects. I spoke with him at a recent dev conference, where he shared how the 3D development field will advance and its immense role in the future of the web. But more on that later. In simple words, Three.js is an extra layer that spares us from dealing with the complexities of WebGL while still achieving the same results. It's similar to what TailwindCSS is to CSS, providing utilities that compile into pure CSS code. In the same way, in Three.js, we use a specific syntax that gets converted into WebGL code. This code is then translated into OpenGL and interacts with the GPU to render scenes on your screen. So what exactly is Three.js? As we said, it's a JavaScript library and an API built on top of WebGL, enabling us to create 3D graphics for the web. But what exactly does Three.js offer? What are its main building blocks? And in technical terms, what kinds of APIs does it provide? How can you use it? That's a lot of questions. So let's break them down one by one. Have you seen Doctor Strange? A doctor turned sorcerer who manipulates different dimensions while battling enemies. In the movie, there's a concept of a mirror dimension, where the hero and enemies battle without the rest of the world being aware. Three.js works much like that. You create an environment and a scene through code, shaping it with your own rules. It's your virtual world where everything you want to visualize comes to life. But don't mix up the environment and the scene. They are similar, but not exactly the same. The scene refers to the overall container or space where all the action happens. For example, our planet is a big scene where we live and do all sorts of things. The environment refers to the surrounding atmosphere or backdrop within the scene. It's like the sky that surrounds us. As Doctor Strange moves between different dimensions, you can create distinct scenes that separate 3D worlds or sections within your application. For example, you could have one scene for the hero section and another for the footer. Each scene is like its own dimension that is typically rendered separately. We can have multiple changing environments within a single scene. For instance, you might want to switch from a day to a night or from a sunny to a rainy environment. While the scenes remain the same, the environment gives it a different feel. This concept can further be extended into AR and VR. With AR, you can overlay 3D objects onto the real world, while VR immerses user into a fully virtual environment using a VR headset like Apple Vision. And Mr. Doob, the creator of Three.js, sees a lot of potential in that technology when it comes to 3D development. Now that we are in a Three.js scene, we need to make it our own with the help of objects, just like we do in the real world. Take a look around yourself. What can you see? A table, a laptop, the chair you're sitting on, the keyboard you're typing on, and even the walls forming the room you're within are all objects. These objects are the building blocks of our 3D scene. We can place cubes and other shapes with different colors and textures, or even better, leverage community-built models in the scene and play around with them. With a scene in place and elements added, the next step is to make it interactive and dynamic. And that's where animations come in. We can transform an object's position, making it animate from one position to another, or change its size or angle by rotating it or adding cool textures to objects through colors or images. To make these even more realistic, Three.js allows us to add lights and shadows. You can add them either on the entire 3D scene or individual 3D elements. We'll cover lights in detail later on, so make sure to continue watching. But none of the scenes, objects, or lights matter if we cannot see the scene. And that's why we have cameras, our eyes in the 3D world. Without a camera, you wouldn't be able to see the scene that you've created. The camera in Three.js decides which portions of the 3D scene are visible to the viewer. Much like a director chooses the angle and perspectives the audience sees in a movie. Like in the real world, in Three.js, you can choose from multiple cameras that offer different perspectives on your 3D scene. For example, in a game, you might want to use a first-person camera for one section and a third-person camera for another. Or you might want to switch between a wide-angle view and a close-up view to show an object within the same scene. Sometimes you can use the main camera to provide a bird's eye view of the entire scene and another to zoom in and make the object appear larger. Think of Three.js cameras as your eyes. They allow you to see the world around you. Okay, you with me so far? But then, what do we do with the information that our eyes give us? We pass it over to our brain to process it. So what would be the brain in Three.js? It's the renderer. In Doctor Strange, after all the special effects and CGI work, a renderer brings everything together into the final product you see on the screen. Similarly, in Three.js, the renderer takes the 3D scene, the environment, objects, lighting, everything we discussed so far, and based on the camera's perspective, calculates how everything should look like when projected onto your 2D screen. It processes every pixel and determines its color, lighting, shadows, and more to produce that final image. Without the renderer, all the objects, lights, and cameras wouldn't make a difference. They must be translated into the pixels on our screen, which is exactly what the rendering engine does. So, to sum it up, we start with a scene to define the space where everything happens. Then we use a camera to determine the viewpoint and the perspective of the scene. Then we use objects to populate the scene with shapes, models, and other 3D elements. With lighting, we illuminate the scene so objects can be seen and appear as real. Then we update objects over time for dynamic behavior or movement. Finally, we render the scene, by calculating it from the camera's viewpoint that can be turned into images to be displayed on your monitor. Then we display those images and we continue to update and render the scene to make the animation smooth. Now that you know the basics of Three.js and 3D rendering, let's dive deeper into the foundational concept, 3D objects. A 3D object is anything you can see or interact with in a 3D space. There are many different types of 3D objects in Three.js, each with its own purpose. A mesh is the most common type of 3D object. It's made by combining geometry and a material. For example, a cube in Three.js is created by combining a box geometry with a material and turning it into a mesh. More on this later, as it's super important. Points are another type of 3D object, and they're a collection of small dots in a 3D space, often used to create effects like stars or particles. A line represents a simple connection between points in a 3D space. It's often used to draw shapes, grids, or wireframes. A group is a collection of multiple objects. Think of it as a div in HTML, which acts as a container to organize different elements. It allows us to transform many objects together. Sprite, a 3D object, not a drink, is an object that always faces the camera. It means it'll always be visible, no matter where we look. You can use it for billboards, icons, or particles in a scene. You might think that lights and cameras are also 3D objects, but they're not. They're more like separate entities or tools that influence how 3D objects are seen. And you know how everything in JavaScript is an object? Well, that's because everything inherits some basic properties. It's the same in Three.js. All elements I've mentioned, like meshes, points, lines, and more, start from the base JavaScript class called Object3D and extend its properties. Provides a common set of properties and methods for performing transformations, such as changing position, rotation, and scale for all types of entities in the 3D scene. Let me show you the most common properties. Position refers to where an object is located in the 3D world. It's described using three numbers, x, y, and z. X-axis moves the object left or right. Y-axis moves the object up or down. And z-axis moves the object closer or farther away from you. Rotation refers to how an object is turned or spun around in the 3D world. You can rotate 3D objects around the X, Y, and Z axis, like stretching your head. X-axis tilts the object forward or backward, like nodding your head. Y-axis turns the object left or right, like shaking your head no. And Z-axis spins the objects clockwise or counterclockwise, like turning a steering wheel. Scale refers to how big or small an object is in the 3D world. Scaling an object along the X, Y, and Z axis can make it larger or smaller. X controls how wide the object is. Y controls how tall the object is. And Z controls how deep it is. You can combine position, rotation, and scale to place an object exactly where you want it in the 3D scene, orient it in the desired direction, and size it appropriately. Now, which elements do we want to position, rotate, and scale to place on the screen? In most cases, it'll be the most common type of 3D object, a mesh. So let's explore it in detail. It's a core 3D object. When you think of a mesh, imagine it as a physical object with a specific shape and appearance. It can be a simple 3D geometric shape that Three.js provides, or a model created by merging different 3D shapes. A mesh is made up of two main parts, a geometry and a material. So let's break them down. Geometry defines the shape or structure of a 3D object. It can be further explained by its three properties: vertices, edges, and faces. Vertices are the corner points or positions in 3D space where edges meet. Each vertex is a point in a space defined by its coordinates, x, y, and z, determining where it's located in the 3D world. For example, a corner of the cube is one of 8 vertices, one at each corner. And if I had to put it in simple words, vertices are like the dots or pins you place to mark the corners of a shape. Edges, on the other hand, are the straight lines that connect two vertices. They help construct the shape and connect the vertices of a 3D object. For example, a cube has 12 lines representing edges that connect different corners or vertices. In simple words, edges are like the lines you draw between dots to outline the shape of an object. And finally, we have the faces. Faces are flat surfaces that connect vertices to form the geometry of the shape. They're made up of multiple vertices and define the visible surface of the 3D object. For example, each of the 6 sides in a cube is a face, which is technically a square formed by connecting 4 vertices. Another important concept in the 3D world regarding geometries is the triangle. Everything in the 3D world is made up of triangles. A cube might seem like it's made of squares, but in most 3D graphic systems, including Three.js, even squares are represented using triangles. Explaining this further would definitely go beyond the scope of this crash course, but I'll make sure to provide a detailed explanation of the importance of triangles in my upcoming Three.js course. But if you quickly want to learn a bit more about that triangle thing, I'll include a page about it in the free Three.js guide linked below. And now that you know the foundations of geometry, let me show you how you can use them within Three.js. It allows you to implement different geometry types straight out of the box. If you visit the official Three.js site, you'll see 21 types of geometries. The most popular are box geometry, which creates a rectangle with 6 faces like a cube, but it can have different dimensions for width, height, and depth. Sphere geometry creates a sphere or a globe where we can control the radius and the number of segments that defines the sphere's smoothness. And here's a pro tip. Adding segments increases an object's detail and flexibility, allowing for smoother surfaces and more realistic lighting. So why wouldn't we always do it? Well, if you add too many segments, they can impact performance, so use them wisely. Cylinder geometry creates a cylinder with a circular base, where you can adjust the height, radius, and the number of radial segments. Plane geometry doesn't create a plane that flies, but creates a flat 2D plane that extends infinitely into the x and y directions by specifying its width and height. A torus geometry creates a donut, and then there's a dodecahedron geometry. What a beautiful name. It creates a polyhedron shape with 12 pentagonal faces, which is helpful for more complex shapes and 3D modeling. And there are many other types of geometries, but there's no need to know them just yet. That's because you don't have to be limited by these predefined shapes. Three.js doesn't stop you. You can create custom geometries by defining objects' vertices, edges, and faces directly in the code. You can define them however you want and create a whole new shape. You have full control over every aspect of geometry, deciding how it looks, deforms, and interacts with the rest of the scene. Creating these custom geometries is different from 3D modeling, which refers to creating the objects in a dedicated 3D modeling software like Blender or Maya, and then importing these models back into Three.js. More on that in the Ultimate Three.js course and the guide linked below. But for now, enough with the geometries. Let's move to the second part of creating a mesh. Now that we have a shape, we have to wrap it with a nice material. A material determines how the surface of the geometry looks. It defines the color, texture, transparency, shininess, and how light interacts with the mesh. It's like the skin of your 3D objects, deciding whether they look metallic, glossy, matte, transparent, or textured. Three.js provides many types of materials we can use depending on the visual effect you want to achieve. Here are a couple of the most common ones. The simplest material, as its name suggests, is the Mesh Basic material. It is so basic that it only applies a flat color to an object, but it does not interact with light. This means that no matter how much light is in the scene, the object will always appear the same. Mesh Fong material adds shininess and reflections. It simulates glossy surfaces with special highlights, making objects look more polished and reflective. Mesh Standard material is a physically based rendering material, which means that it more accurately simulates real-world lighting and reflections. It has become a standard in many 3D applications, such as Unity or Unreal. It offers both metallic and roughness controls, giving you the ability to create realistic materials like metals, plastic, and stone. Mesh Physical material is an extension of Mesh Standard material with additional features like clear coats for shiny finishes like on cars, sheen for fabrics, and transparency effects. It's used when you need to do some more advanced surface effects. Mesh Toon material gives an object a cartoon-like appearance with flat shading and solid colors. Instead of a smooth gradient of color and light, it creates bands of colors, giving it that comic book look. Think of characters in animated films or video games who have solid shading and don't look photorealistic. I mean, they don't have to. It's just a specific look you can go for. And there are many others like Mesh Normal material, Metcap, and Depth material, and many more. But on top of these materials to which you can apply color and lights, you can also apply textures. In Three.js, a texture is an image, like a JPEG, PNG, or GIF. And yeah, it's GIF, not a GIF. Or pattern applied to the surface of a 3D object, such as a mesh, to give it more visual detail and realism. The texture is like a wrapping paper that covers the geometry of a mesh to make it look more interesting or lifelike. There are different types of textures, such as diffuse, normal map, spectral map, bump, displacement map, and so many more. Of course, covering all of these will go beyond what a crash course is supposed to be, but of course we'll cover them in the Ultimate Three.js course. So that's it. Now you know the two main parts of a mesh. When we create a mesh, we can combine a specific geometry with a material to create a final appearance. But how can we see the objects we've created if they're in the dark? So, let there be light. In Three.js, light illuminates the 3D scene, making it more realistic and clearer. Without lights, your 3D objects would be completely dark. Think about it. Even in real life, you don't really see anything around you. You see the light that bounces off of the objects and then back into your eyes, giving your brain the information to process their size, shape, and color. Different types of lights provide different effects. For example, some light shines everywhere, like a light bulb, while others focus on one spot, like a stage spotlight, or shine in a specific direction, like the sun. So, let's learn about different types of lights. First, there's the ambient light, which provides uniform lighting to all objects in the scene without casting shadows. We played around with some ambient lights on a mesh material a few minutes ago. A real-life example of an ambient light would be a cloudy day. On such days, sunlight is scattered by the clouds, so everything around us is lit evenly with no strong shadows. It's soft. Point light emits light from a single point in all directions. It can create bright spots and shadows around the source. Think of a light bulb in the middle of the room. The light spreads out evenly in all directions, making things close to the bulb appear brighter and things farther away dimmer. Direction light simulates parallel light rays coming from a specific direction, like sunlight. It's used to create the effect of a distant light source. It's like the sun on a clear day. The sunlight comes from one direction, and objects cast sharp shadows because the sun is so far away and the light rays are parallel. Spotlight emits light in a cone shape similar to a flashlight. It's useful for focused lighting effects or creating dramatic illumination. In real life, it's similar to a spotlight on a stage during a performance. It shines in a cone shape, focusing on one actor or object to create a dramatic effect with clear shadows. Hemisphere light provides lighting from above and below the scene, simulating light from the sky. I hope that makes sense. If not, no worries. It'll make much more sense when we dive into the code. We'll do that soon after we discuss the last missing piece of the puzzle, the camera. Everything we see on the screen in the 3D world comes from the camera's perspective. It determines the view of the 3D scene. Without a camera, you wouldn't be able to see any objects in the scene because there would be no viewpoint from which to observe them. It's pointless, like having a stage without an audience. There are two main types of cameras in Three.js. A perspective camera mimics how human eyes see the world. Objects closer to the camera appear larger, and objects further away appear smaller. This is called a perspective projection, and it is the most commonly used camera for 3D games, simulations, and realistic visualizations. An orthographic camera removes the perspective effect, which means that objects appear the same size no matter how far from the camera they are. This is called an orthographic projection, and it's useful for certain visualization styles, such as 2D games or architectural blueprints. There's also a stereo camera, which creates two views of the scene, one for the left eye and one for the right eye, to simulate 3D depth. This is often used in 3D movies, 3D games, and VR applications. There are also other types of cameras, such as cube, array cameras, and others. You can explore all of these on the Three.js docs, but in most cases, you'll use the main ones. But to truly understand how a camera works in Three.js, you must know its main properties. The first one is the field of view, often shortened to FOV. It refers to the extent of the observable world, visible through the camera at any moment. The angle of the camera's vision, measured in degrees, determines how wide or narrow the view is. Imagine holding a camera in your hands. If you zoom in, your field of view becomes narrower, showing a smaller part of the screen. But if you zoom out, the FOV becomes wider, showing more of the scene. Field of view is about how much of the scene the camera can see at once, how wide your view is. A point of view, POV, refers to the specific position and angle from which the camera looks at the scene. It's like where the eyes of the camera are located and what direction they're facing. Imagine a first-person shooter, an FPS game. There, the point of view equals the character's vision and depends on the direction they're facing. In a third-person shooter, the camera is behind the character's back. In simple words, point of view is about the camera's position and direction. Where are you looking from? The aspect ratio is the ratio between the width and the height of the camera's view. It ensures that the objects in the scene aren't stretched or squashed when displayed on the screen. When you watch a movie on a widescreen TV versus a square TV, the aspect ratio changes, affecting how the content is displayed. In 3D, this property ensures that objects look natural regardless of screen size. And there's also the near and far clipping planes, which define the boundaries of the camera's view, determining how close or far objects can be for the camera to see and render them. It improves the performance and controls what part of the scene is shown. It's a camera's viewing range. The near clipping plane is the closest distance from the camera at which objects are visible. Any object closer to the camera than this distance will not be rendered. The far clipping plane on the other side is the farthest distance from the camera at which objects are visible. Any object beyond this distance will not be rendered. Think of it like a tree on a hill in a game that's far away. As you get further away, it becomes invisible. These were the most important camera properties. But while learning the foundations of Three.js, we learned that the camera and other 3D elements also extend the Object 3D class, which lets us position, rotate, and scale it. But sometimes that's not enough. And that's where camera controls come in. Instead of manually setting the camera's position and rotation, controls allow us to rotate, zoom, and pan the camera dynamically, often using mouse or touch inputs. These controls are commonly used in interactive 3D scenes, such as games, simulations, and VR experiences. Three.js offers a few built-in controls, each designed for different types of interactions. Let's dive into the main ones. Orbit controls are the most commonly used camera control. They allow us to rotate around a target point, zoom in and out, and pan the view, which means move side to side. Orbit control is great for exploring a 3D scene from different angles while keeping the camera's focus on a central point. An example of that is the Apple's website, where when you look at the 3D model of an iPhone or a MacBook, you can spin it around to see it from every angle, zoom it in to check out the details, and move it slightly to examine it more closely. This control lets you interact with the product as if you were holding it in your hands. It's fixed and you're orbiting around it, like the Earth orbits around the Sun. There are also trackball controls, which allow for more flexible and free-form movement than orbit controls. We can rotate around the camera freely, zoom in, and pan. For example, in BioRender, a platform used by scientists, when working with 3D models of cells or molecules, you can rotate around them freely, zoom in or out, and shift around them without being fixed to one point. It's like floating around a model in space to look at it from all sides. Flight controls simulate movement like that in first-person exploration games, where the camera moves forward, backward, and side to side and rotates as if the user is flying through the 3D world. We mainly use flight controls in exploration games, VR environments, or simulations where users can fly through the scene. For example, in Google Earth VR, we can soar over cities, mountains, and oceans. This control lets us move as if we're flying like a bird, smoothly gliding through different locations and zooming in to explore areas up close. There's also pointer lock control, which locks the cursor on the screen and allows the user to look around as if they were in the scene themselves. It's often paired with keyboard controls to move the camera forward, backward, or side to side. In games like Call of Duty, the mouse controls where we're looking. As we move the mouse, our character's view shifts left, right, up, or down, just like turning our heads in real life. We use this to aim, explore, or react quickly in the game. And there's also the first-person controls, which offer a more traditional first-person view where the camera moves in the direction the user faces. It mimics the controls in first-person video games, where we use the keyboard to move and the mouse to look around. The pointer lock controls, which we explored before, are focused primarily on the rotation of the camera using the mouse, but additional code is required to make it work with the keyboard as well. But that's not the case with first-person controls, which combine camera rotation and movement in one package. It doesn't require locking the mouse pointer, offering more flexibility in controlling the camera. In many real estate websites, you can now virtually walk through a house or a building. It's as if we're moving through the rooms ourselves, turning our heads, stepping forward, and exploring the space from the first-person perspective. You can also check out the Three.js docs for more camera controls, but I think this is more than enough. Now that we've covered the essentials of Three.js, let's put it into practice by creating a simple project using HTML, CSS, and JavaScript and infuse it with 3D. If you check out ThreeJS.org, go to Documentation and Installation, you'll notice that there's a couple of different ways to create a Three.js project. The first one is to install it with npm and a build tool. And the second one is to import it from a CDN. We'll start with that one first, so you can quickly put Three.js to use, but then soon enough, we'll transition over to the better approach, which is to install it with npm. But for the time being, let's open up a new project in our code editor. In this case, I'm actually using an IDE called WebStorm, and I've just created a new empty folder. Within that folder, create a new folder, and let's call it Basic, as this is the most basic version of our Three.js project. Within it, let's create a new HTML file. I'll call it index.html. Within there, you can simply copy and paste the index.html from the installation structure. As you can see, we're importing a main.js file right here. So let's create a new file called main.js, which is going to be a JavaScript file. And we don't need a separate style sheet. Rather, what we can do is just reset the margin to 0, set the padding to 0 as well, and also set the box sizing to be equal to border box. And we can set that on all the elements in our code. Also, remove this / so it points to the right main.js file. Now, to infuse our application with Three.js's functionalities, we have to add it via a CDN. So simply copy this script, and this will add the code needed to run Three.js. So let's add it just before the closing body tag and save. Now let's head over to our main. Let me show you how to use Three.js. First, let's import everything as 3 from 3. This is the Three.js package. Next, I'll add a list of steps we have to perform to show something on the screen. And you already know these because we explored them in detail not that long ago. But now we're exploring them in code. So how do we create a scene? Well, you say const scene is equal to new 3.scene, and you call it as a function. Next, let's also modify the background of a scene by saying scene.background is equal to new 3.color, and that's going to be a hash of F0, 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 just a random hexadecimal color. Now you can see some warnings right here, such as module is not installed, the scene doesn't exist, and the color doesn't exist either. Well, it's completely normal that our IDE doesn't know that these actually exist because we're not using a regular package, we're just using a CDN. So for the time being, I will just remove those warnings. Later on in our React applications, everything will work perfectly and you'll know exactly which properties Three.js exposes for us. Now, with that in mind, we cannot quite yet see the background color of this scene. Not until we add the renderer. So let's continue with the next few steps. The second step is to add a camera. And we can do that by saying const camera is equal to new 3.perspective camera. As you know, there's many different types of camera. In this case, we'll be using a perspective one. And this is the first time that you can see that we can pass some props into the camera. So this is what differentiates theory from actual implementation and hands-on learning. The first property that the camera expects is an FOV. And now we know what that means, a field of view. So for now, I'll set it to 75. Next, we need to provide the aspect ratio. And here, I'll set it to window.innerWidth divided by window.innerHeight. This will make the aspect ratio be exactly the same as our window. And the next two properties are near and far planes. For near, we can set it to 0.1, and for far, we can set it to 1000. We can also modify the camera position by doing something like camera.position.z-axis is equal to 5. So just z right here. Once we have a camera, let's also create something to show, an object. So first, we need to define a geometry for that object by saying const geometry is equal to new 3.box geometry. Of course, you could have used any other predefined geometry provided to you by Three.js. And next, we can use a material. In this case, I'll use a new 3.mesh Lambert material. And to it, you can provide a color. Let's do something like hash 468585. I think that's going to look good. And we can give it a property of emissive, which we're going to set to be the same color that we added, 468585. By default, emissive is set to black. And if we don't add it, then the color of our material won't react with light as we want it to. Next, let's use the geometry and the material to create a cube. Const cube is equal to new 3.mesh. Remember what you learned about? Mesh is simply consisted of two things, a geometry and a material, which we can pass as first and second property to this function. Next, let's add this cube to the scene by saying scene.add cube. Of course, we wouldn't be able to see anything quite yet, so we also need to add the lighting to the scene. We can do that by saying const light is equal to new 3. And now we can choose the type of lighting you want to use. There are many different types. In this case, I'll go with directional light. The directional light accepts two properties. The first one is the color. And in Three.js, you can pass a hexadecimal color by saying 0x and then provide it. Let's use 9CDBA6. I found this one to work very well. And we can also provide the intensity as the second parameter. So let's set that to 10. Finally, let's position the light by saying light.position.set. And we can set it to 111. Do you know what these 3 ones mean? It's the X, Y, and Z axes. Finally, let's add it to the scene by saying scene.add light. Great. We have our scene, we have the camera, we have our object, and now we have the lighting. So let's just add the renderer. We can do that by saying const renderer is equal to new 3.webgl renderer. Make sure that both G and L and R are uppercased, and you call it as a function. Next, we can set the size of the renderer so it knows what it has to render by saying renderer dot set size to window dot inner width and window dot inner height. So it'll render the full height and width of the window. Finally, let's call the document dot body dot append child, and let's add the renderer dot DOM element to our DOM tree. Now, this should be enough to see what we created in the browser. So you can go to your file tree and then right-click index.html and then open it up in your browser. WebStorm makes it even simpler. I can just open the file and then immediately preview it. But before we open it up, we must switch the order of the scripts. First, we have to load the Three.js CDN, and then after that script, we can add the script pointing to our main.js. And one thing we must not forget is to add the version of Three.js that we want to use. So back in the browser, here they tell us don't forget to add the version, and we can check the versions from the npm version list. The most recent version with a lot of downloads is 0.167.1, so let's copy it, and let's add it right here, Three.js at 0.167.1, and we can do the same thing right here. Great. And just quickly going back to the main.js, make sure that everything coming after 3 starts with a capital letter because we're working with constructors such as mesh, box geometry, perspective camera, color, oh, and even this scene right here. And finally, to see the scene, we have to render it. We have just set up the renderer, but now we need to call renderer dot render, pass it the scene, and pass the camera from which we want to render that scene. Once you do that, we can go to our index.html and you can open it up in the browser. I have my preview right here on the right side, and within our scene, we have a camera looking directly at a teal box. Now, this isn't as interesting on its own, but once we add the animations, it'll be so much better. So let's animate that scene by creating a new function called animate. Within it, we can request animation frame to which we can then pass animate. So this will request for the animation. And next we have to define what will the animation do. And here we can just rotate the cube by saying cube.rotation.x plus equal to 0.01. And we can do the same thing for the y-axis as well. Finally, we can move the renderer.render within the animate, indent it properly, and call the animate function at the bottom, which will then call the renderer.render. As soon as you save this, the cube should start rotating right in your browser. And I mean, look at this. You have a 3D element seemingly flowing in this empty scene, which has different lights pointing to it. This is great. But of course, this is just the start. The goal of this demo was to give you step-by-step instructions for creating a scene, adding a camera, using geometric materials and lights, and then rendering them with animation. The key to mastering Three.js is hands-on exploration. So please take the time to explore different geometries, materials, lights, and more. In other words, have fun playing with the code. Open up the docs and try switching a property that we animate. Try using a different light or a different geometry. It's completely up to you. Only by practicing will you be able to better comprehend what the changes that you make to your code change in the 3D environment. We explored creating a simple Three.js scene using HTML, CSS, and JavaScript through a CDN link. Now, let's explore an alternative approach using the Three.js package directly. This time, we'll build something more exciting by incorporating additional geometries, materials, and lights. So, let's get started. Similar as to in the previous demo, we have to somehow get access to the Three.js library. Instead of using a CDN, which is a bit of an outdated approach, we'll now install Three.js as an npm package, alongside 700,000 other people that installed it just this week. To do that, we'll set up a project using Vite. So head over to vite.dev, click Get Started, scroll down to scaffolding your first Vite project, and copy the command. Next, back in our IDE, I will create a new folder, and I'll call it Vite. I'll open up the terminal, and I will cd into Vite, and now we can paste the command that we just copied. npm create vite add latest. First, it's gonna ask us to install the create vite CLI, so let's press Y to do it, and it's gonna ask us for the project name. In this case, I'll just say / to create it in the current directory. Next, we need to choose the flavor of our Vite. I'll just use vanilla, so we're still on basic HTML, CSS, and JavaScript. We'll do React soon, but for now, let's just stay on vanilla. Let's choose JavaScript and run npm install to install all the necessary dependencies, and as soon as it is done, we can install the Three.js package by copying the installation command. It's pretty simple. It is just npm i3. It's a pretty lightweight package, so it gets installed instantly, and we can run npm run dev to run it in our browser. It's running on localhost 5173, so let's open it. And there we go. Hello, Vite. Now we need to clean it up a bit. So let's delete this counter file, and let's clean up the main.js. The only thing we want to do in there is import everything as 3 from 3. I'll zoom it in so you can see it a bit better. And then we can create a new canvas by saying const canvas and getting it by targeting our DOM, so document dot get element by ID, and we'll target the one with the element ID of canvas. After that, we have to do all the other things to make our scene work, like we did in the first demo. And it never hurts to repeat the most important stuff. So let's do it once again together. First, we need to create the scene. So number 1, scene. We can do that by saying const scene is equal to new 3.scene. By the way, notice how WebStorm auto-completes this immediately well for me. And now, if you highlight it, we have information on what this 3 actually is. And what the scene is. It is a constructor which we can visit and see exactly how it works. Also, you can see that the WebStorm adds this inline hint that lets us know that this scene is of a type scene, which results in something like this. If you start typing it and press dot, it will automatically know what kind of properties does it have. Specifically, we'll use the background here. Let's set it to be equal to a new 3.color, and let's use some kind of a grayish color like hash F0, F0, F0. What is the second step? It is to add the camera. So let's say const camera is equal to new 3.perspective camera. And maybe you know what kind of properties does it accept. First, it accepts the FOV, and I love how WebStorm automatically lets me know the name of this property. Next, it's the aspect. So we can give it the window.inner width divided by window.inner height to make sure that it takes over the full width and height of the screen. Next, it takes the near number, meaning how near does the object have to be to still be visible. I'm gonna put 0.1, and then for far, I'm gonna put 1000. And this is our camera. Of course, we have to position the camera somewhere in the space. So we can say camera.position.z and set it to something like 5. What is the third step? Well, it is to add some kind of an object in the space. So what do we need for an object? Well, we need a geometry and a material. So let's define a geometry, which is equal to new 3 dot, and now you can choose whatever geometry you need. It can be a capsule, a cone, a circle, cylinder. In this case, let's be crazy and let's use a dodecahedron geometry. We can also choose its material by saying const material is equal to new 3 dot mesh Lambert material, and to it we can pass color of hash 468585 and emissive 468585. That's a nice teal color. And now that we have the geometry and the material, we can create what? A mesh. So we can say const dodecahedron is equal to new 3 dot mesh, and we need to pass the geometry as well as the material. Oh, I misspelled 3 right here, so let's fix this very quickly. And we have a type warning here saying that Lambert material is not assignable to basic material, so let's quickly make this a basic material as well. Great. Now for this demo, I want us to create 2 objects. So we have a dodecahedron, and just below, I want to create another one. I'll call it box geometry equal to new Three.js box geometry, and we can also pass some props into it, such as the width, the height, and the depth. I did 2, 0.1, and 2 for the values. We also need to define the material, so let's duplicate the material from above and just rename it to box material, and let's just change the colors to something like hash B4, B4, B3. With the basic material, I believe we don't even have the access to the property emissive, so we can just remove it and keep the color, just to keep things very simple. Finally, we can create that box by saying const box is equal to new 3.mesh, to which we pass the box geometry and the material. Let's position this box in a space, something like box.position. .y is equal to -1.5, and now we can add both of these objects to a scene by saying scene.add dodecahedron, and let's also do scene.add box. We know that we cannot yet see those elements without lights, so step 4 is to add lights. We can do that by saying const light is equal to new 3. In this case, let's use a spotlight. We can pass it the color of 0x006769. I found this color to look good, and an intensity of 100. I'll use the light.position.set to set it at 111 coordinates, and I will add it to the scene by saying scene.add. Finally, as the step 5, we have to set up the renderer. So let's say const renderer is equal to new 3.webgl renderer, and to it, we'll pass the canvas that we previously created. It is this one right here, the HTML element. Why are we adding the canvas? Well, so we can add some controls so we can interact with the scene. But for now, we just want to see it. So let's simply say renderer dot set size. We'll set it to window.inner width and window.inner height. And finally, renderer dot render, where we have a scene and we're looking at that scene from the camera's viewpoint. Now we have to head over to our HTML file, which is right here, and we have to add that canvas. We can add it right here instead of this div by renaming the element to canvas and giving it an ID of canvas as well. And we can say Vite app with Three.js. Let's also quickly modify the CSS by going over to style.css, and we'll say all elements will have a box sizing of border box, a margin of 0, and a padding of 0 as well, just to reset things and make it easier for us to interact with the 3D world from scratch. Now, if you check out the browser again, you should be able to see something that looks like this. Doesn't look like much, right? It's just a dodecahedron, which looks like some kind of a polygon, and then a box right below it. But what do you say that we make this canvas interactable? We can do that by using something known as orbit controls. So that's gonna be step 6, add orbit controls. And right here at step 5 for the renderer, we can also set the pixel ratio. So we can say renderer dot set pixel ratio, and we can set it equal to window.device pixel ratio. This is very useful for mobile devices, so the controls work on there as well. So now let's add those controls. We can do that by saying const controls is equal to new orbit controls, which you have to import at the top. We need to pass it a couple of props. The first prop is the camera, which thankfully we have already defined. And the second one is the DOM element of the renderer. Once we have that, we can modify our controls just a bit by saying controls.enable damping, and we can set that to true. This will make our controls smoother. We can also play with controls.damping factor, and we can set that to 0.05. We can also modify the controls.enable zoom, which we're going to set to true, so we can zoom in and out. And finally, we're going to play with the controls.enable pan, so we can also pan the screen. Before we check out those controls in the browser, let's just make sure that our import is good. It looks like for me, it auto-imported it from 3 add-ons. Actually, it should be coming from 3 add-ons controls, orbit controls.js. Now, before we put it to use, let's scroll down. I noticed I have an unused box material here, so let's actually put that to use. We'll use it within the box mesh. And finally, we can add the animations. So let's say 7, add animations. And we can do that by adding the function animate, which we can immediately call right here below. This function will request animation frame, to which we can pass animate. And here we can play with the rotation. So let's say dodecahedron dot rotation dot x plus equal to 0.01. And we can also change the y rotation in the same way. And let's do the same thing for the box by saying box dot rotation dot y plus equal to, let's do something less drastic, 0.005. We also need to update our controls so that the dampening takes effect. So controls.update. And finally in here, now we can call the renderer.render scene. So let's use it right here a bit below. Great. Now if you go back, you can see that the rotation is being applied on its own. But now we also have the power of orbit controls, which means that we can orbit this scene and view it from all the different angles, from bottom, from top, left, right, front, and center. But since we're using a basic material right here, the scene doesn't look that good. So as I told you before, play with it a bit and see how you can change the colors, the lighting, and more. If we replace this basic material with the Lambert material, and if we gave it that emissive property like we did before, even though I'm getting a type warning right here, you can see that this now looks much more realistic. The light is actually bouncing off of it. And if we orbit, we can even get to the exact spot where the light is coming from. You can see it's kind of hitting it at this corner. Similar thing for the box. Let's try to change it to something like mesh standard material. And we can also give it that emissive property by saying emissive is equal to this color. There we go. Now you can see something beautiful. And that is that the teal color of this dodecahedron object actually reflects into the box. And of course, deeper in the course, we'll explain every little detail, such as why this mesh is complaining about this being a standard material and not a basic one. But for now, we're good. Finally, let me give you a pro tip. We also want this animation, as well as the orbit controls, work if we resize the window size. So to make that work, we can do a step 8 of handle window resizing, where we can say window.add event listener of resize. And when we resize, we want to call a callback function where we can reset the camera aspect to be the new window.inner width over the window height. We can update the camera projection matrix. It sounds tough, I know, but it basically just resets the camera position. And finally, we can reset the renderer size by setting it to window inner width, window inner height. Of course, let's spell it properly. And we also need to initially set the size, which I believe we are already doing. That's great. So now if you resize this window, you can see that everything still works perfectly. And this wasn't a lot of code, right? Just enough to add 2 different objects. But even with just 2, there was a lot of duplicated code. So you can imagine how things can quickly get messy as we add more objects. Without knowing the best practices or JavaScript patterns for reusability, you could quickly find yourself in a 3D nightmare. So be mindful when you're working with Three.js on a vanilla JavaScript project. There's also something else I wanted to show you. First was the way that I fixed this import at the top. How can you know that these orbit controls are coming exactly from this place? Well, it all comes down to reading the docs. Alongside playing with the code that you have here, in the last demo I told you that the best way to learn about Three.js is to play with the code and see what happens. Well, the second best way is to read through the docs and explore some examples. You can see exactly how you can use each one of these properties. Not only that, you can see every single property that it accepts, as well as every event that it fires. And the best way for learning Three.js, or any other coding concept for that matter, is to combine the theory and reading the docs with modifying the code and seeing what happens. So if you haven't already downloaded Codium at the start, you can do so now by clicking the link in the description and getting it for your own IDE. In WebStorm, you can press Command-Shift-P and then search for plugins. And right here, we can search for Codium. Let's install it and restart my IDE and create an account. I'll just log in with Google. And then you can select a block of code or the entire thing that you want explained and just click Ask Chat or press Command-Shift-L. And just look at that. This code sets up a 3D scene using the Three.js library, rendering a rotating dodecahedron and the box with a spotlight. The scene is interactive, allowing the user to orbit, zoom, and pan using the mouse. The scene also responds to window resizing. Well, this is exactly what it is. And of course, you can continue asking it questions about the code, such as, we're using a perspective camera. What other camera types there are? And it's going to read both the code and the docs, combine the two, and say, hey, perspective camera is used in your code. It simulates the way the human eye sees the world. The orthographic camera does this, cube camera that, and so much more. It's a super useful tool for explanations. So that's it for this demo and the pro tips that came along with it. So far, we have reviewed many Three.js foundations and tested most of them in code. While writing that Three.js code, you may have felt like, whoa, this is so much better than writing WebGL code for a cube. But as you start to add more features to your 3D app, you'll notice that the amount of Three.js code grows and becomes harder and harder to manage and maintain. Do you know why? When working with Three.js, you typically write a lot of imperative code, meaning you're telling the computer what to do step by step. You're in control of everything, from initializing and positioning objects, handling rendering loops, updating the camera, and managing interactions. While having a lot of control is great, it also means you have to be very mindful of every detail. This can make your code messy and complicated as your project gets bigger. That's the challenge of scaling with Three.js, which coincidentally is the name of one of the important lectures of our upcoming Ultimate Three.js course. One small mistake and things can go wrong. And this is where React 3 Fiber, or R3F for short, comes in. It takes a whole different approach by using the power of React.js. Instead of writing imperative code, you write declarative code. This means you have to describe what you want your scene to look like, and the React 3 Fiber handles the details of making it happen. With R3F, you don't need to worry about the step-by-step process of updating the scene. You simply declare how you want things to be, and the React does the heavy lifting. Instance, if you want a cube to rotate when the user clicks a button, you can just update the state in React, and the React 3 Fiber will automatically update the 3D scene for you. Since R3F is built on React, you can use React's features, such as components, hooks, and state management to break down your 3D scene into reusable components. Along with R3F, there's also React 3 Drei, which is a collection of useful helpers, components, and abstractions built on top of React 3 Fiber. It provides ready-made tools like cameras, controls, and environment setups, which can significantly speed up your development by handling common tasks and simplifying complex setups. In short, Drei acts like a toolbox that extends R3F, so you don't have to reinvent the wheel for common 3D features. Think of it as Chat CN, we use ready-made 3D features to build applications faster. We've been experimenting with vanilla JavaScript demos up to now. So let's try using Three.js in React with the React 3 fiber and see how it compares to the imperative approach we've used. Once again, we'll create another folder and I'll call it Vite-React. I'll cd into Vite-React and run npm create vite add latest. Once again, we'll do the / for the project name, and this time we'll use React as the framework. Let's use just React with regular JavaScript. And once again, we'll have to install the Three.js package, but this time we'll also use a React Three.js library called add-react-3/fiber. So we'll be installing that as well. And you can see how my terminal smartly auto-suggests to install React 3 Drei too. So let's add React-3 /Drei, which is a utility library to make Three.js work with React even better. So let's press enter and let's run npm run dev. On localhost 5173, we have another Vite starter running, but this time with React. Now let's clean it up a bit to give us a clean slate for turning this into a 3D powered React application. We can start by going into the source and then app.jsx. We can clean up everything that is in there and just say const app is equal to a functional component where we can simply return a div that says hello Three.js. And of course, we can do an export default app. Going back to the browser, we can see hello Three.js. Now I'll show you how to use Three.js within React. It all starts by utilizing some of the things that React 3 fiber provides us, such as a canvas. So let's turn this div into a canvas and let's import it from React 3 fiber. To it, we can provide some inline styles by saying style is equal to, and we can give it a height such as 100 VH. We can also give it a width of 100 VW for the width, a display of flex, justify content is equal to center, and align items is equal to center as well, just to make sure that everything is nicely centered. The reason we're adding a canvas is to turn everything within it into a 3D rendering context. That's what the canvas does. It's a DOM canvas which accepts Three.js elements as children. So whatever you want to add to the scene, you can simply add it here. Maybe you want to add orbit controls from React 3 Drei. It's super simple. You just add it here and you provide different functionalities such as enable zoom to true right here as a prop. We can also enable pan, and finally we can enable rotate. If you simply want to set it to true, then you can leave it as it is. You don't even have to explicitly say true, just to make it like this. Next, how do we add a light? Well, you can simply say directional light, and you can pass it a position, intensity of 10, and then a color as well. Maybe something like 0x, and let's do 9CD-BA6. That's a nice looking color. And if you want to color the canvas, you can also just say color, make it a self-closing tag, and say attach is equal to background, and args will be equal to an array where we only have one color, F0, F0, F0. So I think now you can see the difference between declaring literally everything and then just using it within the code, where you're referencing components and variables from React 3 fiber and React 3 Drei. Of course, now we want to show a specific element right here, maybe a rotating cube. So let's just call a component rotating cube, which is going to be a self-closing component. So let's declare it right above. Const rotating cube is equal to a component where we'll return a mesh. This mesh has to have a reference so that we know what we're interacting with. So we can say const mesh ref is equal to use ref, which is a hook coming from React. Now we can say mesh has a ref equal to mesh ref. This is some React-specific functionality. And why are we using it? Well, we're using it because then we can leverage a useFrame hook coming directly from React 3 Fiber. The useFrame hook executes a callback before render in a shared frame loop. So it'll loop and it'll do something to our object. So let's declare a callback function. And here, if we have a meshRef.current, meaning if we can access this cube, then what we can do is whatever you want to do. Something like meshRef.current.rotation.y plus equal to 0.01. And you can do the same thing for the x-axis as well. So now that we're applying some kind of a frame, let's actually render this mesh. You know how before we had to declare everything, like a geometry and then a material? Well, here it makes so much more sense. You have a mesh, and within the mesh, you can use any kind of geometry. In this case, let's use a cylinder geometry, and you can provide some arguments to it. This is going to be the size. So let's say 1, 1, 1, and specifically, these point to the X, Y, and Z axes. Next, we can provide a material. In this case, I'll use a mesh Lambert material, and then you can provide a prop with the color. Let's say color is something like hash 468585, and we can also apply the emissive property equal to the same color. But you might wonder, like, where are these properties coming from? The mesh, the cylinder geometry, the mesh Lambert material, we're not really importing them from the top. The only thing we are importing is this canvas right here. Well, since we're within the canvas, it allows you to call all of these components. Let me show you. I'll go to React 3 Fiber's documentation, and you can see an example for the first scene. We have a canvas, and then here it says how you can add a mesh. To actually see something in our scene, we'll add a lowercase mesh native element, which is a direct equivalent to the new 3.mesh. Remember that? And here's an important note, pointing to exactly what I was telling you about. We don't need to import anything. All Three.js objects will be treated as native JSX elements, just like you can write div or span in regular React DOM. The general rule is that Fiber components are available under the camel case version of their name in Three.js. A mesh is a basic scene object in Three.js used to hold geometry and the material. So we can create a new mesh using the geometry and the material, which automatically attach to their parent. So this is exactly what we have done. So if you wanted to pause for a moment to know exactly what is happening here, this code right here is equivalent to this part in native Three.js, which is what I taught you how to do in the first two demos, so now you can truly grasp the benefits of using React 3 Fiber. Another question you might have is what kind of things are we passing to it? Well, if a native Three.js element like box geometry is accepting 3 props, you can pass those props in the same order through a prop named args. You can add the lights in the same way that you add all the other elements. And when it comes to props, if a native Three.js element has some props, like light has the intensity, here you can add it as a prop. How convenient is that? And that's it. We're at the end of this documentation page. So you can see that React 3 Fiber docs are pretty short. There isn't a lot of stuff here. And these are all tutorials. And that's because they're not really changing too much from base Three.js. They're just making it easier for us to work with Three.js within React. So if you're wondering about which geometries exist, or which materials, or what you need to do to form a mesh, you would still go here to the original Three.js documentation, search for a different component or a property, and see exactly which properties does it accept. And then you know that you can pass them as args to our React 3 Fiber alternative. Great. Now, if we check out our local host, you can see a spinning cylinder, and you can also use your mouse to move across it. This is great. You can see how simple it was to add orbit controls using React 3 Drei. But let me show you one more cool thing. Like, React 3 Drei and React 3 Fiber are all about making your life working with Three.js within React and Next.js applications easier. So let's say you wanted to add some sparkles here. You can just say sparkles, import it from React 3 Drei, and then give it a couple of properties, such as a count is equal to 100, scale is equal to 1, size is equal to 6, speed, let's make them very slow, 0.002, noise can be 0.2, and color can be orange. If you save that and go back, now this object is actually sparkling, and you can zoom in and see the sparkles that you added in just a single line of code. Imagine if this was some kind of a fire where you can easily add sparkling fire elements to it. The possibilities are endless, and this code, super simple to understand. We can use Codium once again to explain this app, and you can see that it is a 3D scene using Three.js, where the scene is rendered within the canvas element, and then we add orbit controls to enable user interaction, directional light to add lighting, and then we set the color and add a rotating cube. So whenever you're unsure about something, it's always nice to use the explain functionality here. And there's also this docstring thing, which if you click it, it'll start generating docs in form of comment right above this code. So you can see it is super simple. You can accept it or change it or reject it, where it says that this is a canvas component that renders a rotating cube in the center of the screen with interactive camera controls, and it returns a JSX element representing the canvas. Super useful. So, isn't this easy? It's just like writing regular React.js code. The logic is more or less the same as in regular Three.js, but React 3 Fiber and React 3 Drei simplify the process. They help us write more maintainable and manageable code through components, and they offer built-in functions right out of the box. Have you ever wondered how Apple makes you feel like you absolutely need that sleek MacBook Pro just by scrolling through their website? Those buttery smooth animations, the way the laptop rotates in perfect 3D space, how every scroll feels premium. And suddenly, you're calculating if you can survive on ramen for 3 months just to be able to afford it. See, Apple doesn't just build websites. They build experiences that make an impact that eventually makes you buy that new Apple product that you don't really need. But here's the question. What if you could do it too? What if every website you create could also make your users stop mid-scroll and think, holy crap, how did they just do that? What if your work didn't just wow some random visitors, but rather turned them into customers, or even landed you that next big gig or that job? Hi there, and welcome to a brand new video where I'll teach you how to create a MacBook Pro landing page clone that looks and feels exactly like the Apple's masterpiece. You'll learn to develop cinematic hero sections with scroll synchronized video backgrounds, interactive, photorealistic 3D MacBook models that users can play with, parallax masked video rendering that feels alive, scroll trigger effects, giving us precise control over animations and timelines, advanced scroll storytelling that guides users through an emotional journey, a sleek bento box layout that presents content in visually balanced modular sections, all of it with optimized performance and responsive design that works flawlessly across all devices. And we're not just gonna copy Apple features here. You'll actually learn the skills behind them, including React.js for dynamic scalable UI rendering, TailwindCSS for pixel-perfect styling, Three.js to load, light up, and animate realistic 3D models, GSAP for scroll triggers, timelines, sequencing, and buttery smooth transitions. And because we're not vibe coders, but developers, we'll implement all of the best code practices and guidelines using CodeRabbit-assisted code reviews and their new CLI to make your project feel as premium as Apple's own site under the hood. To push you even further, I've prepared a complete GSAP and Three.js guide packed with pro tips, examples, and advanced project idea. You can find it within the video kit down below completely for free. And if you really want to go beyond just following along, if you want to understand the psychology behind why these animations grab attention, hold users in place, and make a product feel irresistible, and then learn how to design and build your own from scratch, I've put all of that into my GSAP Mastery course. That way, you won't be just copying Apple's animations. You'll be creating experiences that feel just as premium entirely on your own. Link is down in the description. So, I hope you're ready to stop just admiring Apple's designs and start creating them yourself. Let's get going. And since my goal is to make sure you land a job, this app is not just a regular project. It's a career asset designed to showcase everything you're capable of, making you an attractive candidate for any job. See, hosting your website on a personalized domain makes you more professional and improves your credibility. It also highlights your skill in self-hosting, scaling, and managing websites. So before we dive into the code, we need to set the foundation. I highly recommend Hostinger for hosting this app, and they're offering an amazing deal right now. So click the Hostinger link in the description and then click Start Now. When it comes to hosting this app, I'll personally go with the premium plan. It allows you to host 25 websites with the same account, has 25 gigs of SSD storage, you get a free domain for 1 year, and free SSL for HTTPS security, which builds trust with anybody visiting your site. This deal won't last forever, and because I've partnered with Hostinger, you'll get an even bigger discount. So click the link in the description, start now, and choose a plan. Here, we have to choose the period of our hosting, and with the amazing deal going on right now, I'll choose 48 months to save the most. If you already know the domain name you want to get with the hosting, you can type it out right here, or you can do that later. And most importantly, here's that additional coupon code that I promised. Just type in JavaScript Mastery, and you'll get an even bigger discount on your hosting package. You can now continue, and very soon, we'll start developing our app. Once you're in, we can continue with Hostinger's guided setup. In this case, we're creating a new app. Since we are real developers, we won't be using WordPress or the website builder, but rather we'll start with an empty website. And now here, you can choose your domain name. I know we're still early in the project, we haven't yet started building it, but you've seen the intro and you might already have an idea about how you want to name it. So just type in your domain name right here. As you can see, I'm already using Hostinger for all of my domains. Or if you're really not sure, you can use a temporary domain for now and then choose a real one later on. And that's it. Your domain will get registered. Next, you'll have to choose a server closest to where you think your users will be so your website loads fastest. Feel free to choose anything here. And that's it. The setup is now initializing. While that's happening, I want to let you know that there's a complete GitHub repo for this entire code, which is entirely free. You can click the video kit link down in the description, and there you'll be able to learn more about JS Mastery Pro, our platform for premium courses. But here, you'll also be able to find a completely free Tailwind guide, Three.js guide, TailwindCSS crash course, and the source code for the code alongside the entire Figma design and the assets. So everything you need regarding this project will be right here, completely for free. And that's it. Our hosting has been set up, and now we are ready to dive right into the code. Before we start developing this design masterpiece, let's actually set up the environment so that later on we can just focus on coding. First things first, click the CodeRabbit link down in the description and create your free account. We'll use CodeRabbit's PR reviews and their new CLI all throughout this video, so let's make sure to set it up right away. With that in mind, let's go ahead and check out the entire demo of the application you'll build today, starting with a very simple navigation bar and an animated hero section, moving down over to taking a closer look at the product that our users will be buying. You can also change the colors and the sizes. Scrolling down, you can see this beautiful parallax video section that as you scroll, actually shows you the name of the chip that's inside of that MacBook. Then a bit more info about it. Finally, you have this section where these different screens reveal what you can do on the MacBook itself with more info. Finally, this beautiful animated section that tells you what you can do, while at the same time showing you a video of that happening. So here we have image AI, email AI, summarize, airdrop, and more. And all of that also happens when you're going back. Beautiful. And finally, a nice bento grid of all the features. That's it. Super precise, shows you everything you need to know, nothing more, nothing less. To build this app, I'll be using React, but you're completely free to choose from any of the front-end frameworks. If you want to use Next.js or Angular or view or whatever it is, you're completely free to follow along, make small adjustments, and adapt my code to your needs. Also, make sure you've set up your code editor. I personally use JetBrains' IDEs because of their advanced auto-completion, error tracking, advanced integrated Git workflows, and overall better code intelligence. It's a full IDE after all, and with it, you can also get Junie, JetBrains' coding agent. It is super useful, and I'll show you how we can use it within this application to speed up your development workflow. That said, let's go ahead and create our application. We'll use Vite to quickly spin up our React app. So head over to Vite and click Get Started. Then if you scroll down a bit, you'll see a command for running Vite. So just copy it. Or if you're using WebStorm like I am, you can just go ahead and create a new project. Immediately choose Vite right here, and then choose a Vite template. In this case, I'll go with React. This will run the same command for me. And you can name the folder something like MacBook GSAP app. Once you're within it, you can run the command you copied over from Vite, and make sure to add the / at the end so it creates it in the current repository. I'll say remove existing files and continue. Choose a framework. In this case, we'll go with plain JavaScript, but once again, if you want to use TypeScript, you're more than welcome to, and no need to use experimental versions. We're going to install with npm and start right away. There we go. The app is running on localhost 5173, so you can open it up within your browser. And let's clean up the project a bit to prepare it for your app. Go ahead and remove the app.jsx within the source. Remove the app CSS. Remove all of the assets since you won't be needing them. Remove all the styles from index.css. And let's actually show something on the screen by creating a new app.jsx file within which you can run RAFCE. This is short for React Error Function with exports. If this didn't work for you, you must head over to Plugins and install Modern React Snippets, and then it'll work. If you create this app, head back over within main.jsx, you'll see that it's rendering it. And if you reload your app on the browser, you should be able to see a small piece of text that says app. Instead of that, we can maybe render an H1 and then make it say, hello, Apple MacBook Pro. And there we go. The text is there, which means that everything is working. Now we gotta install TailwindCSS that we'll use for styling. So head over to TailwindCSS.com that allows you to rapidly build modern websites without ever leaving your HTML, or in this case, JSX, and it'll give us those utility classes. So click Get Started and install it using Vite. That's the selected option. We've already done the first step, so now we just have to install TailwindCSS by copying and pasting this command. WebStorm allows me to have 2 terminals or more. I'll name the first one app as it's already running our app, and I'll create a second one, which I'll call terminal, within which I can run additional commands all while our app is running. I'll run npm install tailwindcss /vite. Once that is done, we also have to configure the Vite plugin by heading over within our Vite configuration. So copy this, head over into Vite config, and don't necessarily override this, but rather just add these 2 additional lines. Import TailwindCSS from Vite, and then add this plugin right here to the plugins array. Perfect. Once that is done, head over within our index.css and copy this import TailwindCSS line. Restart your application if needed by pressing Ctrl+C and then npm run dev once again. And then let's start using it. Let's copy this H1 right here that says hello world and update our current H1 that now has this not class, but rather class name of text3xl, font bold, and underline. If you now head back, you'll see that that is applied. We can do one more, maybe testing the text indigo of 700, which is a color, and you can see that it works. That means that you've successfully set up Tailwind. Now, as you can imagine, our final app will have a lot of different icons, starting from this Apple icon at the top to this magnifier glass or the cart icons right here. We got to get all of these icons and colors and themes within our application so we can later on use them. I prepared all of that for you within a free Figma design. You can see the entire app will build with all of the sections one by one, so that if you maybe want to give it a shot on your own, you can do that as well. This design, alongside the theme that it is using, which are some colors that are being repeated, even though it seems it's all dark, there are a couple of colors that we need to add to our theme. So the design and the colors are within the video kit link down in the description. Just click it and sign up for free. Once you're there, you'll be able to learn more about JS Mastery Pro. It's our pro platform for those who want to learn more. And below that, you'll be able to find all the necessary files that I'll be referencing throughout the rest of this course. One of those files will be a modified index.css. So head over into the index.css, find it within the video kit down below, and then copy and paste it right here. It'll feel like there's a lot of code right here, but most of these are just some utility classes that we'll use to make the styling of our app easier. And then, as I promised, here we're setting up some fonts and setting up some of our colors. Yes, most of them are just dark, but here they are. In the video kit, you'll also be able to find the assets. These are those small icons and images that I've been telling you about. So simply click right here and then download the zip. Once you download it, simply unzip it, and then remove the current public folder, and then drag and drop the new one within the root of your application. You'll see that this one will include a couple of fonts, the 3D models we'll be using, videos, images, and icons. This way, we have everything we need to get started developing our application. Congrats on going through the setup. This one will for sure be the most boring lesson in this entire course, but immediately from the next lesson onward, we'll start developing our MacBook application. Let's start with the first piece of our UI, the navbar. Create a new folder within the source folder and call it components. React applications are all about components, very small pieces of UI. So in this one, we'll create a new file and I'll call it navbar.jsx, within which you can run RAFCE just to be able to see the text that says navbar, and then import it right within our app. Instead of the H1, we'll wrap everything into the main tag because this is the main part of our application. And there I will render the navbar. And now you can just see a piece of text that says navbar. So now let's head over into this component and let's start implementing it. First things first, I'll turn this div into an HTML5 semantic header tag. And within it, I'll create a new nav tag. Within nav, I'll render a new image that'll have a source equal to /logo.svg with an alt tag of Apple logo, and immediately we can see it at the top. Then below it, still within the nav, we'll render a new UL, an unordered list, and within here, we have to create some nav link items. So you can create an object, and then within it, a new array. Within that array, we can create different links. For example, we can create an object with a label that'll say something like store. Then you can create another object that'll be a label of, let's do Mac. Maybe another one that'll be all about not Linux. We're not doing that right here. Maybe iPhone, right? We can do another one for a label of watch or Apple Watch. Let's do another one for vision. And then finally, the last one for the AirPods. Okay, so now we have an array of a couple of objects with a label property. I'll give it some breathing room, and then I'll now map over this array by saying .map, where we get each individual link. And for each one, we want to automatically return something. When I say automatic return, I mean that you immediately put the parentheses right here and not curly braces. Because if you put curly braces, then you have to explicitly say what you want to return. But if you immediately put parentheses right here, that means that you don't have to add the return keyword explicitly because it is implied. So for each one, I want to return a link, an li, with a key equal to link.label. And within it, I'll put an anchor tag with an href of link.label. For now, these are not valid labels, but later on we can update them if you want to. And then the text will say link.label. If you want to, since we are repeating the word label too much, you can destructure the label from the link, and that way you don't have to repeat the word link 3 times. That'll look something like this. If you save it now, you won't be able to see anything just yet, but if you expand the screen just a tiny bit, you'll be able to see that on desktop and tablet devices, the navbar is right here. And below this UL, I will add a div with a class name equal to flex-center and a gap of 3, within which I will render a button, within which there's going to be an image with a source equal to /search.svg with an alt of search, and I will duplicate this button and image one more time below. This time it'll say cart.svg with an alt of cart. So now you can see in desktop, it all aligns perfectly in Apple style, Apple logo on the left, the links in the middle, and then a few icons on the right. Now, if I collapse this, you can see that on mobile, the additional links disappear, and we only have the Apple and 2 additional icons on the right. Now, to tidy up this code a bit further, we don't have to keep this data right here. I would consider this some data. That is maybe logic or info, definitely not the presentation of our JSX components. So typically, it's better not to keep it right here. For these types of data pieces, you can create a new file. So right within the source folder, I'll create another folder called constants, and I'll create a new file called index.js within the constants folder. When you name a file index, that means that you can access it just by saying constants without having to necessarily say index.js or some other name.js. Constants index is just constants. And then here, you can move this array, which for example, we will call nav links. So now if you head over to constants, you create a new const nav links, and you paste this array. It's better to keep it here. You can immediately export it, and then you can go ahead and import it right here. Nav links coming from constants index.js, or as I said, you can just say constants. And now we have a very clean navigation bar. Perfect. That was pretty simple, right? So now that we've implemented our first UI component, no matter how simple it is, I want to teach you how to immediately start utilizing all the best practices within your development process. One thing is to not commit to Git after your entire project is done. You want to create a new GitHub repo right from the start. So head over to github.com/new, and right here, you can choose an owner and enter a repository name. In this case, I'll call it GSAP MacBook Landing. You can give it a description if you want to, and you can leave it public and click Create Repo. Once you do it, right here, you'll get the instructions needed to connect this local repo to the remote one. So let's open up our terminal, say git init, git add dot, git commit -m, initial commit, git branch -m, main, git remote add origin, git push u origin main. With just these couple of commands, you will have pushed the current code and the assets over to our GitHub repo. So if you reload in a couple of seconds, you'll be able to see all your code pushed right here to GitHub. And that is important for a couple of reasons. First of all, other developers and potential employers will be able to track your commit history to see whether you have actually built this project or you just copy and pasted it from a tutorial. If you've been building it yourself, then all the commits will show up nicely. You can also tidy up the description, enter the URL, and some topics. This will make the repo cleaner, and at the same time, as you're pushing new code to your repos, your contributions graph will shine green. So from here on, we'll push over to GitHub for almost every section in this course, and then you'll be able to go to my repo, and if you're not sure how something was implemented, you can check that specific commit and see exactly what happened. That'll make it easier for you to follow this tutorial as well. Now, on top of setting up GitHub for every single new project that I do, another tool that became a must-have for me is CodeRabbit. It allows me to keep my code clean and catch some mistakes that I miss. So if you haven't already, click the link in the description and create a free account. In this course specifically, I want to focus on their newest product called CLI Reviews. Instead of vibe coding, it allows you to vibe check your code with smart reviews. Go ahead and copy this CLI command. And an important note is that CodeRabbit CLI is for now supported in macOS and Linux. Windows is coming soon. So if you're in Windows, depending on when you're watching this, you might be able to check out CodeRabbit CLI, but if not, you can still create an account and utilize the pull request reviews feature. And depending on which IDE you're using, you can also check out the AI code reviews right within your IDE. But now for my macOS and Linux users, let's quickly go through the CodeRabbit CLI setup. Back within the editor, I'll paste this curl command, which will download the CodeRabbit CLI. It says installation complete, and you can now restart your shell or run this command right here, which I will do. Once you do that, you can run CodeRabbit --help to see a bit more info about what it can do, or you can just CodeRabbit. This will automatically authenticate you. So I'll go ahead and authenticate using GitHub, and you'll get this token. So simply copy the token and paste it within your terminal. There we go. CodeRabbit is running. Right now, there are no new changes. That's because our Navbar was super simple, and I went ahead and committed it before running CodeRabbit. So let's go ahead and implement the hero section, and then we'll be able to see what this CodeRabbit has to say about our code. Now that the navbar is done, let's focus on our wonderful hero section that has this animated MacBook opening to us and kind of hinting that there's a lot inside. We can get started by creating a new component and call it hero.jsx. Run RAFCE right within it to quickly spin up that component, and then use it right here below the navbar within our app.jsx. This one will be called hero. So now if you head back over to our app, you won't be able to see the hero yet because it's being hidden by the navbar. So instead of a div, let's turn it into a section with an ID of hero so that we can scroll to it if needed. Within it, render a div, and then within that div, render a new H1 that says MacBook Pro. That's your big title. Then below that H1, render an image with a source of /title.png and give it an alt of MacBook title. There we go. Now, right below this div, render a video, set its source to /videos /hero.mp4, and then set it to autoplay, which will automatically open it up on reload, make it muted, make it play in line, so you don't see the additional settings like the volume, forward, backward buttons, and so on. And now if you reload, it'll just nicely autoplay and open up. Even though it might seem like this is some crazy animation, what it actually is just a very optimized video animation that just opens up and works. We can also make it load a bit faster or slower and modify some other video properties by attaching a ref to it. This is something we'll often do. Whenever you want to have more control over a specific video, you attach it to a ref. So video ref is equal to a use ref hook coming from React, and then you simply attach it to a video by saying ref is equal to video ref. On its own, this won't change anything, but it allows you to do more stuff with it. For example, you can open up a new use effect, and when this component loads, you can then check if video ref has been attached to any element. If that is the case, set the video ref.current.playback rate to 2. And now if you save it, you'll see that it'll open up 2 times as fast. Check it out if I comment this out. Now it's much slower. It is completely up to you what you want to do with this video and the other videos as well. Sometimes it is personal preference, but the goal of the websites is not to overwhelm them with animations. There should be some micro animations, but they should be happening pretty fast, not to make your website feel like it's slow. And then below this video, we can render a button. This button will simply say the word buy as a primary CTA, and then below it, a p tag where we can say from $1599 or $133 per month for 12 months. Something like this. There we go. nice and Apple-like. And of course, if you expand it on full screen, it'll look so much better because this is a horizontal animation, which means that it takes more horizontal space. Beautiful. But now, let's open up our terminal. I'll head over to CodeRabbit, stop it from running, and then run the CodeRabbit command one more time. Now, it notices that there are 2 files changed with 27 insertions. You can now hit Enter to hop into the review directly within our terminal. So press Enter, and now it says AI pretending that it knows better than you, and it's loading the existential dread about your code. Okay, that's nice. At least it's being honest. Preparing passive-aggressive comments. I love that one. I love all of these loading messages, actually. And there we go. Review completed, this time with no comments. Well, that's absolutely amazing for us. Sure, the hero component wasn't that long, so there wasn't much to review. But as we dive developing other, absolutely more complicated components, like this 3D model viewer, I'm sure CodeRabbit will find ways to improve our code. So for now, since we're good, let's just go ahead and commit it by typing git add dot git commit -m implement hero section and git push. In this lesson, I'll teach you how to build this interactive 3D MacBook Pro viewer, where your users can change the color of the MacBook from silver to space black, switch between different sizes, as well as rotate this 3D model. This layout will be divided into 3 different pieces: a headline and some product info, then the control panel for customizations, this thing right here at the bottom, and then a canvas that'll render that 3D model. Let's start by creating a new file in the components folder, and you can call it product viewer.jsx. You can use RAFCE to quickly add a new component within it, and then you can import it right here within the app.jsx by simply saying product viewer. Now, if we head back to our current version of the application, you should be able to see a product viewer text right here. Then let's develop the UI of this experience section. Head over into the product viewer, turn it into a section that'll have an ID equal to product-viewer, and then within it, render an H2 that'll say take a closer look. Then below it, render another div with a class name equal to controls. And within it, render a p tag with a class name equal to info that'll say MacBook Pro 16-inch in silver or maybe space black. There we go. You can see it right here. Below this p tag, go ahead and create another div that we'll use to center the controls with a class name of flex center, a gap of 5, and margin top to divide it a bit from the text. Here, we can render a div with a class name of color control, and there we can render 2 self-closing divs with a class name of BG neutral 300 and another one with BG neutral 900. And here you have 2 different colors. We'll always be rendering one color at a time, so for now we can maybe make it just say MacBook Pro 16 in space black. And then below this div, we'll create another div that'll have a class name equal to size control. And here we can render a div with a p tag in between that'll say 14-inch, and we can duplicate it and below say 16-inch. So now we can choose between different colors. If you're ever wondering what a specific Tailwind class name does, you can control-click it, and it'll lead you directly to that CSS directive. So you can see that, for example, this size control applies a small medium to the text, flex between the elements, BG neutral, rounded full, some padding horizontal, padding vertical, and a gap in between the elements. That actually creates this outer shell. And then to each div within it, we apply a size of 8, rounded full, cursor pointer to make them appear clickable, text black, and flex center, so we know we can choose between those 2 versions. So again, at any point you're wondering what something does, just go ahead, click on it, and you'll be able to see the full CSS for it. Finally, below all of these divs, we'll render another p tag with a class name of text-white and text-4XL that'll say render canvas, because now very soon we'll start rendering the canvas right here. Before we do that, we'll have to store a lot of different things within the state. And sure, you could use React context, or you can use Zustand. Zustand is a super simple store or global state setup for React applications. So you can install it by running npm install Zustand, as well as CLSX. We'll use this for some dynamic styling with TailwindCSS. Once you install them, you can create a new file, or rather a new folder within the source folder, which we'll call store. And within the store, we'll create a new index.js file. Here, we have to import create from Zustand to be able to create a new store. Then we'll create that store and we'll create it as a hook. Use MacBook store. It's equal to create from Zustand, to which you pass a callback function that automatically returns an object. And here you can define some global state variables, such as a color of 2E, 2C, 2E. This is the color I picked from the design. And you can also provide a setter variable for that variable, such as setColor, which accepts a color and sets it within an object like this. Why are we doing this? Well, to be able to keep track of the information of which color of the model is currently being shown. And we have to do the same thing for the scale, such as scale of 0.08, set scale, which will take in the scale and set the scale. Finally, if we decide to reset it, we have to have a callback function that will be doing just that, which can simply call set and set the color to the default color of hash 2E, 2C, 2E, and it'll also set a scale to 0.08. Perfect. And now this is our store that we'll export, and we'll be able to use it all across our application. So now let's use those store values and update the color and the scale within the product viewer. Head back over to the product viewer component, and right at the top, say const, and then destructure some of the values coming from use MacBook store, just like this. And make sure to import that use MacBook store from /store. Now from it, we can get the color, the scale, the set color, and the set scale setters, so that we don't have to manage that state over here. We're managing it within a global state. So all the logic will be right here, whereas here we focus on the presentation. What you can do right now is in color control, where we have this div, you can give it an on click. That'll be equal to a callback function, where you can set color and set it to the color that is being clicked. In this case, it is hash ADB5BD. Make sure to call that as a function, because that's how we've created this setter. And then this will set the color, but we also have to keep track of that color within the class name. So I will put this into multiple lines. We have a div with not an on clock. This will be an on click. And then for this class name, we will call CLSX. This is that package that we installed that allows us to set the base style, such as BG neutral of 300, but then it also allows us to check whether color variable is set to hash ADB5BD. In that case, we'll make this button appear active by giving it an active class. So now if you head over here, if you click on it, now it gets the active class. And at the same time, the color is also selected. What does that mean? Well, that means that now we can display the color right here, even though it won't be in a human readable name, but at least we can get the variable. So if we say MacBook 16 in color, you can see this color was about to be shown. And now if you duplicate this div right here and replace it with the one below, the only difference is that this one will set it to a dark color of 2E, 2C, 2E with a BG neutral of 900. And if color is 2E, 2C, 2E, then it'll be active. So now we can see how we are modifying the value in the global state, and we're changing the presentation based off of which color had been selected. We can do absolutely the same thing for the scale. So I'll duplicate this div once more and paste it right here instead of this div. On this click, we will set the scale to 0.06, which is a bit smaller. And for CLSX, we will check if scale is triple equal to 0.06. In that case, we will apply a BG white and text black. Else, we will apply a BG transparent and text white to let it know which one had been clicked. This div won't be self-closing. It'll actually render a p tag that'll render the size. And now I will duplicate this div for this 16, change the name to 16, and change the scale to 0.08, both here and here. So now you can switch between different colors, and we can also switch between different scales, which will modify this variable. So now that means that we can use this scale variable from the state to also show it right here. Of course, it's not showing the actual numbers. We'll fix that later on. But at least we know that our modifiers are working. And now we can start getting closer to displaying this big model right here in the middle. To display something in 3D, we have to install packages that help us do just that. So run npm install. The most important one is 3, as in Three.js. Then we need a helper library called React-3/Drei, which makes it easier to work with Three.js within a React environment, which is composed of these UI components. And then finally React-3/Fiber, and then run enter. While that installs, head back over to the product viewer. And for now, we will render a canvas right here below all of these divs where we have this p tag, simply by saying canvas. This, of course, has to be imported at the top, coming from React-3/Fiber. Give it an ID equal to canvas. And if you save it, you won't be able to see anything within it. So let's add a box coming from React-3/Drei. Here it is. You can play with that box by maybe modifying the position a bit, such as setting it to -1, 1, and 0, which will move it across the space. In Three.js and in any 3D environments, we have 3 axes, X, Y, and Z. X is left and right, Y is top and bottom, and 0 is how far or how close the item is. If you increase the Z, you'll see that it'll get very close, so close in fact that maybe it'll jump off the screen. But if you make it smaller, you'll see that it'll go further away. I always recommend that you play with those values and see what each one does. We can also modify the scale a bit by setting it 10 times the scale that we have chosen from our application. So you can see now, it'll actually modify the box size depending on what you click. And check this out as well. You can also apply a material-color to it and set it to the color coming from our state. So now it's dark, and now it's white. And this box can be a self-closing component. And it appears like it's not properly centered, is it? So we can give this canvas some camera properties, such as a position of the camera, not of the box, to 0, 2, 5. We can also give it an FOV. This stands for field of view, which I'll set to 50. I'll set the near plane to 0.1 and far to 100. Now, if you reload, you'll see that the camera angle will have changed. And you can continue playing with it until you have it perfectly centered. And the most important thing is to be able to interact with it. For that, you need something known as orbit controls. And you can also give it a property of enable zoom and set it to false, because we don't want to be able to zoom, we just want to be able to move it around. Right now, it's either super light or very dark, so we can't really see the edges of it. But later on, we will light up our scene and you'll be able to see it in more detail. Perfect. So now we have created this section where we have a title, we have a canvas where we're displaying something, and then we have controls where we can actually modify the global state and change the values so that the canvas interacts with what we're changing. Now in the next lesson, we can focus on rendering not just the box, but the actual 3D MacBook model. Let's turn this cube into a MacBook. Thankfully, we already have a model for it within public, models, MacBook 14.glb. This is a 3D file. But before we can use this 3D model inside React 3 Fiber, we need to convert it into a React component. And for that, we'll use this gltf 2JSX package. What it does is it takes a 3D model and just through the terminal, it converts it into a nice React component. So back within our terminal, navigate over into /public/models. Here, you should have all the different models. And then run npx gltf JSX MacBook 14.glb -T. This command will convert the MacBook 14 GLB file into a React component, and the -T flag will flatten the transformation, giving us a cleaner structure. If you press enter, it's going to ask you to install that package. So press Y, yes. And if it needs some additional permissions, you can add sudo in front of it. But in this case, we're good. It looks like it generated a new file. So let's check it out within our application. It's this MacBook 14.jsx, but now we want to move it within a new component that's going to be within the components folder. So within components, create another folder and call it models. This will be for our 3D models, and then simply drag and drop this model within the models components. Here it is. And it's going to look something like this. Now, we want to apply some changes to it, such as renaming it from model to MacBook Model 14. And we can also export it as a default function. So we can say export default function MacBook Model 14 because it's the only thing we'll be exporting from this file. Then we need to update the model path, use gltf, coming from /models /MacBook 14 transformed.glb. Let's make sure that exists by heading over to models, MacBook 14 transformed.glb. It is here. And then we also want to apply a texture to this laptop by saying const texture is equal to use texture /screen.png. This allows us to add some kind of a screen image over to this model. Then we have all of these different meshes or geometries that together make this model. The only mesh we need to change is going to be second to last one, this one right here, 123. I want to expand this one so it's not a self-closing div. And within this mesh, we want to display a screen. Don't ask me how I know this. It's impossible to tell just by the numbers, but you had to just render the model before and then see that under 123, that's actually the screen. I'll show you later on what happens when we change it. So here, I'll render a mesh basic material, which allows us to apply a map of the texture coming from the screen image, just like this. And then at the bottom, you say use gltf preload / and you have to change this to models MacBook 14 transform GLB. Perfect. And now before we check it out, let's quickly do the same thing for the MacBook 16 code. We're still within the models folder within our terminal. Run npx gltf JSX MacBook 16.glb -T. Press enter, and it'll very quickly generate a new component. It's right here, so you simply need to drag and drop it into source components models right next to version 14. As before, we'll have to make some small adjustments to it, such as modifying the path right here by saying /models / and at the bottom /models /MacBook 16 transformed. And we can also use the texture by saying const texture is equal to use texture /screen.png. Now we can use that texture right here within the 123 mesh, which is actually the screen, where we can apply a mesh basic material, which basically allows us to render an image through a map of texture coming from our screen.png. And one more time, we want to follow the same process for the last model, MacBook GLB. We'll use this one later when we implement a section where the MacBook texture changes as we scroll to the bottom. So as before, just run this, but instead of saying 14 or 16, just render it like this, and then drag and drop this new model into the models folder. Don't forget to change the path to /models, as well as right here. and then later on we can change the texture. For now, let's put the two models, the 14 and 16, to use right here within our product viewer. Instead of rendering a box, we'll render a MacBook model 14, pass to it a scale equal to 0.06 and position equal to -1, 0, 0, and self-close it, and make sure to import this model at the top from where we created it. You can pass any 3D props to the MacBook model because if you take a look at it, it expects all the props and just passes it down to the 3D model. Now, if you reload, you'll be able to see the model right here, but it's a bit dark. So if we try adding some kind of an ambient light, maybe with an intensity of 0.5, that'll light up the keyboard a bit more. So it's not super dark. Maybe for the position, we can keep it 0, so it's centered. There we go. And if you increase the light a bit, like let's say to 1, you'll see that it refracts the light a bit differently. But of course, we're still not quite there yet. The model is there and we can move it around, but take a look at the final version. It is much more polished. Making it go from this to this has a lot to do with lighting it differently. So let's do that next. Let there be light. We'll create a lights component that defines all the lighting for a 3D scene. It'll use a mix of environment lighting and spotlights to achieve an Apple-like studio photography look. Go ahead and create a new file within the components folder and call it studio lights.jsx. Run RAFCE, and then go ahead and import it right here within our product viewer instead of the ambient light. If you do it just like that, it'll break because we're trying to render a div within a canvas, which doesn't work. Lights have to be parts of the canvas as well. So I'll turn it from a div to a Three.js group with a name of lights. That on its own won't do anything, but it'll fix our view. And within it, I'll create a new environment coming from React 3 Drei. This will wrap the scene with lighting. And if we give it a resolution of 256, it'll add subtle reflections to metallic and glossy surfaces. Resolution of 256 is balanced for performance and detail. Within it, let's render another group. And within that group, we can render something known as a light former, coming from React 3 Drei. It's a self-closing component. This will simulate a large, soft, rectangular studio light. Apple often uses these softbox lights to highlight product edges without harsh shadows. So let's give it some properties, such as form of rectangular light, intensity of 10. Let's give it a position of -10, 5, and -5, a scale of 10, and if you save it, you can see that it's kind of coming from the left direction, right? Yeah, it's coming from there, definitely. If you change it over to 10, it'll be coming from the right, or maybe far right. It's too far. What if we bring it a bit closer? 20. Yeah, you can see how it's starting to light up a bit more. Perfect. We can also rotate it a bit by giving it a rotation -y of math.pi. And yeah, you'll have to use a lot of radians and degrees in Three.js and divide it by 2. So we just give it some rotation. I will now duplicate this and create another light former with the same intensity, but with a different position. It'll be 10, 0, 1, coming from the right side. And this will now properly light up the entire model. Beautiful. We could call it a day right here, but I also want to teach you how to add some spotlights. So create a new spotlight with an angle of about 0.15, a decay of 0, intensity of math.pi times 0.2. And now if you reload, you'll be able to see that there's going to be a new light coming in. Maybe we can remove this environment so you can see just the spotlights. It seems like it's coming right at this spot. If we increase the angle to maybe like 1, you can see that it's much larger, but I'll bring it back to 0.15 and I will position it a bit differently by giving it a position of -2 So you can see that this dot will now move off of the screen. I'll also give it 10 and 5. And now we can see how it's hitting the screen from the top. Pretty cool, right? Now let's duplicate it 2 more times. For the second one, I'll change the position to 0, -25, and 10. There we go. So now it's coming from the bottom a bit. And also the last one, I'll change the position to 0, 15, 5. And now it's also coming from the sides. Again, you can play with this and come up with something that looks and feels the best for you. In the last one, I'll just change the decay to 0.1, and I'll increase the intensity from 0.2 to 3. So this way it'll shine even brighter. But again, feel free to modify it however you like. And now if we bring back our previous studio lighting alongside these spotlights, it'll feel like a more complete look. Maybe we can decrease the last spotlight just a tiny bit. And there we go. Take a look at this. Beautiful. So now you get the idea that it's not only about the models themselves and the meshes, or even displaying a specific texture on a mesh. So this was the default. You can see how it wasn't high res, but we ended up adding this more higher res texture on the screen to get something like this. Hopefully that makes sense. But yeah, it's not only about the meshes and geometries and materials. It is also about lights. Because if we now remove the studio light component, we don't have anything besides the screen. But if we bring it back, it looks great. Perfect. Congrats on adding the lights. In the last lesson, so far, we've loaded up our 3D model and added the lights. But now we'll animate it so that when you move it around, it always returns to the center position. And you can also switch between different sizes. We'll do that using GSAP. So open up your terminal and run npm install GSAP and @gsap/react. Alongside that, we'll also need another small package called React Responsive, which is used to apply conditional animation logic and layout depending on different screen sizes that your users are on. So just install it. After that, we need to register our GSAP plugin. We can register it within the app.jsx because that's our entire application. So right at the top, just import scroll trigger coming from GSAP/all. And also go ahead and import GSAP coming from GSAP. These two imports are importing the main GSAP library, as well as bringing in the scroll trigger or any other plugin like maybe split text that we'll be using throughout the application. Scroll trigger will let us animate things based on the scroll position, such as pinning, scrubbing, and triggering. And yeah, GSAP plugins aren't automatically active. You have to register them. So adding this single line, gsap.register plugin, and you can say scroll trigger right here. Later on, we might want to add a split text. Make sure that your plugin is globally accessible across your entire application. So putting it in app.jsx is a great choice. With GSAP installed, we are ready to create a new file. And this one will actually be a Three.js component. So under components, I'll create a new folder and I'll call it 3. Within 3, I'll create a new file called model switcher.jsx, which will handle the transitions between two different models. It'll be responsible for rendering both MacBooks, 14 and 16, detecting the size from the user UI, and animating transitions between the two models using GSAP. It'll also implement something known as presentation controls, which will allow users to rotate and inspect the MacBook in 3D. So first things first, before we even add anything into this model switcher, let's go ahead and import it right here within our product viewer by saying import model switcher from .3/model switcher. Oh, and I just noticed Studio Lights are a Three.js component as well. They're not a typical div. So I'll also put the Studio Lights within 3. And yeah, make sure to also change the import. Once you import the model switcher, we will render it right here within the canvas. That's the difference between regular components and Three.js components. Three.js are within the canvas, and they can't be a typical div. They either have to be a mesh or a group. And instead of rendering these basic orbit controls, I will now render a model switcher as a self-closing component, and we have to pass a prop of scale to it. Now we'll change the scale depending on the screen size we're on. For that, we'll use that responsive package that we installed not that long ago. So I'll check if we are on mobile, and if that is the case, we can check it by using the use media query hook coming from React Responsive. And the query that we'll check for is max width is 1024 pixels or lower, since we're using the max width. This means mobile or tablet. So if we are on mobile, we'll check that right here. And if that is the case, we'll provide a scale of minus 0.03. Else, we'll provide a full scale. This will make it look better on mobile and tablet devices. So now let's go over to Model Switcher and let's develop its functionality. First things first, run rafce to create a new functional component called Model Switcher. Then accept a prop of scale. Oh, and we can also accept the isMobile prop here. So let's go ahead and pass it over from our product viewer. IsMobile is equal to isMobile, just so we don't have to call the hook one more time. And alongside getting these two props, we can also create new references. Small MacBook ref is equal to useRef, as well as a large MacBook ref is equal to useRef right here. useRef is obviously coming from React, so make sure to import it at the top. There we go. And now we'll have to choose when to show a big one or when to choose a small one, depending on the scale. So we'll say const show large MacBook. If the scale is equal to 0.008, this will be set to true. Or if the scale is equal to 0.05, then this will be set to true as well. Now within JSX, I will render an empty React fragment. And within it, something known as presentation controls. Within them, I'll render a group with a ref of large MacBook ref. And within that group, I will render a MacBook model 16, which we have to import from the right file. Let's try to find it within models, MacBook 16. Did we change the name right here? Oh, I forgot to rename it and to export it as default. That is very important. So just do export default function, MacBook model 16. And you can do the same thing for this one. Export default MacBook model. Perfect. So now, if we head back, you can now import that 16 version. And to it, you can pass the scale of if isMobile. In that case, you can pass a 0.05 scale. Else, you can pass 0.08 scale. This is just to make sure it looks good on all different screen sizes. I will now duplicate this presentation controls right below. We'll render the small MacBook ref. The smaller one is the 14 model, and the small is 0.03 on mobile and 0.06 on desktop. So now we can see so many models right here. Definitely not what we want, right? But I think this just shows you that we no longer need just a singular model, MacBook 14, right here in the canvas, because now this model switcher will render different models depending on what we click on. So to both of those, let's pass and spread the controls config. This controls config will be an object where we can define how we want to move around this 3D model. Right now, nothing is applied. And maybe instead of showing both, let's just show one for now. So I'll comment out the other. So now you can see that you can move it around however you please, and it stays that way. But you can give it a very simple property of snap to true. What this will do is it will snap back when released. So now if you move it around and you release, it goes back. So even if you mess with it a lot, it always gets back to the frontal vision or to the general position. You can also pass the speed in which you can slide it around. Zoom is there as well. All of that works normally. Now there's a polar angle, which we'll set to math.pi or minus math.pi and math.pi. Now what this does, you can think of these as vertical rotation limits. If you bring the polar back, you can actually slide below and see it, whereas if you remove the polar and reload, you cannot go any more down. Which maybe I even like, because you'll never be looking at the bottom, you'll be looking at the sides. There's also the azimuth, which is the horizontal scroll, which I'll set to -infinity and infinity, which means that you can slide horizontally however much you want. There we go. And it'll always go back. Let's see how many circles can we make it make. Oh, okay. Pretty cool that it doesn't rotate in as many circles. It just gets back one circle, right? Amazing. And you can also set up some additional physics, such as config is set to mass of 1, tension of 0, and friction of 26. What this does is it tries to replicate real-world physics as you move this device around with mass, tension, and friction. Now, let's create some helper functions right at the top of this model switcher that allow us to fade the different meshes and move the different groups. I'll first outline some constants, such as the animation duration, which I'll set to 1 second. Same for the offset distance. I'll set it to 5. This offset distance is how far one model will move off screen when it's hidden. I'll create my first utility function called fade meshes. It'll accept a group and the opacity, and it'll open up a function block where we first check if a group doesn't exist, we exit out of the function. We just return. But if a group is there, we want to traverse all the elements within the group, get access to each of the children like this, and then for each one, check if child has a mesh, then we can change the mesh of that material to transparent by setting it to true, and then use the GSAP property .to on the child material to apply the opacity throughout a specific duration that will be set to animation duration. And this has to be within an object. GSAP, of course, has to be imported from GSAP at the top. And what we're doing here is we're setting the material to transparent at the start, but then we'll animate it slowly so that it looks like it's coming to life. Then we can do a similar thing for moving the element by saying move group is accepting a group and the X, and this will allow us to animate the horizontal movement of a group. As before, we'll check if a group doesn't exist, then we'll return. But if it does, we'll use GSAP to animate the group position to the following X position over a following duration of animation duration. I'll collapse these two functions, and now we'll be able to use these two utility functions within something known as use GSAP, which is a custom hook coming from GSAP React, making it easier to work with GSAP within JSX components. So right here, above the controls config, I'll define the use GSAP hook, and like useEffect, we can make it run whenever something in the dependency array changes. In this case, whenever the scale changes. So right here, we want to animate the movement of a group from a large to a small MacBook. Right now we're in 16, so I'll say small MacBook ref dot current to get the current position, and we'll move it by the offset distance, so minus offset distance, or move group large MacBook, we'll move it to the position of 0. Then we can also fade out the small Mac and fade in the large Mac as it is moving. So I'll say fade meshes. I'll fade in the small MacBook ref dot current to 0, and we'll fade in the other one, which is the large MacBook ref. We'll fade it over to 1. And we have to do the same thing, but if we're currently showing the small Mac. So I'll say if show large MacBook is true, then we want to run all of these. But if we're currently showing the small MacBook, then we want to do it the other way around. So I will duplicate all of this, but we'll change the values to small MacBook ref dot current to 0, and the other one will move it by the offset distance. And we want to change the opacity to small to 1 and large one to 0. So now if I save it and reload, it's currently on 16, but if I move over to 14, it slides away and a new one should technically appear. Oh, and wait, it will as soon as I comment this one in, because that's the 14 model. So one more time, 16 slowly fades out to the right, and 14 slides in from the left. And you can see that now we have a full presentation of controls over the two models that we can switch between and move around. Next up, we just have to change the color. To change the color, we can head over into one model and then the other, and then apply that color. So head over into MacBook 14 models, and then we'll have to extract that color from the global state by saying const color is equal to use MacBook store, which you will have to import right here at the top, coming from store index.js or just coming from store. Then we'll also need to get the scene from our transformed GLB model, and then we will use a use effect to apply that color across all of the different meshes. I'll say use effect, create a new callback function, and run it whenever the color changes. In this case, it'll change whenever we change it right here. What we want to do then is call the scene and then traverse through it. We then want to get access to each child from the scene, and for each one, we want to check if that child is a mesh. And then here, we want to change the color only if the part name is not in this list that I called no change parts. So what is this no change parts? Well, it'll come from constants. So head over into constants index.js, and alongside the nav links, we can also export and create no change parts. And this will be an array. Just so we don't have to write it down manually, you can find it within the video kit down below. If you scroll down under snippets to copy, you can copy the entire constants index.js and override what we have right here. You'll notice that here, I created an array of different names to which I do not want to apply the color. I manually went through every single mesh and I checked whether that color is an outer part of a MacBook. If it is, we want to change its color. But if it's the display or something else, then we don't want to touch it. So now that we have this no change parts, and now that we're exporting it from the constants, we can now import it right here and say if not no change parts dot includes the child name. In that case, we want to change the child.material.color to be equal to new 3.color, and want to apply the color that we're passing right here from the state. Now, before you save it, make sure to import 3 by saying import everything as 3 coming from 3. Or in this case, we're just using the color functionality. So you can say import color from 3, and then you can do it like this. Now, if you want to test it out, we need to switch over to the size that we made these color changes on. Right now, we've done the changes for the MacBook Model 14. So if you switch over to 14 and now test it out between light and dark, you'll be able to see the difference. Let's make it work for the larger model as well by copying this part entirely, heading over to 16, and then just pasting it over here. Make sure to import the color from the MacBook store, get the nodes, materials, and the scene coming from MacBook 16 this time, and then get the texture. After that, we apply the use effect across all the different meshes, but only the specific ones. And this means that we can now change the color for both MacBook sizes. Now that that works, we can now remove this piece of text right here that is right here within this product viewer. And we can now just say MacBook Pro available in 14 and 16-inch variants in space gray and dark colors. Perfect. You can keep it like it is, or if you want to, you can totally remove that piece of text and just keep the switcher. Perfect. And of course, keep in mind that this looks so much better on a larger screen where these colors and sizes can truly shine. Now, with all of those changes implemented, we want to run a new CodeRabbit session to see what it has to say about our code now. Now it has 4 additions, 7 modifications, many new lines added. So let's hit enter to hop into the review. Hopefully there are no ghosts of bugs pasts. Let's wait a bit more and see if AI really does know more than us. And there we go. As the Code Rabbit is reviewing your code, we can already see two potential issues that we can then expand. One problem is that we can avoid exact equality comparison with floating point scale values. If you press enter on that toggle, you'll be able to see more info about it. It says here that using triple equality with 0.08 is fragile because floating point arithmetic can introduce precision errors. If the scale value comes from calculations, animations, or user interactions, exact equality may fail unexpectedly. So it's always better to use thresholds, or if we know for a fact that these points are going to be exactly as they are, and we do know that because we have set them up, then it's better to define those scales as constants. And now we have a couple of options. We can either close the details, copy the prompt to fix this with AI, or apply the suggestion, or reject the comment. In this case, the change is super simple, so I can go ahead and implement it manually by copying these couple of lines, heading over to the model switcher, and then right here at the top, we can define different scales, and then just modify this line to use these new constants. With that, our code is more predictable and descriptive. Going back to the terminal, let's now collapse this issue because we fixed it, and let's head over into the first issue right here, where it says that we need to add a missing dependency to the use effect. The scene object is used inside the use effect, but not included in the dependency array. If the scene reference changes on model reload, the effect won't rerun with the current color. That is actually a super nice suggestion, and I just pressed the letter A, and it seems like it fixed it on its own. Let's head over to the model 16, and there we go. The scene got added. That's great. We can also do it for the model 14, where we can add the scene. Now we can head over to the next issue within our index. Here we have some inconsistencies within the text. This one for sure I will automatically fix by pressing the letter A. And then finally, the color typo in the reset function. It resets the color to 2E2C3E, but the initial color is 2E2C2E, so it's a bit different. So let's go ahead and auto fix it. If you head over to the store, this actually shows you that you can completely change the color of the model if you want to. So if you want to change it to something entirely else, you can do that. Like this is a nice greenish color, and you can see how differently this MacBook looks like. You can go with something much different. Let's go with 3/7, and this actually gives us a nice grayish color. Or if you want to go with something darker, this works too. So if you want to add multiple colors, feel free to do that. This was a great catch and definitely not something I would have noticed on my own. So now we can go back to home, and with that, all of the suggestions had been implemented, which means that we're finally ready to push our code to GitHub. By running git add git commit -m, implement 3D product viewer section, and git push. And just like that, our latest changes have been pushed over to GitHub. In the next lesson, when we implement the next section, I'll show you how you can also use CodeRabbit when we open up a PR from a new branch. CodeRabbit CLI is great for getting the fixes directly within your IDE, but where it truly shines is within PRs. Now, the next section we'll implement is this amazing video playback that shows you the M4 chip, allowing you to play those demanding games on that powerful MacBook. So since this section will be a bigger one, and for sure we'll need a PR review when we finish it, let's go ahead and immediately create a new branch by running git checkout -b and call it showcase. This will automatically switch you to a new branch, so we can dive right into it. Okay, here's the hero section. Here's the 3D model viewer, and then right below it, we'll have a showcase section. A section that opens up a full screen video, on top of which we'll display an overlay that'll show the user what powers this game. And that is a very powerful Apple M4 chip. And then we of course show some more info about it. So let's get it developed. I'll start by creating a new component within the components folder, which I'll call showcase.jsx. I'll then run rafce to quickly spin up this new showcase component, and then we can import it within app.jsx right below the product viewer. There we go. Here is the showcase. Heading right into it, we can start developing its UI by turning this div into a section that has an ID of showcase, so we can actually scroll to it from the navbar. Then within it, I'll render a div with a class name equal to media. because within here, we'll play this video on repeat. We'll use a regular HTML5 video element that'll have a source of /videos/game.mp4. So as soon as you do this, you'll be able to see what appears to be a photo, but is actually a video. And since this section is very visual, I want to expand it a bit so we can better see what's happening. I'll set it to loop, I'll make it muted, and I'll make it autoplay as well as plays in line. That way we don't have any kind of controls to scrub the video. Rather, we'll play and pause the video depending on the scroll. That's where GSAP comes in. So now if you reload, you'll be able to see this beautiful video, which has to be high res because it's showing on full screen. Now, with that in mind, I want to apply a mask on top of that video. So right below this video element, create a new div that has a class name equal to mask, and within it, a self-closing image with a source of mask-logo.svg. So typically, whenever you are applying masks, you're using SVGs because they're super easy to show on top of other content. Right now, that mask is dark and it is right here below. So you can see how it looks like if I click and hold and then drag and drop it over it. We want to align this and make it cover the full screen and make it show as we scroll. But while we're here, let's also pause this video for a second, just so it doesn't continue scrolling. And let's implement the section below the video. So we'll go below these two divs and create a new div with a class name of content, another div right here with a class name of wrapper, and then another div right here with a class name of, on large devices, maxWMD. That way it won't take the full width of the screen, rather it'll stay in the middle. I'll give it an H2 and I'll call it rocket chip. It's super fast. Then below it, I'll render a div with a class name of space-y-5, margin top of 7 to divide it a bit, and padding E, PE, that's inline end, 10. Now within it, we can display another p tag and say introducing, then we can put a space, then still within this p tag, but now within a span that'll have a class name of text-white, we'll display M4, the next generation of Apple Silicon. And then after the span, I'll say dot M4 powers. Then, continuing with the rest of the UI, we can create another p tag right here, and we can compare it with the final website. If you scroll down, you'll see that here text is much bigger, and I'll copy both of these paragraphs. I'll start with the first one, and then I'll create another p tag below it, and I'll paste the second one. Finally, below that second p tag, we'll need to create another p tag, which could technically be an anchor tag, with a class name of text-primary, and within it, I'll say learn more about Apple Intelligence. Finally, we just have to create these two small sections up to 4 times faster pro-rendering performance than M2. So let's do that by heading 2 divs down, 1 and 2, create another div to encapsulate that section with a class name equal to maxW of 3XS and space-y-14, and then 2 more divs, each for its own section. One with the class name of space-y-2 to create some space in between the elements, and then a p tag that says up to, below it, an h3 that says 4x faster, and then below it, another p tag that says pro rendering performance than M2. And we can say 4 times faster pro rendering performance. This is good. Now we can duplicate this just below. And for this one, I'll say up to 1.5 times faster CPU performance than M2. So now if we head back over to our current application, it'll look something like this. This is just plain structure. It's plain text and elements that we can then animate. So let's start with implementing this stunning video mask effect. Right at the top of this file, I'll first get access to the isTablet variable, and this will be equal to useMediaQuery. Remember that React responsive package we installed, which allows us to figure out on which device are we loading this application. For this one, we want to know whether it's tablet, so we'll trigger it when the max width is smaller than 1024 pixels. And now we can put GSAP to use. by using the use GSAP hook, within which we're going to check if we're not on tablet, then we can start applying the animation. Of course, we have to keep track of the changes in the is tablet state, and every animation starts with a timeline. We need to move something through time. So say const timeline is equal to GSAP, which you have to import right here at the top by saying import GSAP from GSAP dot timeline. Then to it, you can pass some additional options, such as scroll trigger. We want to trigger this animation or this timeline not on click, but rather when we reach the showcase section. Specifically, we want to start it when the top of the screen reaches the top of the section, and we want to end it when the bottom of the screen reaches the top of the section. We want to apply a scrub set to true, so we're actually animating the timeline with our scroll, and we'll also pin it. So now that we have this timeline, we can call it by saying timeline.to.maskImg. So we're now animating something within that timeline. In this case, we're targeting this div image element, and you can define what you want to modify for that element. In this case, we want to transform it. So I'll run transform, and the transformation we want to apply here is a scale of 1.1. So we're going to enlarge this image. And I'll also apply another .to function, in this case to the .content element, where I'll set the opacity to 1, Y position to 0, with an ease of power1.in. Then I will autoplay the video. And now before we go ahead and test it out, I just noticed that I made a small mistake right here. The ID here should be showcase. If you fix that, all the contents within it will show more nicely on the screen. And on smaller devices, this won't scrub on scroll, but immediately the mask will be on top of the video. But now check this out. If we enlarge the screen, reload, and start scrolling down, you'll notice that now you'll see the full game and you'll be like, what's happening? We're looking at Assassin's Creed here. But as you continue scrolling, it'll all start making sense because this game can actually run on your M4 rocket chip. Yep, that's the newest generation of Apple Silicon. Pretty cool, right? It's such an effective section that nicely complements the first two sections we've created. So with that in mind, let's go ahead and commit it by running git add dot git commit -m showcase section and git push. Since we created a new local branch, you also have to set it as a remote branch. You can do that by simply copying this git push set upstream command. And then back on GitHub, you'll see that the showcase branch had a recent push about 24 seconds ago, so you can compare it and open up a pull request. In production apps, you never push straight to main. You implement the features on your feature branches and then open up a pull request. And that's exactly what I want to teach you right now. So create a pull request, and if you go under files changed, you'll notice that we haven't really pushed the right changes. Back within our application, it seems like I was inside the models folder, and you always want to be within the root of your application when you're pushing it over to GitHub. So once again, run git add dot git commit -m implement showcase section, and then git push. This will now push the right changes over to GitHub with 11 file changes, and it'll give CodeRabbit plenty of code to review. And it looks like it already hopped on to do that. It may take a few minutes, so let's give this rabbit some time. We'll have to trust its mommy saying that it's the best code reviewer out there. Okay, first things first, CodeRabbit provided this nice summary where it says that we implemented a couple of new features. We introduced an interactive 3D product viewer with real-time color and size controls, responsive layout, and smooth model transition. And we added a scroll animated showcase section with pinned media and content reveals for an immersive viewing experience. Okay, so let's see the comments it came up with. There's a couple of nitpick comments, which are very small and you don't have to necessarily fix them, such as fixing placeholder links in the footer, or removing unused imports, or maybe memoizing the color, so we don't have to create a new one every time. But on top of these nitpick comments, there's also some major ones. And what I like about CodeRabbit is that it provides you with a complete analysis chain on how it came up with this review suggestion. It's suggesting to use sRGB color space so UI imagery isn't washed out. And it even provided an alternative if we're using an older Three.js version. Now, here are two super easy ways in which we can immediately implement these suggestions within our code. One is the committable suggestion, where you can review the snippet to be added, and you can automatically commit it to the code. The other one is a prompt for an AI agent to fix it for you. For this one, let's go ahead and commit it automatically by just saying commit and commit changes. There we go, suggestion applied. And it's going to update itself so that it's resolved. This was within MacBook 16. So if you head back over to your application and run git pull, you'll be able to see that there's going to be a new pull on MacBook 16 with the implemented change. So head over to MacBook 16, and you can see that now it's using this sRGB color space. But of course, always make sure to check what you're auto importing. In this case, the imports have to go above right here. And then inside of the component, we're using this texture and applying a color space to the texture. And then we have the rest of the code. And if you take a look at the screen right here, it's using the sRGB color space, whereas the V14 isn't. And if you're still not sure what these two lines do exactly, select them, press Command-Shift-B, and type Junie. If you don't have Junie installed, go ahead and install it by clicking the link in the description. But if you do, you can just ask it, what do these two lines do? And just like that, we got a short answer. Texture color space sRGB color space tells Three.js that the pixels in screen PNG are in sRGB space, so they should be gamma decoded on upload and displayed with the correct color management. No washed out or overly dark colors. And the needs update flags that the texture's parameters changed, so Three.js should re-upload the texture to the GPU on the next render tick. Otherwise, the color space may not take effect immediately. And now if you need a deeper explanation, it gives it to you here. But in simple words, we're doing this so that the color on the screen isn't washed out or using overly dark colors. This is a nice catch by CodeRabbit. So let's go ahead and apply it to MacBook 14 as well by copying these two lines, heading over to MacBook 14, and just pasting them right here below the texture, and make sure to import the sRGB color space. Now back to CodeRabbit's review. It has something to do with the use effect, in which we change the color of the meshes within the MacBook model. It says that this is a major issue where we need to clone the per mesh materials before recoloring to avoid cross-part bleed. Shared GLTF materials will recolor excluded parts if reused, clone once, and then set the color. Okay, that's nice. We immediately get a committable solution. But before we commit, let's also add and push the changes we have within our code, just so we don't have any conflicts, by running git add dot, git commit -m, add sRGB color space, and git push. But it nicely noticed that the diff is outdated, so we need to refresh and then try again. There we go. But in this case, I believe that this change isn't necessary, and rather, if we implement this, the color switching on our MacBooks will stop working, so we won't proceed with this suggestion. There's another suggestion saying that we shouldn't pass both the material prop and the child material, because the child won't reliably override. And I think this is true. This has to do with changing our screen, where we're applying the texture of what's being shown in the screen, but here we're also applying an additional material, and here we're adding a child material. So if I remove this material on the outside and head back, everything is still working as it did before. But now we don't have to be scared that it'll mistakenly render just this material instead of the child material, which is the actual screen. So I'll remove this material from the parent, both on version 14 and version 16. Perfect. Let's see what else we have. We have the constants here saying that we can add CSS definitions for box 1 and box 2. No matching selectors found. No, they should be there within the index.css file. So I believe with those changes implemented, we're good to go. But let's just not forget to commit our latest change by running git add dot, git commit -m, fix material override, and git push. With that done, all the checks have passed and we are ready to merge this PR into the main branch. Perfect. That's it. Oh, and while I was reviewing this PR, CodeRabbit also gave me a complete walkthrough of what we're implementing here. It split the changes by cohort and gave us a summary for each one of the files or the cohorts of files. For example, we have these 3D models, and sure, we know what those are, but if somebody else is reviewing our code base, it's super useful to get a very quick answer that these are GLTF components, and through them, we can apply store-driven colors across meshes. Then the model switcher is toggling between the large and small MacBook, and then we're using GSAP to move those around. And check this out, there's even a sequence diagram where we can see how a user can interact with our app. The user first loads the app, then we render the product viewer, which then reads from the store the color and the scale. The user can then change the color and the scale using the setter function. They set it, we update it, we apply colors, and finally we animate the positions using GSAP. It's so nice to have a visual representation of what we just implemented. And then here's the part for the showcase. I would have thought that it's impossible to show this using a diagram, but hey, you render it, we register the scroll trigger, we pin it to the screen, and then as we scroll or scrub the timeline, then the mask scales and the content fades and translates. Once again, it's super nice to see this visually. And at the end of the day, we're even getting a poem. This is not just auto-generated, but rather it's connected with what this PR just did. Three.js dreams and silver sheens, GSAP winds that softly glide. I flip my lid, colors bloom, a hop, a click, a state renewed, showcase and viewer imbued. Okay, well, that's quite something. So with that in mind, the changes are now here. These great sections have been implemented, and now we can move to the next section. Next, we have this next level graphics performance, where many different screens will reveal the MacBook in the middle. So back within our code, let's first run git checkout and move to the main branch and pull all the latest changes. Then we can create another branch either for the next section, or we can create one for sections to come. In this case, I'll do that by running git checkout -b, and I'll call it finalize landing page. Now that we switched over to that branch, we are ready to get started with implementing it. Just below this rocket ship, we'll focus on implementing the performance section next. So within the components folder, create a new file and call it performance.jsx. And you can also use RAFCE to quickly spin it up. Then back within the app.jsx, you can just render it below the showcase and call it performance. As a matter of fact, we can create all the other components that we'll also be using throughout the rest of this application. The next one will be called features. So let's implement a new file and let's call it features.jsx. You can also run RAFCE to quickly spin it up, import it within the app. Then we'll have a highlights section, .jsx, where you can run RAFCE and also import it within the app. And finally, we'll have the footer. That one is simple, so just create a new file, call it footer.jsx, run RAFCE, and then import it within the app. Perfect. 4 more sections to go. If you now start scrolling down, you'll see 4 different pieces of text, one for each of the sections. So let's move over onto the next one, which is performance, and let's start implementing the UI. I'll first turn this div into a section and give it an ID equal to performance so that we can scroll to it later on. Then I'll create a new H2 and just copy what the official website says. Next level graphics performance, game on. Below that, we want to render all of these images. We can do that by creating a new div, which you can call wrapper because it'll wrap those images. And within it, we can map over those images. I already stored them within the public folder and mapped over them within the constants index.js. So you can just import them from there, and you can see that each image has its own ID and the source. So now you can just run that map for each image. You can automatically return an image element with a source equal to image.src, an alt tag of ID, and we can also give it a key equal to image.id. And since we're mentioning image.source and ID too many times, we can just destructure it right here by putting it in curly braces. And that way you don't have to repeat yourself and say image dot every time. Now, if you do that and head over to desktop, you'll see all of these images one by one being rendered right here. Below those images, we want to display some content. So I'll run a div with a class name equal to content and a p tag. Here, we want to display some text, such as this one right here. And specifically, we can highlight one sentence, one that says that gaming feels more immersive and realistic than ever. So that one, I will put within a span element that has a class name of text-white. So let's nicely enclose it within this span element. And if you do that, you should be able to see the text somewhere here if it's not hidden by the images. And we also have to create an extra space right here before the span and then after the span to connect it with the rest of the text. Now we'll animate this text and the images. But for this section, I want to try something different. I wrote a prompt and I want to try to give it to Junie to see how well it does. So just press Command-Shift-P and open up Junie. We can start a new session, and this time we'll allow it to code. I'll give it access to a specific file as the context. In this case, we're working on the performance section, and I'll paste the prompt that I wrote. I will leave this prompt as well as the final output in the video key down below, so you can test it on your end, and if something doesn't work, you can always just use the final code. Now let's go through it. Junie, I need some GSAP animations added to the performance section. Here's what I'm after. The paragraph inside the content should fade in and move up slightly as it scrolls into the view. On desktop, I also want the performance images to animate into their positions using a scrubbed scroll timeline. Each image should be targeted by its ID class, and their final positions should come from the constants. On mobile, only the text animation should run, no image timeline, use GSAP with the section ref for scoping, and so on. The end result should be a smooth text fade slide as you scroll. In the desktop, the images settle into place in sync with the scroll. So let's see how well Junie does. Before it starts writing the code for you, it actually goes through the project and tries to understand what's happening. It's opening up index and CSS files just to get a better understanding of the codebase. And only when it reviews it, it then updates the task progress. Because now it knows exactly which images we're talking about, what are their final positions, and it's diving into implementing the animation. So it's editing the performance file as we speak. You can review all the changes in real time, and now it's including the triggers. I'll give it some more time to finish it before we check it out. And there we go. In real time, as I was speaking, it implemented GSAP animations for the performance section with scoped section ref. So now if you open up the performance section, you'll see that right at the top of the component we implemented, we now also have this use GSAP hook. In this case, we don't have to register the scroll trigger plugin because we've already done that in the app. But other than that, let's see how well it implemented the animation. Oh, and we do need the scroll trigger import after all to refresh the resize. So we can leave the import right at the top. Now, if I get back to the code and I start scrolling down, you'll see that it actually slides all of those images very nicely. It's still not yet perfect, as one of those images is the actual MacBook, which should remain in the middle so that the final application looks something like this. But I gotta say, Junie got very close with the animation. Now, let's go through it together and see where we can tweak some things. I'll first use this isMobileRef by using the useMedia query so that we know whether we are on a tablet device or not. By applying a query of max width of about 1024 pixels. Then, right here, we're animating the text. We're targeting the P element within the content and modifying its position. In case the only thing I wanted to do is to just modify the opacity and move it up a bit. So I'll make it start from the opacity of 0 and the Y position of 10, and then change the opacity to 1 and the Y position to 0. With an ease of power 2 out, the duration can remain. The trigger can be .content P, so when the top of that element enters the bottom of the view, and we'll end it when the top of that element enters the center of the view. And no need for these toggle actions. Rather, I'll just set the scrub to true, which means that it'll animate it as we scroll. And that is our text animation. So now if you reload and scroll down, you'll notice that the text actually scrolls in with the images. Perfect. Now let's look into the animation for the images. We want to make sure this is desktop only. So instead of doing this match media, which is indeed a built-in GSAP feature, we'll use that handy package by saying if is mobile, return, meaning don't apply any further animations. But if we are on desktop, we'll create a new timeline, TL, by saying gsap.timeline. Oh, it's already being created right here. That's good. And then for it, we'll apply some defaults, such as ease of power 1, dot in out. We'll apply a duration of 2 seconds and a override set to auto. This will automatically handle the conflicting animations. For the scroll triggers, we'll use the entire section as the trigger. We'll start the animation when section top hits the bottom of the viewport, and we'll end the animation when the bottom of the section hits the top of the viewport. We'll set the scrub to 1, which will sync the animation with the scroll, direct sync, and we'll invalidate and refresh, which means that GSAP will recalculate trigger points whenever a screen gets resized. And now we need to animate each of the images to their final positions. But we don't want to do it for P5 because P5 is the MacBook image. If you head over to public and then see the image 5, you'll see that that is the actual MacBook. So that one we don't want to animate. So right here, I'll check if item or position.id is equal to P5, then just return, skip the animation. If you do this, and if we end everything properly, let's see whether we have closed everything. Well, I will remove this bottom part for now, just to make sure we're closing it properly. GSAP starts here, ends here, and then we'll add this scope and section ref later on. There we go. Now it's good. So if I scroll down, you'll now notice that the MacBook stays in the middle. So nothing is being applied on it. We just have to fix the animations a bit. So let's fix those positions. First, I will remove this initial offset. If you do that, you'll notice that there's no lowered opacity. All of them are at their full opacity. And then we're checking for different positions. We're checking if each one of these images has its position, like let's say ID with a P1 has a left of 5 and a bottom of 65. That's the ending position we want to apply to this element. So that's why we say TL, as in timeline, dot to this specific class name that we target. Then we apply the two variables. So that's this object that starts with y0 and auto alpha to 1, but we can also start it from a basic object. And then for each one of these, if a left position exists, then we move it that much percent to the left. If a right one exists, or if the bottom one exists, we do the same thing. And finally, if the transformation exists, we apply the transformations. Then finally, we apply all of those GSAP animations to that specific element. In this case, we can remove this return, and instead, to this use GSAP hook, we can give some additional options, such as the scope of section ref, which means that we're limiting GSAP queries to work only within this component, as well as we want to add dependencies. So whenever the is mobile changes, we want to recalculate the positions. So now if you reload and go back, and if you scroll down, you'll notice that now these images will nicely reveal the MacBook. But you can notice that after we pass this section, they continue getting farther away. But they should actually get farther away as soon as we are looking at the screen directly. And to do that, we need to change this part right here, where we'll say that we'll end the animation when the center of the section hits the center of the viewport. So now if you reload, check this out. If I scroll down, the full animation will play out by the time when we hit the center, and all of the images will be that much farther away, revealing the MacBook in the middle. And then as I continue scrolling, they won't be moving anymore, but rather the text will be revealing itself at the bottom. This is beautiful. So Junie definitely helped us a lot with coming up with this animation, but we also needed to do some work on our end to tweak the animations to come up with that real human touch. With that in mind, this section is done. And if you check it out on a tablet device and reload, you'll see that it also looks good. Well, you could tweak the positions of the screens outside to work good on smaller devices as well. But if you go to something like a mobile or tablet, it still looks like there's a lot happening, right? You can do so many things on this MacBook device. Again, if you want to make a bit more precise circle of apps around the MacBook, you can just head over into constants and then animate them to different positions depending on the screen size. you would maybe go something like this, desktop, and then you would put the left and bottom within desktop. And you can also apply different positions for mobile or for tablet, which would make it look great on all sorts of different devices. And then you can animate it over within that GSAP section that we just implemented. With that in mind, we can check it out with CodeRabbit by just running the CodeRabbit command and then pressing enter to see what it has to say about our changes. Looks like we only got 2 issues. One is in the footer, and we should be using the semantic footer element. Yep, we'll change that later on. And then the second one is in the performance component, where we need to use the alt attributes for the image's accessibility, which I entirely agree with. So we can just press the letter A, which will automatically apply the suggestion. Good. With that in mind, we are now ready to commit the changes by running git add dot git commit -m implement performance section and git push. Since it's a new branch, we have to set the upstream, so we push it over to our remote repo. We won't be checking out the PR just yet. We'll first implement the other sections to come, and then we'll do it at the end as one final PR check. Next up, see it all in a new light section, which will be the feature section of our landing page. We'll have the same MacBook model as before, but this time with an animated video screen. And then as you scroll, not only will we display additional features on the left and the right, but we will also rotate the MacBook to show in video on the screen what that feature is all about. This is an amazing use case and combination of both GSAP and Three.js. So let's do it together. Back within our code, now we want to navigate over to components and features. This is where we can turn it into a section that has an ID of features and add an H2 that'll simply say, see it all in a new light, like on the design. But before we go ahead and display it, there are 2 things we have to do. First, we have to head over into our store. That's store index.js. And here, we will now be modifying the texture of the screen as we scroll, so we have to change it in the global state. For that reason, I'll choose the current texture, and we'll start with it being the video's feature number 1.mp4. But then we also have to have a setter function, such as setTexture, that allow us to change what's being displayed on the screen as we scroll. And also when we reset, we can reset the texture to be just the initial video. Perfect. Now let's go to the previously generated MacBook model. It's right here within Models, MacBook. Not the 14, not the 16, but just the regular MacBook. And here we want to add a support for the video texture. We can do that by extracting the color and the texture, which is the video, coming from or is equal to use MacBook store. Then from this use GLTF model, we also want to get access to the scene and make sure that the path is right. It's macbook-transformed.glb. Once that is done, you can say const screen is equal to use video texture. This is a very nice utility function provided to us by React 3 Drei, to which you can just pass a video. In this case, it's texture, because the path right here is coming from the store, pointing to an MP4 file. Then we want to do the same thing as we've done in the previous MacBooks, and that is just to change the color of it. So I'll copy this use effect and just paste it below, where we'll have the scene.traverse, check if it's a mesh, and if it is, we will change the color. And then of course, if you head over to the mesh 123 geometry, we have to remove the screen material and rather make it accept the child, which will be the actual mesh basic material that'll show the screen texture. Or in this case, it'll be just the screen. I believe that's how we called it right here at the top. And that's it. This now means that as before we rendered a texture that was an image, now we're passing over a texture that is a video, and that video is coming from a store, and we can modify it as we scroll. So let's develop it by heading over into Features and creating a canvas within which we can display this 3D model. This canvas is coming from React 3 Fiber. It'll have an ID equal to F canvas, as in features canvas, and we can immediately play with the camera position of the element we'll show in there. For now, I'll just leave it blank. Pretty cool thing is that we already created a component called Studio Lights, which automatically lights up our scene. And we can also apply an additional ambient light of an intensity of 0.5. And then here below, we have to render our 3D model. Before we do that, let's just display a list of features that we want to display below the canvas. So I'll render a div, and that div will have a class name equal to absolute, because it's going to show outside of other elements in the screen, and inset 0. Within it, we can map over our features coming from constants, and then for each feature, we can automatically return a div with a class name equal to, it'll be a dynamic class name, so we have to import CLSX, and it'll always have a class name of box, but we also want to apply an additional class name depending on the index of the box we're rendering. So I'll get the index, and I will say dynamically give it a box and then index +1. So box 1, box 2, 3, and so on. And then also we want to apply some additional styles by saying feature.styles. Because within constants to each one of these images, we're positioning it in a different part of the screen. You can see that right here. Email is on top left, image is on top right. Then we have middle, summarize AI, and at the bottom, airdrop. These features won't show on the screen just yet because we have to animate them into place. So for now, I'll just render a piece right here that says feature.text. Even though it won't show yet, it'll show when we animate it in. So now we have to implement this 3D model. And to do that, I'll create a new component right here on top of our features, and I'll call it model scroll, because it'll be a 3D model that, well, scrolls. And it's going to be a React component on its own. Within the return part of that component, we can just return a 3 group with a ref equal to group ref. And that's a ref that we can create right here at the top by saying const group ref is equal to use ref coming from React, starting as a null value. Then I will load it within a suspense. That means that we can display some loading as it actually loads up, because here we're displaying a video component and it does need some time to load. Instead of just a regular fallback that says loading, we can now display HTML elements within a Three.js canvas. So for that reason, we have to give it a fallback and wrap it in HTML. That then allows us to render some HTML elements within a Three.js canvas. In this case, I'll just return an h1 with a class name equal to text-white, text-3xl, and uppercase, and I'll simply make it say loading ... Now, once the loading is finished, we want to display a MacBook model, the one we created, with a scale of, and now depending on whether it's mobile or not, we want to give it a different scale as before, so we can get access to this is mobile and make it equal to use media query. And the media query we'll use is a typical tablet one, so that'll be a query of max width of 1024 pixels. And now if we are on mobile, in that case, we'll give it a scale of 0.05, a bit smaller, else 0.08. And we can also modify its position, where it displays on the screen. It'll be 0, -1, and 0. So we'll move it a bit down on the y-axis. And now we can render this model scroll right here within the canvas. If you do that, you'll see this loading that I was telling you about, and then a new MacBook that'll load with the video number 1 playing. But as we scroll, nothing will happen. So I'll drag this a bit to the right so we can still see the video playing. Let's make it tablet size. And now let's slowly start animating it. I'll first get access to the setter function called setTexture, which is coming from Use MacBook Store, the global store of our application. That'll allow us to change the video on scroll. Next, the first thing we want to do is preload all feature videos during component mount. That way, we can easily just modify them within the screen as we scroll down. So I'll run a use effect, and as soon as the component loads, meaning an empty dependency array, oh, and don't forget to import the use effect from React, we want to go over the feature sequence coming from constants, and for each one of these features, we're going to get access to it and immediately preload it. We can do that by creating a virtual video element in memory, which won't be added to the DOM. I'll call it V, and that'll be equal to document.createElement of a type video. This will allow us to start downloading the video data without displaying it. Then we want to configure the video element with optimal settings for smooth playback by saying object.assign, V as in video, and then we can give it a couple of settings, such as the source, which is going to be feature.videoPath, muted, because we don't need any sound, plays inline to true. Inline here will be capitalized because we're in JavaScript. Preload will be set to auto, which means that it'll aggressively load all the data of the video, so it's ready to be played when needed. And then we'll also set the cross origin to anonymous, which will allow us to load videos from different domains, like a CDN. And then we can run v.load, which will start fetching the video. Perfect. So once we preload the videos, we want to enable the 3D model rotation on scroll. Remember this, how it rotates? Well, that's what we want to achieve. So right below, I'll open up the Use GSAP hook, and we'll start with a 3D model rotation animation. And we'll also pass an empty dependency array to this Use GSAP hook. Let's start by creating our first timeline, specifically for the model, so we can call it model timeline, and it'll be equal to GSAP, which we have to import from the top, dot timeline. So that's going to be import GSAP from GSAP, and then we can pass some additional options to it, which will be based on this scroll trigger plugin. We'll make the trigger the canvas itself. So as soon as the F canvas, the feature canvas, gets into the view, or rather, we'll start it when the top of that component gets to the top of the viewport, and we'll end it when the bottom of the component hits the top of the viewport. We'll set the scrub to 1 so that it is one-to-one matched with our scrolling, and pin to true. This will pin the canvas in place during the scroll, creating that scroll distance. So if you now reload, you can see how there's so much more scroll for the same thing. Now, once we have this timeline, we also want to sync the feature content. So different types of videos that are going to display different features. That'll be equal to timeline is equal to gsap.timeline based on the scroll trigger as before. And it'll more or less be the same thing as we had here. We'll simply have the scroll trigger. The trigger will still be the canvas. We'll start from top center. We'll end at bottom top. And we just want to scrub it, but not pin it. Perfect. Finally, we want to spin the 3D model by saying 3D spin. If groupRef.current exists, then we have the model timeline that will animate to, and first you have to choose which target you want to animate. So that is the groupRef.current.rotation. And to it, we'll apply some settings, such as the Y position of math.pi times 2. And what this does is it'll rotate it 360 degrees or 2 radians, 2 times math.pi, around the Y-axis. That means that it'll make a full circle. And we can do it with an easing, so ease of power1.inout. You'll see me use this one often. Perfect. So now the 3D model should be spinning as well. Check this out. It'll make a circle around the Y-axis. And finally, we have to sync the content and the texture so that these blocks appear around the model and that the video that's being played on the screen also changes. So let's do that next. I'll say content and texture sync. I'll open up the timeline and run the .call function, which allows us to call an additional function, in this case, set texture function, and we will set texture to /videos /feature-1.mp4, and we will animate the box at the same time, box1, to opacity of 1, so it's actually visible, y of 0 with a delay of 1. Now I'll go full screen so we can very soon see those boxes that appear. But for now, I will actually duplicate these two call and to functions a couple of times for all the different text boxes that we have. 1, 2, 3, 4. That way, we have the box 1, we have box 2, box 3, and 5, because we're starting from the first one. For the features 2, 3, 4, and 5. 5 different features. For all of them, we'll change the opacity to 1, the Y position to 0, and I'll remove the delays from all of them besides the first one because they'll be appearing one after another. We can also change the box names to box 2, 3, 4, and 5. Now, if you save this, you'll see this one that says summarize and draft replies to emails instantly so you stay on top of your inbox. Then as you scroll, the new video will load up and it'll say generate images and edit them with ease. As you continue scrolling, you'll see another one that says turn log articles and reports or notes into clear bite-sized summaries, and so on. And you can notice that sometimes we have that suspense showing up, which shows us the loading animation. Even though we preloaded the videos, it still takes some time to update the textures. I know it's not pretty, and the only way I was able to go around it is when I used images. So if you want to just display an image of what that feature does, we would be able to completely eliminate the loading. But since we're using the images, the loading has to be there, but it's only for this first scroll. If you continue scrolling up and down, it'll be gone. And now, alongside just displaying the text, such as generate your images, we can also add some additional information. So besides just saying feature text, let's edit this JSX a bit more by rendering an image with a source of feature.icon and an alt tag of feature.highlight. Below the image, we can render a p tag that'll start with a span element with a class name of text-white, and it'll render the feature.highlight. And finally, below the span, we'll render the feature.text. So now we have this nice looking text that has the image, so we can very easily at a glance see what that feature is all about. And if you bring this to a tablet view, you'll notice that everything still looks great, the laptop is big, and you can still see the features. Sometimes it goes over them, which also I believe adds that special touch to this 3D element. And that means that the feature section is done. So let's go ahead and commit it by running git add git commit -m implement features section, and then git push. Just 2 more sections to go, and the next one on our list is the highlights section. So let's implement that one next. Let's implement this next section, which seems just like a vertical list of cards on mobile, but if you expand it a bit, you'll quickly see that it turns into a bento box layout. Yep, right here on desktop, there's never been a better time to upgrade. So let's go ahead and implement it. Right here under highlights, I'll turn this into a section with an ID equal to highlights. Then within it, I'll render an h2. And now we want to copy the text over from a finished website. There's never been a better time to upgrade. Feel free to copy it or just type it yourself. And then below that, we'll have an h3 that says, here's what you get with the new MacBook Pro. So now if you head back over to your current application, and if you scroll down, you can see this title. Below that, we want to display these 4 different cards. So let's create a new div with a class name equal to masonry. This layout is also called a masonry layout. If you Google it, you'll see something that looks like this. You could also consider it a Pinterest layout. because I believe they were the first ones to popularize it. So within this layout, you can create another div with a class name equal to left column. And then within the left column, you can create another div that'll have an image of source/laptop.png with an alt tag of laptop. And below it, you can have a p tag that'll say fly through demanding tasks up to 9.8 times faster. And now on the current website, you cannot see it yet. That's because this left column has an opacity of 0 applied to it at the start. If we remove it, you'll be able to see it here. But we're keeping it 0 at the start so that we can then animate it in later on. Now, on the left side, there's this a stunning liquid HDR display as well. So let's display it by duplicating this div just below and displaying a sun.png image with an alt tag of sun. And for the p tag, we'll just say something like a stunning with a break tag, liquid HDR with a break tag, and then display. That'll replicate this. Now we can focus on the right side. I'll simply duplicate this left side below and rename it to right column, within which I'll have a class name equal to Apple Gradient. For this one, we really want to make it pop with this border. The image within it will have an AI.png path, and the alt tag will be AI. And it can say something like built for Apple Intelligence within the p tag. We'll add a bit of a break. And then this part right here can be put into a span element. So we apply a gradient to it. And finally, for the last section, we'll have a div within which there's going to be a battery.png image with the alt tag of battery. And it'll say up to 14 hours more battery life or up to 24 hours in total. Specifically, we can put 14 hours more within a span element like this. And then that span will have a class name equal to green gradient. And then we can put a space before it and after it as well to divide it from the other textual elements. And then for this one, we can make it a bit grayish. So up to 24 hours will be within another span element. This one will have a class name of text-dark 100. And we also want to apply a space right before it. Perfect. Now, we cannot see those sections just yet because they're hidden, starting with the opacity of 0. So if you head over to the left and the right column and remove the opacity, you'll of course be able to see those sections. But we want to animate them from not being visible at all to being fully visible. So let's do just that right here above, where first we'll figure out whether we're on the phone or on desktop, because depending on that, we'll have different animations. So is mobile, use media query, you already know the deal, where the query will be a max width of 1024 pixels. And right below it, we'll open up the use GSAP hook, which will run only once at the start, within which we want to use the GSAP library. So you have to import GSAP from GSAP, and then you'll say GSAP.to. We don't have to have from because we already set the opacity to 0. So we're just animating to, specifically targeting the left column and the right column, and we'll apply it based on the scroll trigger. The trigger of the scroll trigger will be the highlights section itself, and we'll start, depending on whether we're on mobile or on desktop, from bottom or from top center. I found those values to work the best when animating this section on desktop and mobile screens. We'll also, outside of the scroll trigger, apply some additional properties, such as Y to 0, opacity to 1, stagger of a 0.5, so we stagger each card by 0.5 seconds, and duration to 1, as well as the ease of power1 dot in out. So now if you reload the page and scroll down, you'll notice that they slowly appear. If you want to prolong the animation, maybe we can make this top. That way it'll start as soon as the top of the component reaches the top of the viewport. So if you scroll fast, you'll be able to see these cards animating. And on mobile, it looks great as well. Before we head over to the last component of this application, yep, we're there already, and that is the footer. Let's not forget to commit the changes right here by running git add dot git commit -m implement highlights section and git push. With that in mind, we can get started with the footer. Our footer will be super simple, as is the footer of all professional websites out there. Sure, you can make the websites pop with 3D models, videos, and make people really want to buy your products. But top navigation and bottom nav is for giving them the links to actually buy it. So every single important link that has to be there, but we didn't include it throughout the landing page itself, well, now we can show it here. So let's replicate this very simple footer on our own. Of course, it looks good on tablet and desktop devices as well. So as CodeRabbit earlier suggested, let's use an HTML5 semantic footer tag, and within it have a div with a class name of info. This is for this line right here and the logo. So I'll immediately create a new p tag and duplicate this piece of text within it. Of course, you can actually turn this into clickable links or anchor tags. And then below it, I'll render an image. This one will be a source of /logo.svg with an alt tag of Apple logo. And then we want to go below the div, create one horizontal rule, which is this line right here. Below it, display another div with a class name of links, and then render a p tag, within which we will display the copyright. And then below that p tag, we'll render a UL, an unordered list, through which we will map over the footer links. And then for each one of these links, we will automatically return an li with a key equal to link.label, or we can just destructure the label and the link from the link itself. So now we just have to say label. Within it, we will also render an anchor tag that'll have an href of link, and it'll display the label for each one of these links. If you've done that, your footer should now look like this. And we can also check it out on desktop. If you hover over those links, they'll appear clickable. For now, they don't really lead anywhere, but rather bring us back to the hero section. So now that we're officially done with all of these sections of our application, just before we commit it and open up a final PR, let's run it through the CodeRabbit CLI one more time and press enter to review all the latest changes. Let's channel the spirit of senior developers. Look at that, not too many issues, just in the performance.jsx file, where we need to improve the accessibility with some meaningful alt text. Yep, performance image 1, 2, 3, and so on, which you can either auto-apply, or let's not be too lazy, let's head over into the performance file and immediately just apply a nice alt tag right here by saying performance image number, and then we can render the actual index of that +1. So it's going to be performance 1, 2, 3, and so on. And we can turn this into a template string. 1 is fixed. And finally, we have to remove the duplicate wrapper element. Oh, is that really the case? It appears it is. Okay, this was actually a super nice catch. Also in performance, on line 7172, we have a duplicate wrapper. We definitely want to remove this one right here. And with that in mind, we have resolved all of those issues, and we are ready to push the changes over to GitHub by running git add dot git commit -m implement footer and git push. That'll allow us to open up a new PR and know for a fact whether we are indeed ready to merge it into the main branch. Before we merge it, CodeRabbit has to take a look and let me know that it's okay with merging all of those changes. So I'll go grab a cup of coffee, see what feedback it comes with, and let's fix it so we can be 100% certain that we're finalizing this app with a clean and error-free codebase. And here we are with a full walkthrough of the added features. I mean, just for a second, imagine that you didn't write this code on your own, but rather that a colleague or another developer in your team wrote the code. Seeing this is super useful because it explains exactly what happened. This PR will add 4 UI sections: performance, features, highlights, and the footer into the app composition. We're implementing the GSAP-driven scroll animations and React 3 Fiber 3D model interactions, including the store-managed video texture and color application to a MacBook model. This is exactly what we've done. And we get an even more detailed diagram. This one explains how the model spins as we scroll the page, and here we can see a bit more about the performance implications. This time, the comments include minor issues, such as adding a key prop to a mapped feature. Oh, look at that, I really did forget to add a key to a mapped element, which can often cause some inconsistencies. So a very simple thing is to just add it right here. Last time I showed you how we can immediately commit this suggestion so that it now includes a key, but as you can see, you'll have to carefully review this before committing, because sometimes, like in this case, it's adding more stuff than it's taking away. It's starting to add an additional div, but it's not removing one at the top. And then it's ending without a div, but here it has a new one. So instead of doing this manually, the other thing that it gives you is the prompt for an AI agent. Nowadays, almost every single IDE has AI features built in. So just copy the prompt, go back within your application. In this case, I'll open up Junie, and I'll simply paste what I copied over from CodeRabbit. And in a second, a key attribute was added to the mapped element without us having to touch a piece of code. Perfect. And besides the nitpicky comments, that's it for this review. So before I merge, let me quickly commit the change by running git add dot git commit -m, add a key when mapping over the elements, and git push. With those changes implemented, we are now ready to merge this PR. And the last thing we have to do is deploy this app to the internet so that everyone can open it up. We can do that right here within the terminal by running npm run build. This will create the optimized production build of the application. Once you have it, head back over to your hostinger's dashboard and open up the dashboard for this specific application. Then open up the file manager, head over into public HTML, delete the default PHP, and instead, you can right-click on the dist folder that was created for you when we ran npm run build, and you can open it up within Finder or File Explorer if you're in Windows. Once you have it, you can head over into it, and then drag and drop all the files to this public HTML. It'll take some time because we have some larger files over there, but as soon as it is done, you can head back over to your dashboard and just click on your domain name. Immediately, your application will open up, but this time not on localhost, but rather on a real online domain name that is HTTPS secured. As you open it up, we first have this MacBook opening up section. Then we have this 3D model that you can move around and change its colors and sizes. Moving down, we have this beautiful full page video section that then transitions over into a mask element showing the M4 chip that is powering the MacBook that you're about to buy. Then we can see what that MacBook is capable of by displaying all of these different apps. And finally, we can see it in a new light by seeing the exact types of apps that it can run, most of them being AI powered. And of course, there's never been a better time to upgrade, which is our last section, and finally the footer. This was such an amazing build, and I'm super happy that you came all the way to the end of this course, because now you've not only built, but also deployed this amazing GSAP and Three.js powered application. If you like this course, head over to jsmastery.com and take a look at the Web Animations full course, where you'll learn how to come up with animations on your own. We'll start from the beginning by getting started, targeting the elements and understanding properties, all the way to different easings, which shows you how the animation actually plays out in real time using animated graphics. And you can see that on the elements moving around. Not only that, at the end, you will build and deploy a GTA 6 animated website with all the sections that the real website has. And finally, we'll dive into the emotional design case studies, where you can see how Apple, Duolingo, Stripe, Revolut, and other huge companies are using animations to their advantage. Once again, congrats on coming to the end of this course, and I'll see you on the inside. Have you ever looked at a sleek 3D portfolio and thought, I wish mine could look that good? Well, today is your lucky day. Hi there, and welcome to a course in which you'll build a portfolio that could easily get featured on awards, combining stunning 3D animations with a user-friendly layout that'll have recruiters and clients saying, Whoa, this guy really knows his stuff. With a minimal yet effective navigation bar, a stunning hero section with a 3D room model, particles, animated text, and a clear call to action, and stylish cards showcasing your experience, projects, and clients. After that, you'll display your project in a clean bento grid layout featuring your best project. Then there's a unique and animated timeline that visually showcases your career journey. Sleek cards to highlight the technologies you've mastered with interactive 3D icons. A testimonial grid with this cool hover effect. And finally, a functional contact section featuring a form and a computer desk 3D model like you're waiting for an email. And finishing it off with a simple footer at the end. By the end of this course, you'll have a portfolio that not only looks amazing, but loads smoothly, even on mobile, showcasing your skills and experience in a way that's impossible to ignore. And if you're worried this might be too advanced, well, don't worry, because I'll walk you through everything, step by step, from integrating 3D models with Three.js and React 3 Fiber to adding smooth animations with GSAP and building a sleek, modern design with TailwindCSS. So whether you're a beginner looking to level up your portfolio or an experienced developer aiming for the next big opportunity, this video is for you. And alongside this video, I've also put together a handy cheat sheet for Three.js development. You can grab it for free within the video kit in the description below and use it as a quick reference. And if you're looking to deepen your understanding of Three.js and turn it into a career, I recently put together a course focused entirely on vanilla Three.js, from the basics to advanced interactive experiences. You'll get hands-on with live code playgrounds built right into our new platform, allowing you to experience with lighting, animations, and different 3D properties in real time. You'll instantly see the impact of every change, truly learning how Three.js works under the hood. If that sounds helpful, the link is in the description. But with that said, are you ready to build a portfolio that's truly next level? In this course, I won't just show you how to build a portfolio, I'll also teach you how to deploy it to the internet so everyone can see what you've built. Now, a developer portfolio is not like any other project. It is a career asset designed to showcase everything you're capable of, making you an attractive candidate for any job. And that's why I'll teach you how to go a step further. See, hosting your portfolio on a personalized domain makes you more professional, memorable, and improves your credibility and search engine visibility. So, before we dive into coding, let's get that domain name. I highly recommend Hostinger for hosting your modern portfolio. And right now, they're offering a great deal which you don't want to miss. When it comes to hosting this modern portfolio, I personally go for the premium plan. And here's why it's perfect for this and many other projects. You can host 100 websites with the same account. You get a free domain name, which gives you a professional touch. You get a free SSL for HTTPS security, which creates trust with anyone visiting your portfolio. This deal won't last forever, and because I've partnered with Hostinger, you get an even bigger discount. Once you click the link in the description, click Claim Deal, and Add to Cart. Here, we'll have to choose the period of our hosting. With the crazy discount going on right now, I'll definitely choose 48 months to save the most money. And enter your JavaScript Mastery coupon code, which will give you an even bigger discount on your hosting package. And once you buy it, we are ready to set everything up and get started with building out our portfolio. Let's start with Hostinger's guided setup. We are building a new website, so you can choose Create, and we're building a completely custom website, so we can choose Skip at the bottom. Next, we need to choose our domain. As you can see, I use Hostinger for my JSMastery.pro platform. So here you can type out your domain name. I would recommend something like your first name and last name.com. Something like johndoe.com. And if you purchase the hosting for more than 1 year, you'll get the domain completely for free. Choose it and click Next. The domain is registering. Now already we are the next step, where you can choose where your audience is located at, and you can see there's a lot of options. Click Next, and the setup will initialize. While that is happening, just another quick note, and that is that the full code base of the video you're about to build is live on GitHub. So you can check it out right here. And if you don't mind, give it a star. With that in mind, we are redirected to the dashboard of our hosting project. So finally, let's code it out and we'll deploy it at the end of the course. To get started developing our amazing 3D portfolio, we'll start by spinning up our Vite and React project. At this point, I think Vite is the preferred way to start React applications. So just head over to vite.dev, click Get Started, scroll down a bit, and you'll be able to see a command that we have to run. So let me show you how to do that right within your code editor. Or maybe you're using an IDE, like I am. Throughout this course, I'll be using WebStorm, a super powerful IDE that is, as of recently, completely free for non-commercial use, which means that you can just download it and start using all of its amazing features. You can totally proceed with this course with any other code editor, but later on, once you see something cool happening right here inside of my IDE, and it's not happening for you, well, that's most likely WebStorm. So let's open up our integrated terminal and run npm create vite add latest, and then the name of your project. If you're not currently within any kind of a folder, you might want to type 3D portfolio right here. But as I'm currently within a 3D portfolio folder, I'll just say / to create the project in the current repository. And I'll press enter. It'll ask me a couple of questions, such as do I want to install the create vite installer, to which I'll say, why, sure, go ahead. And then it's going to ask me a couple of questions. The current directory is not empty. Well, in this case, I'll say remove existing files and continue. You can choose your package name. I'll just say 3D portfolio. And then you'll need to choose a framework or a flavor of your application. You can totally proceed with any option from the list, but throughout this course, I'll go with React. And I'll go for the JavaScript variant. But of course, if you want to do it in TypeScript, you're totally free to do so. That's it. Simply run npm install to install all the necessary dependencies to run our React application. And once that is done, run npm run dev to spin up the project on localhost 5173. And then just click on it to open it up within your browser. You should be able to see something that looks like this. But now let's clean up our file and folder structure a bit so everything makes a bit more sense for the build of our 3D portfolio. I'll start by diving into the source folder, removing all the assets we have right now, removing the app CSS, as well as app.jsx. We'll create all of these on our own. And you'll want to clean up your index.css as we'll update it later on. Now, to actually show something on the screen, we have to create a new app.jsx, and within it, run rafce to quickly create a new functional component. That'll look something like this. If rafce didn't work for you, that might mean that you don't have the necessary extension or a plugin installed. So go to your editor's settings, either plugins or extensions, and search for React snippets. In this case, I'm using modern React snippets, but any should do the trick. Once you do that, we can remove this import as it's not necessary, and we can wrap everything within a main tag. Within it, we can render a div, and within this div, we can render an h1 that'll say something like, welcome to my 3D portfolio. Perfect. And if you go back to your application, you should be able to see something that looks like, oh wait, that's too light of a screen. We were looking at a dark screen for such a long time, so sorry for flashing you with this light screen. But it is what it is. We'll switch it over to dark mode very soon. For now, the most important part is that you can actually see this empty canvas, which throughout the period of this course, together will turn into your 3D portfolio. But to do it, we'll need some packages or dependencies that'll help us work with 3D. So open up your terminal one more time and actually open up another one. This one will keep running our application, and the second one we'll use for installing those additional dependencies. So run npm install, and now we can list out all the packages and dependencies we'll be using. Let's start with GSAP. So what is GSAP? Well, if you head over to gsap.com, you'll be able to see that it says animate anything. a widely robust JavaScript animation library built for professionals. It allows you to effortlessly animate anything that JS can touch, delivering silky smooth performance and unmatched support. Okay, I think they're trying to be a bit flashy right here and show you everything that you can do with GSAP right here on this landing page. And I gotta say, it's looking great. There's a showcase of many different projects that people have built over the years. And who knows, maybe your portfolio ends up right here. So let's install it by installing GSAP as well as GSAP/React. Now, after installing our animations library, which we'll use to animate specific parts of our portfolio, you'll also want to install Three.js, a library for creating WebGL-powered 3D scenes inside of your browser. If you are super new to Three.js, I would recommend checking out our free YouTube crash course before proceeding with this course, or even checking out our vanilla Three.js course on JS Mastery Pro. If you check out the terminal, you'll see we dive super deep into everything that Three.js offers, starting from things like cameras and orbiting different models, all the way to transforming and moving your objects, to adding meshes and geometries, managing it all through a graphical user interface, and of course, Lightning and so much more, because we're continuously adding new content to this course. But with that said, let's add 3 as well as at React-3/Fiber. Fiber is a React version of Three.js that simplifies the use of Three.js library within a React ecosystem. And also, on top of that, there is a package called React 3/Drei. It is a helper library that even further simplifies the most common 3D tasks like lighting, loaders, and more. Finally, for some scenes, we'll also need some visual effects like bloom and so on. So I'll say add React-3/post processing. I'll explain how all of that works pretty soon. For now, let's just get them installed by pressing the Enter key. And with that, our first step is done. You have successfully created a React application with an empty page that right now looks something like this. And you have installed all the necessary packages. There aren't many. They're going to help you develop your 3D portfolio. Great work. So what'd you say that we go from something that looks like this to something that looks a bit more like that? Well, to achieve that, we need a way to apply styling to our application. And for styling, we'll use TailwindCSS, which allows you to rapidly build modern websites without ever leaving your HTML. In other words, it's a utility-first CSS framework packed with utility classes for easy but fully customizable styling, something that Material UI, Bootstrap, or other styling component libraries don't do very well, which is customization. Here, you're writing Tailwind, which is technically still just CSS, but in a much faster way. So let's go ahead and set it up. Head over to Docs, Installation using Vite, and just copy this first command right here and paste it into our second terminal, npm install TailwindCSS and add TailwindCSS/Vite. After that, we'll have to go over the second step, which is to configure the Vite plugin by adding TailwindCSS Vite plugin to our Vite configuration. So just copy this entire block of code, navigate over to Vite config. By the way, I just pressed Command P, which allowed me to quickly open up the file explorer and navigate to this file without ever having to search for it right here. So that is Command P. And now you can simply paste what you just copied, where now we're setting the TailwindCSS plugin. And we also need to keep the previous plugin that we had, which was React. That looks something like this. And we have to import this React from @vite.js/plugin-react. Perfect. Now, the third step is to add an import to our CSS file that imports TailwindCSS. So copy this and paste it right at the top of our index.css file. Add import TailwindCSS. And here we can also define the base styles, like the styles for our HTML and body elements. and give it a width of something like 100 VW, which stands for viewport width. We can also give it a background color of black, and we can also give it a color of white. If you save this and go back, you should be able to see something that looks like this. Welcome to my 3D portfolio, now with a dark background and light text. Now, in TailwindCSS v4 and beyond, we now have the native support for @theme directive, which allows you to define some global styles for fonts or colors right within the index CSS without having to have a separate tailwind.config.js file. So here, you can do something like theme -- color -white -50, and you can define a specific value like hash D9ECFF. This is a different variation of the white color. And instead of specifying it every single time, D9ECFF, now you can just say color white 50. But where did this color come from in the first place? Why did I use this specific color? Well, alongside watching this course, I'll also give you access to the entire code base of the course in case you want to just look at the code. But more importantly, I'll give you full and free access to the finalized Figma design. So in case you want to check it out and try to attempt developing it on your own, or you want to change some things up, well, you can do that by checking out the final Figma design. The link to the video kit containing everything you need for this video, such as the source code, the Figma design, and additional assets and snippets, is right below this course. So just click on it, get to the video kit, and then go to the Figma design. From within the design, if you inspect specific elements of text, you'll see different colors, such as this button, for example, that has this silver color, or this one right here. You can see D9ECFF. This is the exact color that I have added to my Tailwind config. So what you can do next is go through the entire Figma design and manually apply all of these colors, such as, for example, -- color -blue -100, which is hash 2D2D38. And then you can also add all of the other colors as well. Alongside the theming functionalities, you can also add the custom utility classes using Tailwind's layer feature. So you can say add layer, utilities, and then you can define, for example, a .flex-center class name. Why flex center? Because so often we need to center something within a div, right? So instead of every time saying flex, center, center, here you can just define that this flex center will apply a property of flex, a justify center, and items-center. So when you want to use it within the code, it is super simple. You just say flex center. And there are many other ways in which we can use this new Tailwind configuration to make our life much easier later on. So just so you don't have to go over to our design and poke every single element 10 times until you get to its color, I'll provide the final index.css file for you right at the bottom of this video kit. So head over there and copy the index.css file. Once you copy it, override everything we wrote here and simply paste it. You'll notice that here we add some additional elements that are going to help us style our application, as well as some basic elements for defining different grids, responsiveness, and utility functions, as well as, most importantly, theming, and we're adding our own font as well from Google Fonts. This doesn't contain any programming logic or Three.js code. Rather, it's just some utility classes that will make the styling of our application easier. Whenever there's something we're using within our code, I'll point your attention to it. For example, take a look at these components. This layer of components is used to define custom styles scoped to real components. This keeps things modular. For example, if you search for something like a Navbar right here, you can see that as soon as we apply class name of Navbar, it's going to apply these classes right here to make it look nice. And you can also immediately style the logo within the nav, or even how list items within it look like. These styles act like reusable building blocks across the app. Think of this as the design system layer, where you store the visual identity of the buttons, layouts, grids, and more. Don't worry, I'm going to explain how it all works very soon. And the only thing you'll need other than the styles are going to be the assets. Yep, these little icons that you can see here, 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 even here. I want to make sure that you have everything you need to continue developing this application without going back and forth with the design. So I've took the time and put all of these icons in a single zipped folder. Head over to the video kit and find it right here. Once you download it, head over to your current application and delete the current public folder. Unzip the folder you just downloaded and drag and drop this new public folder right within your application. This one will contain a lot of images, logos, and textures, as well as different 3D models we'll use throughout our application. With that said, let's test whether our TailwindCSS configuration works. I'll pull my browser to the side so we can see it alongside our IDE, and I'll open up the source app.jsx, and I'll apply a class name of text-3xl. If you do that, and if your text gets larger, or if you maybe apply an underline, that means that Tailwind is properly connected to your application. And with that, we are ready to start working on the hero section. So let's do that next. The portfolio hero section. The first thing that your users see and a major chance to make a first impression. Here, we'll start strong by immediately blending some UI elements, scroll-based interactivity on the Navbar, and a real-time 3D canvas. So let me start by breaking it down into two major parts. First, the JSX structure and the layout, and then, of course, the GSAP animations and interactivity. First things first, we have to organize our projects into sections and components. So let me clean up this app.jsx and organize our project. We can start by creating a components folder right within the source folder. I'll call it components, and I'll also create another, which I'll call sections. Next, head over into sections and create a new file called hero.jsx and run rafce. And then import it within your app.jsx. That'll look something like this. We have our app. We can wrap it just in an empty React fragment for now and render a self-closing hero section just like this, but make sure to import it from sections hero.jsx. If you do that, you should be able to see just the hero right here on the right. But now we can start diving deeper into that hero section by creating our hero section layout. First, we'll start with some semantic HTML by turning this div into a section. We can give this section an ID so we can later on scroll to it of hero and a class name of relative and overflow dash hidden. Inside of it, we can create a div that'll have a class name of absolute, top dash 0, left dash 0, and a z index of 10. What is this for? Well, for a little background element that I want to show near the top left of the screen. So let me render a self-closing image tag with a source of /images /bg.png with an alt tag of background. If you save it, you won't be able to see anything yet, but soon enough, the goal is to show these little dots right here floating on top left of the screen. So right below this div, let's set up our main layout by creating a div with a class name equal to hero-layout. On the left side, we will display our hero content, meaning the text. And on the right side, we'll display the 3D model. So start by creating a semantic header tag with a class name of flex-call, justify-center. On medium devices, w-full, so it takes full screen, w-screen, and on medium devices, padding x of 20 and padding x of 5 usually. This is to make sure that it looks good on mobile devices as well. And now you can start seeing that background appear right here. Within it, we can display a div that'll have a class name equal to flex-call, and a gap of 7. And now we can focus on the main headline. Yep, this is the one that I'm talking about. It'll actually be comprised of 3 different H1 elements. So let's first start by creating a new div for it. It'll have a class name of hero-text. And then here we can create our first H1 of shaping. Below it, we can say into real projects. And below it, we can say that deliver results. But we're shaping what? But what are we shaping? Well, if you take a look at the final application, you'll see that here we'll have animated text that says ideas, code, designs, concepts, and more. So for now, let's just use one of these. For example, designs. And later on, I'll show you how we can make it animated. First, we need to define some kind of an array that we want to loop over. We might as well define it here by saying const words is equal to an array of different objects, and each word has to have a text, for example, ideas, and then we also have to give it an image path because each word will also have a little icon that you can see alongside that word. So let's give it an image path of /images/ideas.svg. And you can do the same thing with the second one, which is going to be concepts. And here you can say concepts.svg. Perfect. So now I'm going to zoom this out so it seems more like a real application. And I want to figure out how we can animate it. Well, first of all, let's map over those words right here. So after the word shaping, instead of designs, I'll open up a new span element. It'll look like this, a span with a class name equal to slide. Within it, another span with a class name equal to wrapper. And within it, we want to map over our words by saying words.map, where we get each individual word. And for each word, we want to automatically return a span. Now, what do I mean when I say automatically return? I mean not open up a curly brace here, rather just open up a parenthesis, because that means an immediate return. This span, since we're mapping over it, has to have a key of something like word.text, because each text is unique, and a class name of flex, items-center, on medium devices a gap of 3, typically a gap of 1, and a padding bottom of 2, just to create some spacing. Finally, within that span, we can render an image for the icon. It'll have a source of word.img path. It'll have an alt tag of word.text, and it'll have a class name of on extra large devices, size of 12, on medium devices, size of 10, and typically a size of 7, so it looks good on all different screen sizes. On medium devices, we can also give it some padding of 2, typically a padding of 1, rounded dash full, so it sits within a circle, with a BG white of 50. So if I save this, you can now see 2 different icons that are animating up and down. And of course, alongside the icon, right below it, I want to display another span element that'll simply render the word.text. So now it says ideas, and it animates over to concepts. But keeping this list of different words right here on top is not that ideal. Because what if we want to have not just 2 different words, but rather 5, 6, or 10? It doesn't make sense to clutter the view of the hero with some data points. And as a matter of fact, if you wanted somebody to very easily be able to update this, it doesn't make sense to keep it here. It's better to extract all static data into a standalone file, typically called constants, which contains nothing more than just some data that we want to use across our application. So let's copy these words, and instead of keeping them here, let's create a new file within the source folder, or rather a new folder called constants, and within constants create a new file called index.js. Within it, paste those words and make sure to export them by saying export const words. And now, when using those words, you can import them over from the constants. Everything still works as it did, but now we have just a single import at the top. And now, if you wanted to provide more words right here, you can do that easily. As a matter of fact, we can add or shape concepts, designs, code, ideas, and I went ahead and duplicated it right here just so we have more things to scroll over in a more dynamic way. And then when it reaches the end, it'll very nicely scroll all the way to the first one. There we go. Super nice, right? So throughout this application, there's going to be more cases where we want to have some static code, like arrays of different data that we want to use. And you can find those at the bottom of the video kit as well. Just copy the constants index.js file and just paste it here. You'll notice that we have different words, but then also you can change your abilities, for example. What are your strengths? And descriptions of those strengths. Which different images do we want to import? Maybe you can also change different navigation links. It is all right here. So now that we have that, I want to take a second to explain how this animation works. See, this span has a class name of slide, and then a span inside of it has a class name of wrapper. These classes are defined within the index.css file. So if you command click them, I think this should lead you directly to where they're mentioned, or you can just find them within the index.css. And here you can see that we're defining the display of the entire block as inline block. We set the direction of column, and then we start a transition. The key part right here is this keyframes word slider, where we're translating the Y position of the different words right here, such as designs, code, and so on, first by a little, then more, and then we finally fully transform it. And then we animate it over a specific number of seconds infinitely. This subtle yet powerful micro interaction brings life to your main headline and immediately communicates what you do, both visually and interactively. And then below this slide with the wrapper, H1, we can also add a p tag that can say something like, "Hi, I'm Adrian, a developer based in Croatia with a passion for code." Of course, you can type something different. Make sure to give this p tag a class name of text-white50, on medium devices text-xl, relative a z of 10, and pointer events none to make it non-clickable. And of course, this was supposed to be outside of the H1, not just the first one, but all of them. So I'll post it right below this div that says hero text. There we go. Much better. Finally, below this, we want to create some kind of a call to action where people can click on a button, and then that button leads us to our work. This button will be reused many times throughout our application, so it makes most sense to create a reusable button component. So back in our application, let's head over into the components folder and create our first component called button.jsx. This button will be used across multiple sections, both in the hero and context section, so let's make it fully reusable and dynamic. I'll run RAFCE to quickly spin up our functional component, and then within it, we can make this button an anchor tag. This anchor tag will have a class name, which will be equal to CTA-wrapper. CTA stands for call to action, which means an action that you want your user to take. Before I continue developing this button, let's actually use it within our hero section. So right below this p tag, I will render our button. Make sure to import it at the top. And then within this anchor tag, I can create a div with a class name equal to CTA group and group. And within it, we can render another div, this time a self-closing one, with a class name of bg-circle. Next, below it, we can render a p tag with a class name of text, and we can simply render something that button should say, like see my work. And there we go. See my work is right here. Below it, let's also render a div with a class name equal to arrow-wrapper, and let's render an image with a source of /images/arrow-down.svg with an alt tag of arrow. We cannot see it yet, and that's because we have to style it a bit better. So from the hero section, let's pass some props that allow us to style it. I'll pass over a class name equal to, on medium devices, W of 80, on medium devices, H of 16, typically W60, and H of 12. And why do we have to provide the class name as a prop and not immediately right here? Well, that's because this button is going to be used in different scenarios, And depending on where it's being used, we want to provide some different class names. We can also give it an ID of a button, and we can provide a text, such as see my work, because in the contact section, it's going to say something else. So now we can head over into that button and destructure those props that we're passing into it, such as the text, the class name, and the ID. Next, we can make this first class name dynamic. I'll delete it and make it dynamic by opening up a new dynamic block of code and a template string. I'll say if a class name exists, so class name and then question mark, else render an empty string. What does this mean? If a class name exists, render it. If it doesn't, render an empty string, and then always render a CTA wrapper. Finally, here, instead of see my work, we can render the text. And in this case, the class name here should have been CTA button instead of a CTA group, which will activate those classes. If you head over to that, you'll see that it'll apply some padding, both horizontal and vertical. It'll round the corners a bit, apply a dark background. But hey, if it's dark, why is it white right now? Well, that's because we also have a transition. So as you hover over it, you can see that the background turns dark and only the arrow jumps up and down. That happens because of these inner classes such as BG Circle and the arrow wrapper. So with that in mind, our button is fully styled, and later on, once we implement a couple more sections, we'll actually make it scroll to the sections just below. Now we can get back to the hero section and see what we have right now. We have been working on the header component, which is actually just the left part of the hero content section. Or if you're looking at it on a mobile device, that is this top part. But now is the time to fill in this huge gap on the right side. And we can do that by introducing this great 3D room model. So let's do that in the next lesson. To start adding our great 3D model right below or to the right side of the text, we can head back over into the hero section and we'll implement it right here below the header, where it says right side 3D model. I wouldn't even call this a model. It's actually an entire 3D experience. So let's go ahead and create this component. Right within source, components, create a new folder and call it hero models. Within hero models, create a new file and call it hero experience.jsx. Just run RAFCE for now. Later on, we'll implement the entire experience here, but for now, import it right here where it says 3D model by putting it in a figure. Figure is an HTML5 semantic tag that says that something important will be right here, and it is self-contained, meaning it is a single unit that we want to display. Within it, we can render a div that'll have a class name equal to hero-3d-layout. This will give it 70% of the width of the screen on large devices or full width on smaller devices. So if I head back right here and give this a border red of 200 and border -2, you should be able to see that it takes full width of the screen. But if we expand it, it's taking about 70% of the screen right here, which is still a lot to show this model. So right within it, let's render this self-closing hero experience. This component is absolutely positioned, so you can see it jumps a bit over here. But as we implement it, it's gonna jump right below. So let's head over into it. And here we have to render our GLB model. So what is a GLB model? Well, a GLB is a file format that allows us to render 3D scenes and models. You can find many of these models on websites like Sketchfab. Some of these are free and some of them are paid, and you can easily download them and put them right within your application. But let's take it slow. First things first, I want to set up a canvas because in Three.js, everything begins with a canvas. So instead of a div, let me render a canvas, which I have to import from React 3 Fiber, and we have to have a camera within that canvas. So I'll say camera is equal to, and then we can set the position of the camera to an array of something like 0 on the x-axis, 0 on the y-axis, and about 15 on the z-axis, which is pulled back a bit, allowing us to frame the model nicely. We can also give it something known as an FOV, or field of view, of 45. allowing us to once again nicely frame it within our camera. And of course, we cannot yet see anything if we don't have a light. So let me add an ambient light, which is a self-closing component with an intensity of something like 0.2. And we can also add a color to this light, such as hash 1A1 A40. If you save this, you won't be able to see anything just yet. Why? Well, because there's nothing to see. There's just light. So to see something within the canvas, you need to add a 3D object, such as a mesh with a geometry and the material. Well, here's an example of adding a simple box. You can create a new mesh, and then within it, you can render a box geometry with args, an array of 1, 1, 1, which is how wide and how big it is. And then you can also give this mesh some kind of material, such as mesh standard material, and make it a color of something like blue. If you do this and save, you still won't be able to see it, and that's because we have to properly light our subject. Ambient light in this case is not enough, so let me add a directional light with a position of something like 5, 5, 5, and an intensity of 1. If you do that, you should be able to see a blue, or let's make it teal, box. Pretty cool, right? But right now, it's just a 2D box. So how can we actually move it around to see it in all of its 3 dimensions? Well, we can add something known as orbit controls, allowing us to move around this 3D model. I'll add it right here above the mesh by calling it orbit controls, coming from React 3 Drei. It is a self-closing component, and if you just call it like this, you'll already be able to move this box in all different dimensions, and you can even zoom it in, as you can see. Currently, only some sides are lit up, while the others are not. You can play with the intensity of the light to see how that changes the model. And of course, this is something we dive much deeper into within our vanilla Three.js course, so I just had to show this to you. We go super deep into different types of lights that there are. And then, check this out, you can see exactly what each Three.js property is doing right here within the lesson. I mean, just how cool is that? You can play with the intensity of different point lights, change the positions of the lights, and even change the rotations. We have a second point light. You can see how it gets reflected on different elements. Pretty cool stuff, right? And right now we are dealing with a directional light. We dive a bit deeper into the power property, and check this out. At the end, you can also practice your knowledge using a quiz. Pretty cool, right? And if something's not clear, you can ask questions right here within the comment system, and I'll reply very soon. But with that said, let's actually make something out of this cube. Or rather, should I say, we need to import our real 3D model here. But before, let's first play a bit with the orbit controls. I will set the enable pan to be set to false, which is going to prevent panning the scene. So you can only zoom in and zoom out, as well as move around. Also, I want to enable the zoom only if we're on desktop devices. But if we're on tablet, then I want to disable it because it's going to prevent the users to be able to scroll throughout the website. So I'll create a dummy variable called isTablet, and I'll make it equal to false for now. So here we can say if not isTablet, then enable zoom, else disable it. Of course, very soon we'll have to make this work for real. But for now, we're good. After that, we can define the max distance that we can zoom out. I'll set it to 20, as well as min distance. And I'll set that to about 5. We can also set the min polar angle to math.pi over 5 and a max polar angle to math.pi over 2. This allows us to control where in the screen we can move. For example, we can move up to this point up. We cannot have a full view down and a full view up in the room. We can only look at it from this angle. And that's exactly what these polar angles are doing. While we're here, let's also implement this isTablet functionality for real. And for that, we'll use a library called React Responsive. So I'll simply run npm I react-responsive to install it. And this will allow us to ensure that on larger devices, users can rotate and zoom, while mobile and tablet users will get a bit of a simpler experience. Using this library is super simple. You just have to say isTablet is equal to useMediaQuery, and then you pass a query you want to validate for, such as max width of 768 pixels, like this. And then for the other one, we can maybe define isMobile. IsMobile will be max width about, I think 768, and actually tablet is 124, like this. So now we have this real isTablet variable. But now is the time that instead of this fake cube, which you can see now we cannot zoom on mobile devices, which allows us to then move up and down normally as we would on any other website. But if I zoom in on desktop, that still works. So now the main goal is that instead of this cube, we actually render this full 3D model. While I was creating the design for this amazing 3D portfolio, I was thinking for a long time, which model should we use? I went through many different iterations, but ultimately ended up on this one. It is a developer-like room. It has a lamp, a PC, a robot vacuum, a chair, and 2 screens. Pretty nice. It's also not super realistic. It has a nice artistic look, a bit of gloom from these monitors shining away, and it just feels like a developer's room, right? Which you want to put on your portfolio. But of course, you're completely free to search any 3D model you want. Sketchfab is one of the better websites. So, for example, you can search for a laptop or a MacBook model. There we go. And there are many cool ones that you can use and display in the hero of your application. But as I said, I really like this one, and I think you will too. So let me show you what the process is of using some of these models in your apps. You could totally go ahead and download it right here. After you log in, it'll just give you a GLB file, and then you would be able to import it within your application. But here's the thing. Some of these models are super large. For example, the GLB file is 1 megabyte large. And even though that is not so big, it has 33,000 triangles, which makes it take some time to load. And that is without the lights that we need to display on it. So what I did is I didn't want to use this model directly. Rather, I asked my friend that knows a bit of Blender for 3D modeling to clean up unnecessary meshes, hidden geometries, and parts that we just didn't need on the screen. This allowed us to reduce the number of triangles while still preserving the original detail, and they also grouped some parts together so it's easier for us to name them and manage them within the code. And she's actually teaching me those Blender optimization techniques so I can cover them within the Elite Three.js course, which will release soon on the platform. But for now, just so you don't have to go through that process yourself, I decided to give you already optimized models right here within the public folder. So remember putting this here before? If you go into models, you'll see an optimized room.glb. This is the model you want to use. Now, to be able to use any kind of a GLB model, you need to first convert it to JSX by using the GLTF JSX package. It is a very simple package that turns GLTF files into JSX components. It is super simple to use. Let me show you. I'll open up my terminal and actually open up a new one. Within this one, I will cd into /public/models. So now I'm in the same folder where we have all of these models we'll end up using. The only thing you have to do is run npx gltf jsx optimized-room.glb and press enter. It's asking you whether you want to install that package, so say yes or just Y, and this will create a clean optimized room.jsx file for you containing the scene hierarchy that we can directly import and render within our React 3 Fiber project. Here it is, optimized room.jsx. So simply move this file over to source, components, hero models, and put it here, right next to the hero experience. Then head over into the optimized room and rename the file to something like room. You can also change it right here at the top, export function room. And this was auto-generated by gltf to JSX. Pretty cool, right? So what is this? Well, this is a JSX representation of this 3D model. It has different meshes and geometries that we can use, and all of that together will form that room. Just make sure to point it to the right file. Currently, it's pointing to optimized room GLB, but you'll have to point it to /models/optimized room GLB, and you'll have to prepend that word models right here as well, because if you check out our file and folder structure, you'll see it's within public, models, and then optimized room. Great. Now let's import this model into our hero experience. I'll head over to that component, and instead of just rendering a mesh, a box geometry, we can render this room. So I'll render a self-closing room component coming from components room. And if I save it, check this out. Even on mobile, you cannot really zoom in and out, and right now it's not positioned in the best way possible, but you already get the idea for what this is. In my case, it is a heavily lit room, like there is a sun shining right here from the middle of the room. The more directional light intensity you add, the brighter it'll be and the less you'll see the colors. But if you reduce it, for example, already it'll start looking so much better. Now, what do you say that we more properly position this model on our screen? So instead of just rendering the room itself, I'll render it inside of a group, which then allows us to adjust different things, such as the scale of the room. So I can say that if we are on mobile devices, then the scale will be 0.7 times the original size, else it'll be the full size. So now the model will be a bit easier to handle on mobile devices. We can also change the position, where we can make it 0 on the x-axis, minus 3.5 on y-axis, and 0 on the z-axis to move it down a bit. There we go. This makes more sense. And we can also change the rotation a tiny bit by making it equal to 0 minus math.pi over 4, and then 0 on the z-axis. This will rotate it slightly. So once you first open it up, it should look something like this, nicely positioned within your mobile screen. Currently, our lights are totally off, but don't worry, we're gonna fix it soon. Before that, check it out on desktop. Looking great? Well, soon enough, it'll look great. Lights truly do make a big difference when working with 3D models. So let there be light. Instead of simply adding lights one by one like this, we can actually create a new component within the hero models, and I'll call it hero lights.jsx. Run rafce, and then simply add the lights right within this empty React fragment. For now, I will simply use the same two lights that we had here. So if I copy them and remove them from here, save. Oh, just the screens will light. This is pretty cool because they emitted their own light. But I'll put those right here, ambient and directional. And now I will import the hero lights right above this group. And you can see we have light again. So now we can head into the hero lights and start implementing all the different lights that we want to have in our application. You might think that there are not many lights right here, but the more you think about it, the more lights you'll see. I'll increase the width of my browser a bit so we can see it a bit better. Let's start by removing those two lights and add a spotlight, just like this. Make sure to spell the L in spotlight uppercase. And let's give it a position. This one will be the front right spotlight, which is going to mimic a strong key light, like the desk lamp that we have right here. So I'll position it on 2, 5, 6. And you might want to play with this a bit just to make sure to get it right. And let's, of course, give it some kind of intensity. I'll make it very strong, like 100. And now we can see that it's coming from the top right. But if you play with these values a bit, like 2, 2, 2, you'll see how strong it is right now. Or we can make it come from the center of the screen, 0, 0, 0. You can't see anything then. But then if you change it to 1, 1, 1, you can see how well it is lighting everything. As you move the numbers a bit, like 135 or maybe 145, or maybe you make it this 2, you can see how this light behaves. For now, I'll set it to 2, 5, 6. There we go. This is already looking so much better. We can also angle the spotlight a bit to maybe something like 0.15. And check this out. Get what I was saying? We are really talking about a desk lamp light right here. Yep, you can go to that level of detail where only a small part of the model is visible. There's also this interesting property called penumbra, which basically means the softness around the edges of that light. And you can change the color of the light to something like white. There we go. Now let's add an overhead lamp. I'll copy this initial light, change the position to 4, 5, 4, change the angle to 0.3, the intensity to about 40, we don't need it to be that strong, penumbra to about 0.5, and we can give it a bit of a cool blue tone. Let's say that we have some colored LEDs, something like 4CC0F0, and now we're lighting this larger part of the screen as well. Let's add another one. And I mean, you can play with this as much as you'd like. We could have been totally happy with what I had initially with just one directional light, but I want to really create the mood, if you know what I mean. Next one, we'll have -3, 5, and 5. There we go. So now you can notice how these lights start overlapping. With an angle of 0.4, we can give it a super soft edge of just 1, intensity to about 60, and a color of like 9D4 EDD, which is going to give it a bit of a different tone. And now I want to add another type of light. This one will be defined as primitive because within primitive, you can provide any kind of an object here, which will be a new 3.rect area light. So this is a special type of light that provides a soft and moody fill light. You can also provide it a color like A259FF. I found that one to work pretty well. Oh, and here I forgot to pass a hash, so the color wasn't actually getting applied. So if I comment out this primitive light, just so you can see what was happening, this is looking so much more interesting than before, right? So now we have this super white light. We have this bluish spotlight right here. And then we also have this purplish spotlight at the right side. And now we're adding this additional rect area light. To be able to use it, you have to first import at the top. So I'll say import asterisk as 3 from 3. And this allows you to use different elements from the library. Of course, this lights up everything a bit too much, but you get what I'm going for, right? We can change its position to about 0, 1, 0, and we need to change this intensity to 15. And the rotation is the most important part. We want to angle it down toward the scene. So I'll change the rotation to minus math.pi over 4, math.pi over 4, and then 0 for the z-axis. It's also important what else you pass into this rect area light. See, the second property it takes in is the intensity, and then the width and the height. So alongside the color, I'm going to provide 8 as the intensity to this rect area light, 3 as the width, and 2 as the height. So that's going to angle it a bit more toward the room. Finally, I want to add a point light, which is going to be very subtle and scattered for color balance. So I'll simply give it a position of 0, 1, 0. So it's going to be on the center side, but a bit lower, with an intensity of 10 and a color of hash 720-9B7. I found that color to work very well. And I'll add another point light right below it by duplicating this one. This one will come from behind or off to the right. So that's going to be 1, 2, and -2 with an intensity of 10 and a deep blue color like 0D00A4. So now the lighting in this room looks pretty crazy, doesn't it? I think one thing we can do to tone it down a bit is properly position this rectangular light by changing the position to come from the front right side. So on x-axis, 1, a bit from the top, so y-axis 3, and then 4 from the z-axis. You can see this now fills the room a bit nicer. And maybe the most important thing that I missed is the softness around the edges of the light. Even though I thought I applied it, you can see that these lights seem to be fighting with each other, one overlapping with the other. And while it's pretty cool to see that you can test color theory by applying different colored lights over the same surface area, we don't want it in our application. So when I said penumbra here, I was actually missing an M. So if you add it here, you'll notice how this light will get much softer and it won't compete with the rest of the lights. Same thing for all the other 2 spotlights. Yeah, I think the glow of the lamp shows it the best because it has such a high intensity. Check this out. If I change the value of that property to nothing, so it doesn't exist, it'll have a very sharp light. But if I change the value, it'll soften it and more and more and more until it becomes barely noticeable, but it is still there. In this case, lamps really do emit some light, so I want to leave it right here. Pretty cool stuff, right? But now everything still seems a bit too purplish or bluish, doesn't it? It doesn't seem like your real room. It doesn't have that same artistic style that the original model had. So let's go outside of the lights for a bit, and let's go back to the room model to see whether we can fix some of these meshes, materials, and geometries. I want to replace some of these default materials with the ones we're going to custom define that better react to light. That way, we'll have more control. For example, a Fong material, that's F-O-N-G, is great for soft shading with subtle highlights, whereas the standard material is great for realistic lighting and reflections. So depending on what we want to achieve, we can apply a different material to different meshes. The way it works is like this. You can first import something known as use texture by saying const matcap texture is equal to use texture coming from React 3 Drei. And here you can define where that texture is coming from. In this case, we can go to /images /textures /math1.png. And if you try to take a look at this math1 image, you should be able to find it under images, textures, math1, and it should look something like this. We'll use it for some meshes right here, and you'll soon see how that'll look like. So just to show you a simple example, I'll say const curtain material and make it equal to a new 3.mesh Fong material. And to it, you can pass a color of hash D90429 as an example. And don't forget to import everything as 3 from 3 to be able to use these materials. Now we can put that curtain material to use. For example, in this first mesh geometry where it says materials blend 1, you can use the curtain material and see what difference does it make. Currently, we haven't applied it properly, which is actually good because you can see how this mesh looks like without any material. Super plain, right? But as soon as I properly fix this color right here by removing this space, you can see that we have a completely different story. We get a much more vibrant color that reacts to light a bit differently. So this right here is the material that we had before, blend 1. Okay, pretty cool, but a bit plain. And then this is our new curtain material, which is nothing special. It is just a basic built-in ThreeJS mesh Fong material with a bright, vibrant color. And I know this might seem like a lot because we're diving into adding so many different sorts of lights to make this room super unique because, let's be honest, light is what allows you to see the room in the first place. So we tackled spotlights, primitives with the rect area lights, point lights, and more. And now we're even changing the original materials of some meshes right here. The one that's going to make the biggest difference for sure has to be this texture that we're importing from a PNG. Yep, you can import a texture from a PNG image. Let me show you how. I'll say const body material and make it equal to a new 3.mesh fong material, to which I will pass a map. So instead of a color, you can pass a map, and I'll pass it as the matte cap texture that I defined above from image. And now we can apply this body material right here to this second mesh. Instead of materials blend, I'll apply a body material and see if you can notice the difference. It's the walls. See how the walls react differently to lights depending on which materials we give it? This is cool, sure, but this definitely makes it look a bit different, if that's what you're going for. Now, just so you don't have to go ahead and update every single material with its own color, it is like being a bit of an artist, right? Changing the colors. I'll provide you with the final room.jsx file right within the video kit. So head over here at the bottom of the file and copy it, room.jsx. If you paste it, you'll notice that we're leaving some materials as blend, some like the table we're changing, and then some more like the radiator, pillow material, maybe even something like the chair or the computer. That's what we need to change. So if I save this now and reload, we get something that looks a bit more like this. It's much closer to the final effect that we were going for. I just felt that this works with the original theme of the portfolio that we're going for. Oh, and notice one cool thing, and that is that these monitors now have this some kind of a glow. And that in the world of Three.js is called a selective bloom. So I can change the intensity of that bloom and you'll notice how much stronger it'll be. It like the light bleeds out. So I found the value of 1.5 to work the best. So it seems like they're shining too bright to be able to see what's on them. Now, if you reload the page on your desktop device, you'll see the full 3D experience. We have what appears to be a super moody room where a lot of vibe coding happens. But once again, I invite you to play with the lights a bit. Every change that you make makes a big difference to the final model. And in the final app, I even added some particles, but to be honest, I think that's a bit too much because snow or particles don't really fall within a room, right? But if you do want to add them, I'll leave it right at the bottom of the video kit. The only thing you have to do is create a new component within the hero models, call it particles.jsx, paste that code right here, and then get back over to your hero experience. And then right below the lights, you can render the particles and pass the count of how many particles you'd like. I'll set it to about 100 and see the magic happen. If you want to really freeze your computer, set it to 1,000 and see what happens. There we go. That's a sky full of stars if I've ever seen one. Pretty cool, right? Again, either don't include it at all, as it might be a bit of an overkill, or leave it to about 100 max. So with that in mind, great job on completing the hero section. It has been the toughest part of this portfolio, trust me on that, but at least you learn a lot about lights. Now, there's one more thing regarding this hero that you might have not noticed we're missing right now, as opposed to how it is in the final application. It is the loading animation of this text. Even though this part is always animating, once we reload, we also want to animate each one of these lines line by line to look something like this. Check this out. The first one will drop from the top first, then the second, and then the third. Check this out. As I reload the page, they all drop one by one, from the bottom to the top. So let me show you how to implement that animation. This time we won't be using Three.js, rather we'll be using GSAP. So head over into your hero component and let's import. Use GSAP coming from GSAP React, as well as import GSAP, which is the general library, from GSAP. just like this. Then inside of the component, we can call the use GSAP hook to animate this h1 tags. We can do it by saying use GSAP. To it, you have to pass a callback function that we want to activate. And there you can use the GSAP library to say go from and then go to. And to this, you can pass two different objects to define what's happening with these elements. First, you have to target which elements you want to animate. In this case, I'll animate the hero text class name, so make sure to start with a dot. And specifically, I want to animate all h1 elements within the hero text class name. Then we're going to provide a from position, so I want to animate it from these properties to the following properties. Let's say that I want the elements to start from a bit of a higher position on the y-axis. For example, y is 50 and opacity of 0. So we can bring them to life later on from 0 opacity to the full opacity. Then we want to animate them to y0. So we want to bring them down. We want to change the opacity to 1. We want to stagger each one of these h1 elements by 0.2 seconds. So we get first 1, 2, 3. And I want to set the duration of the animation to 1 second and the easing to power 2 dot in out. This is just how this specific animation will play out. So now if I save this and if I increase the duration to something like 5 seconds so you can see it better and reload, you should be able to see how all of these three are coming one after another. To make the effect even more pronounced, I can change the stagger to about 1.5 seconds. Reload and check this out. First, we have the first one, then we have the second one, and then we have the third one. Of course, you never want to keep your users waiting, so what you can do is bring the stagger to 0.2 and the duration to 1 second. That'll end up with a nice animation that looks like this. Of course, the text is even larger on full screen, so the animation looks even better there. Looking good, right? GSAP is not that hard. So let me explain what happens here. The Y position moves each headline from 50 to 0 to give it some movement, and then the opacity from 0 to 1 fades the element in. And then a stagger gives us that cascading animation. Pretty cool, right? Now, another thing that we need to do with our hero section is to make this button scroll a bit down. We cannot see the scroll just yet because we haven't implemented any additional sections, but once we do implement it, we want it to scroll very smoothly to a very precise position. This is what we want to achieve. I click it, and we go right here to the top of these statistics, and then we can see the portfolio. So to implement that, head over into the hero section, and then from the hero, head over to the button that we created that is right here within the header. There we go. Now to this button, we have the anchor tag, which is the main clickable element. So let's give it an onClick function where we can access the click event. Within here, the first thing we want to do is prevent the default behavior of the browser, and that is to reload the screen once we click on an element. Then we want to get access to a target that we want to scroll to. And you can use the document.getElementById, and whatever ID you define, we can scroll to it. In this case, I'll call it counter, because right here, within these elements, we want to count up some of these statistics. So I'll call it counter. Then we only want to scroll if we found that element and if we have an ID. In this case, we're only passing the ID from the hero section, and we won't pass it later on once we use it in the contact section. So the contact should send the email and not scroll up. Only this one should scroll up. Next, we have to give it a bit of an offset, which means kind of figure out to leave some space at the top. So I'll say const offset is equal to window.innerHeight, and I found the number 0.15 to work pretty cool. I'll show you later on how it works with and without this. Finally, we want to calculate how far down we need to scroll. So I'll say top is equal to target.getBoundingClientRect.top plus the window.scroll y minus the offset, because we want to leave some space on top of these elements to make them appear nicely on the screen. And finally, you can say window.scroll to define the top that you want to scroll to, and set the scroll behavior to smooth. So very soon as we implement those counters right here below, we'll be able to click and scroll down. So let's implement it. I'll head back over to my hero section, and below this figure and below the div that's wrapping it, still within the section, I'll render an animated counter. But let's first create that component within the components folder and call it animated counter.jsx, run RAFCE right within it, and then import it right here where we were. Animated counter, a self-closing component. And if you do that, you should be able to see it right here at the bottom. I'll collapse my browser, head into the animated counter, and we can implement it. We can start with the JSX. I'll first wrap everything in a div that has an ID of counter, because we're going to use this element to scroll to later on. Next, I want to give it a class name equal to padding-x-lg to give them some space on left and right. I also want to give it on extra large devices a margin top of 0, but typically a margin top of 32. Within this div, we can have yet another div that'll have a class name equal to margin x of auto, grid of 4 columns. So we're going to show 4 different cards. Within it, we can map over our counter items. So just start typing counter items and press enter. It will automatically import them from your constants. Here, I put different values. For example, years of experience, satisfied clients, completed projects, and client retention rate. You can, of course, change this. If you maybe have 10 years of experience or less, you most likely have much less, but that's totally okay. Satisfied clients, you can change all of these numbers or values, as well as the labels that you want to display right here. It's all dynamic. So let's map over those counter items by saying .map, where you get each item. And for each item, you want to automatically return a div that'll look a bit like this. It'll have a key equal to counter items dot label, and you want to give it a class name equal to counter dash number, text dash white, text dash 5XL, font dash bold, and margin bottom of 2. Next, you can give it a 0 number. So we're going to start all of them with a 0. And then you can render the item dot suffix. What is this suffix? Well, it is either a plus for a number or a percentage for the retention rate. And then if you save this, you should already be able to see 4 different numbers right here. But let's actually wrap this in another div. So I'll make it a div like this, and I'll put it right within it. We want to wrap it in a card first. So this outer div will have a class name of bg-zinc of 900, rounded-lg, padding of 10, flex, flex-col, and a justify center. So now we can see 4 of these different cards just showcasing empty values. But before the value, we can actually render another div that'll render the item.label. So we have 0 years of experience, 0 satisfied clients, and 0 completed projects. Not so good. Let's give this div a class name of text-white50 and text-lg. Okay, that's a bit better. But still, why are we saying 0 right here? Well, that's because we always want to start with a 0, but then we want to count the elements up to the value that we have chosen. Either 10, 100, or more. Sure, what you could do is immediately display it right here. So that's going to be just item.value. And that's pretty cool already, right? But I want to show you how you can animate this element to go up in number to reach those specific values. So let's do that next. To implement our counter, we can use a React CountUp npm package. You can simply install it by saying npm install React CountUp. And then we can use it by importing the CountUp right at the top, and then using it like a CountUp component. That'll look something like this. Within this div, we can implement a CountUp and give it a start and an end. If you don't provide a start, it'll start from 0. And then right here as the end, we can implement the item.value. And you can also add a prefix or a suffix to it. So the suffix can be item.suffix. Let's see how that looks like. I'll delete this, save it. And if I go back and reload, you can now see that all of these numbers count up. Even though this is 10 and this is 100, the component automatically takes enough time to load them all the same. Perfect. This is looking amazing. And let's check it out on desktop. Yep, this is looking good. We have our hero section, which takes full height of the screen. Very soon, we can also add a navbar right here. But for now, we have this hero. And then if you click on See My Work, it actually scrolls down to these count up cards. So this is looking great. And on mobile, the reason why we had to put so much work into this See My Work button is because sometimes you cannot scroll on mobile devices, as instead you'll be actually drag and dropping our 3D model. So it was super important for this See My Work to properly scroll down to the count up section. So with that in mind, we have now implemented the hero section with this amazing 3D model and GSAP animations we have added to these H1s, as well as implemented a counter for some of the most important metrics about our years of experience, satisfied clients, projects, and more. In the next lesson, let's focus on developing this showcase section where you can display your highlighted project alongside 2 other projects you've done before. With the hero section done, let's focus on the section below, the showcase section, where we show 3 real-world apps you've built, 1 large featured app on the left, and 2 supporting projects on the right. First things first, we have to create a new section. So within the sections folder, create a new file and call it showcase section.jsx. Run rafce and import it right within the app below the hero. Showcase section right here. If you do that, you'll be able to see a showcase section text right below. So let's get started with the layout. First, I'll wrap everything with a div, and I'll give it an ID equal to work so that we can use the navigation bar links later on to scroll to that section. Then I'll give it a class name of app-showcase, and this will nicely center it on the screen. Right within it, I'll create another div, and this one will have a class name equal to w-full, so it takes the full width of the screen. And then within it, I'll have another div with a class name equal to showcase layout. This one will make it flex row on extra large devices, so we can fit 1 on the left and 2 on the right, and flex col, so all of them show one below another on mobile devices. So now we can split this into 2 sides. We're going to have the left side right here on the top, and then after that, we'll have the right side. So on the left side, let's create a new div. This div will have a class name equal to first project wrapper. And within it, I'll create another div with a class name of image-wrapper. And within it, I'll render a self-closing image with a source of /images/project1.png. And I'll give it an alt tag of ride. Because if you take a look at my images, right here within the public folder, images, and then we have our project 1, you'll see that this is Ride, a React Native Uber-like application, which if you want to learn how to build, well, you can do it for free on YouTube. If you wanted to put the image or the thumbnail of your project, which you most likely want to do, unless you build this one, of course, then you'll have to upload your own image to the images folder and just refer to it right here. And then you'll be able to see it right at the bottom. Within this div containing the image, I'll create another div with a class name equal to text-content. And within it, I'll display an H2 that'll say on demand rides made simple with a powerful user-friendly app called Ride. Of course, you can enter the title of your application right here. Then we can have another description paragraph right below with a class name of text-white-50 and on medium devices text-XL. And here I'll copy what I have in the already deployed website. an app built with React Native, Expo, TailwindCSS for fast, user-friendly experiences. Of course, I invite you to talk a bit more about the technologies you used here or what obstacles you encountered while developing it. And now we can head over below this div for the left side and focus on the right side. There, we can have one div which will wrap those two additional projects with a class name of project list wrapper and overflow dash hidden. Within it, we can have a div for our first project. So let's give it a class name of project. And within it, we can render a div within which we can render that project's image. So let's give it a source of images project2.png with an alt tag of library management platform. If you save it, you'll see one image right here. But we can position it a bit better by styling this div that's wrapping it with a class name of image-wrapper, bg of hash, ffefdb, just like this, so we nicely position it within the screen. Right below this div containing the image, we can also render an h2, where we can simply say library management platform. In this case, we don't need to give it a description because this is a secondary project. So let's go ahead and copy this entire project div. So for me, that's this red one right here. And I'll paste it one more time just below, this time for our second project. So I'll change the background color a bit so they're not the same to FFE7EB. There we go. So just a bit of a different color. Image will point to project 3 and the alt tag will say YC directory. This is yet another of our YouTube projects, YC directory, which is a startup showcase app. Of course, I invite you to put your own projects right here. And now is the time that we add some animations to this screen. It doesn't look that exciting on mobile, but on desktop, we do have a big project on the left and two smaller ones on the right. But if you compare it with the final project, you'll notice that there, they nicely appear one after another. Whereas on our current application, they just show up and that's it. So let's animate them one by one. To do that, you'll want to give each one of these project divs its own reference. So right at the top, let's create a new const section ref is equal to use ref coming from React. And at the start, set it to be equal to null. We need one for this section, and then we need one for each one of the projects. So I'll say const project1 ref is equal to use ref. At the start, set to null again. And then I'll duplicate it 2 more times for the project 2 and project 3. Now we can give a ref to the main section. So I'll actually rename this to an HTML5 semantic section tag with a ref of section ref. And then I'll also give it to each one of these projects. The first one being this first project wrapper. I'll give it a ref equal to project1 ref. And then I'll head over to this second project and I'll give it a ref of project2 ref. And finally, for the third one, I'll give it a ref of project3 ref. So now all of these different divs or projects have different references attached to them. So now we can apply some animations on them. Let me show you how to do that using GSAP. First things first, we will import GSAP within curly braces from GSAP. And one thing that you want to do is say gsap.register plugin, and you'll pass in a scroll trigger, which you'll need to import from GSAP. So say import in curly braces, scroll trigger coming from GSAP scroll trigger. And finally, we'll also need to import the use GSAP hook, which we used before, which is coming from @GSAP React. You need to register this plugin because otherwise GSAP won't know that you want to apply some scroll related features. You already know how to start applying GSAP animations. You do it using the use GSAP hook. So let's say use GSAP right here. And you have to give it a callback function with a dependency array right here at the bottom. It works similarly to React's use effect. This means that everything in this block of code runs only once when the component mounts. So there's one thing that I want to do first, and that is fade in the entire section that shows these different projects. I can do that by using the section ref dot current, and I want to animate it from and to something. So I'll actually have to say GSAP dot from to, and then the first parameter you pass to it is the reference to a div that you want to animate. Then you pass from which animations you want to go. So I want to go from opacity of 0. And then you, for the third parameter, pass where you want to go. You want to go to opacity of 1 throughout the duration of 1.5 seconds. And I'll actually put this into multiple lines so it's easier to see what's happening. So GSAP from to, apply to this div, opacity from 0 to 1 throughout the duration of 1.5 seconds. If you do that and reload, you'll notice that now it fades in pretty nicely. And now we want to animate each project on scroll, one by one. We can do that by gathering them into an array and then loop through each one and create a scroll animation. So right at the top, I'll say const projects and create an array of those projects. Then to it, I want to add a project 1 ref dot current, project 2 ref dot current, and finally project 3 ref dot current. So we have stored all of these references in an array. Then we want to say cards dot for each. So for each card, and take its card index, open up a new function block, and then run the GSAP dot from to function. What do you want to animate? Well, I want to animate a card. Which card? Well, the one that we're going over for that specific round of the for each loop. And what do I want to do to it? I want to start it at Y50 and opacity of 0, which means that it starts as invisible. And then what I want to do to it is I want to change the Y to 0, which means that we're going to move it back to its normal position and make it fully visible by changing the opacity to 1 throughout a duration of 1 second. And I also want to add a delay to stagger when they load. So I'll say 0.3 seconds, and then take the index plus 1. That's because the indices start at 0. So instead of having 0 at the 1, we'll have 1 times 0.3. So the delay for the first one will be 0.3. Then for the next one, it'll increase to 0.6, and then it'll increase one more time to 0.9. And finally, to know when we want to apply this scroll animation, we have to have a scroll trigger. Here, you can say when you reach which portion of the screen, when they want to trigger it, and we can say the trigger is actually the card. So animate when the card enters the viewport. And then you can decide when exactly you want to start it. For example, start when the top of the card is near the bottom of the screen. So about 100 pixels from the bottom. And right here, I should have said projects. So we're mapping over each one of these project cards. Okay, so now if you reload and scroll down, well, you won't be able to see the animation just yet. You'll just be able to see this one where it goes from opacity 0 to opacity 1. So why cannot we see this animation? Is it something with the for each loop? Well, not really. It's just that you have to use GSAP from within the use GSAP hook. So simply select this and bring it down into the use GSAP hook right here. There we go. And you can also bring these projects here. So now we're saying use GSAP, and then we're applying the GSAP animation. So if I now save this, scroll up to the top, reload, and then scroll down, you can now see how each one of these nicely appears as you scroll. And of course, let's not forget that this looks even better on desktop devices. So as you scroll, we get all of them appear nicely one by one. Great. And that brings us to the end of the showcase section. Now we could focus on the next section, but now that we have the hero and one more section, what we can focus on instead is implementing the navigation bar, because now we have two different things that we can scroll from and to. So let's do that next. Let's get started with developing our navbar. It should look something like this on desktop, where if you scroll down, you can always get back to the top of it by clicking your name. And then here, it allows you to smoothly scroll to different parts of your portfolio. And then on top, we have contact, which brings us all the way to the bottom to this great 3D model that we'll implement soon. And then if you check it out on mobile, it'll be very simple. We don't need the viewer to necessarily see every single thing. If they want it, they're going to scroll. But then at the moment where they want to contact you, they can just go here and do that immediately. So let's focus on implementing the navbar. We can start by creating a new component right within source and components, and create it right here by creating a new navbar.jsx file, run rafce, and just import it over in your app.jsx above the hero section. So that'll be the navbar like this. If you do that and go back to your website, you should be able to see it right here on the top, and then we can implement it. Just head over into it, turn it into an HTML5 semantic header tag, and give it a class name equal to navbar, and within it, create a div that'll have a class name of inner, and within it, render an anchor tag that'll have a class name of logo, and an href of hash hero, pointing to your hero section when clicked. And there you can type your name. I'll type Adrian GSM. Of course, you can put your first and last name right there. There we go. Pretty cool, right? Now, right below this anchor tag, we can render nav for the rest of the navigation items. And here, I'll give it a class name of desktop, so we know that whatever is within this nav only appears on desktop. But then after the nav, I'll render another anchor tag that'll have an href pointing to hash contact with a class name of contact-btn and group. And within it, we can render a div with a class name of inner. And within it, we can render a span that'll simply say contact me. There we go. So now we have a contact as well as Adrian GSM right here at the top. Now the question is, what do we show within the nav? Well, for that, we'll have to head over to the desktop version of the application. So I'll expand it a bit. And within it, let's render a UL, an unordered list. Within the unordered list, we want to map over all of our linked items. Sure, you could create an array of objects where you have a title for each one, and then you also have a URL that you want to point to. But it's always better to declare those links in your constants in case they change. You don't have to change them here. So simply say nav links and import it over from constants index.js. If you want to change those links, you can, but these are the sections that our portfolio will have: work, experience, skills, and testimonials. Sections that every single portfolio needs to have. So once you're in there, just map over them, destructure the link and the name that we get from each one of these links, and then for each one, automatically return a list item, an li. And since we're mapping over it, we also have to provide it a key, which can be a name since it's unique, with a class name of group. And within each one, we can render an anchor tag that'll point to the link. So this is a dynamic link property, different for each one of these links. Within it, we can render a span element that'll render a name. And within it, we can also render another self-closing span that will have a class name of underline, allowing us to have that very cool visual effect. So if you save it, you should be able to see work, experience, skills, and testimonials with this cool underline. And if you click on work, since that is the first section we have implemented, you can immediately see it right here alongside its nice animation. Let's try it one more time. I can head up and I can see my work both here, and it nicely animates. Pretty cool, right? Now, check this out. If we scroll down, you'll notice that our navbar will kind of be hidden by some of the other more colorful elements that we have on the screen. That means that we want to actually give it some kind of a background so that it's visible even on top of these elements. For that, we have to keep track of the state of the navbar. If we're here, just leave it like this. It has enough contrast with the background. But as soon as we scroll down, we'll then apply some kind of a background. To do that, we have to figure out when have we scrolled and when have we not. So right here at the top of the navbar, I'll say const, and I'll define a new use state called scrolled and set scrolled. At the start, it'll be equal to the use state. That'll simply say false. And this use state, of course, is coming from React. Then I'll open up a new use effect coming from React that'll happen only at the start or when the component gets mounted. So I need to define the dependency array as an empty array. And within there, we want to figure out how do we handle the scroll. So I'll create a handle scroll function, which will check whether the user has scrolled at least 10 pixels. So say const is scrolled is equal to window.scrollY is greater than 10. If that is the case, I'll set scrolled to true because it means that the user has scrolled. And now I want to add this event listener to the window. It'll be a scroll event listener, and it'll call the handle scroll function. And I also want to unmount it to clean it up. So I'll say return callback function, window.remove event listener, scroll, and handle scroll. So this way we're still keeping all of the optimization in React by removing or cleaning up the event listener when the component is unmounted. So now that we have access to this scroll state, let's put it to use. See this navbar? We want to apply different classes to it depending on whether the user has scrolled or not. So I'll make this class name dynamic and a dynamic template string for that matter. It'll always have the class name of navbar, but if scrolled is true, in that case, I'll also give it a class name of scrolled, else I'll give it a class name of not scrolled. So if you check out both of these, you can see that scrolled simply applies a top 0 and a background black, and then not scrolled applies a background transparent. That's it. That's the only difference. So now if you scroll down right here, you'll notice that now it has a dark background, so it's still fully visible even when appearing over all of these elements. And then if I go up, it simply disappears. Makes sense, right? And with that in mind, your navbar is now fully completed. It scrolls to work and to home, but later on, it'll also scroll to all of these additional sections, which we're just about to implement. So let's start with the next one on the list. And that one is the logo showcase that scrolls through the logos of different companies that you have worked with in the past. So let's do that next. Let's start implementing the logo carousel. This is all about social proof. You want to show off client logos in a smooth, continuous scrolling. This is called a marquee, I think, just like the top tier agency sites do. So let's create a new component just for it. I'll head over into the components folder and create a new file called logo section.jsx. Within it, you know the drill, run rafce and then import it right here, logo section, as a self-closing component right below the showcase section. Once you do that, you should be able to see an empty piece of text. So let's head over into it. And instead of this empty div, create a div that has a class name of on medium devices, margin Y of 20. So that's 20 on top and bottom, but typically margin Y of 10. So only on medium devices do we want to have that larger margin Y. And then also give it a position of relative. Right within it, create two separate self-closing divs, both of which will have a class name equal to gradient edge, and then duplicate it. You'll see very soon what that does, but essentially you can see how these logos disappear on the left, and then they start appearing from the right as it moves. So right below, create a new div that'll have a class name equal to marquee and give it a height of about 52. Then right within it, create another div that'll have a class name of marquee box with a medium devices of gap 12 in between the elements, and typically a gap of 5 should do the trick. This marquee is the visible area that you see on the screen, but the marquee box will actually have twice the width and it'll animate indefinitely to the left. This is how you can apply animations. So let's research them a bit deeper. You can see that this marquee takes 100 dynamic viewport width, and we hide it. Okay, so this is what you can see on the screen. But this marquee box will actually have 200% width and then an overflow hidden. So we're animating it outside of the screen. And we're applying a simple CSS animation of marquee 60 seconds linear infinite. Believe it or not, that's all it takes. You can do a lot of stuff built right into CSS. So the only thing remaining for us to do is to add the logos. We're going to loop through all of the logos twice, so it feels infinite. First, we need to import the list of the logos. So I'll say logo icons list coming from constants. And as you can see, I put about 11 logos right here, but feel free to remove them or feel free to add the logos of the companies that you worked for or that you collaborated with. And if you didn't work with any major companies that have known or good looking logos, well, then you might just skip this section altogether. If you want to, the only thing you have to do is comment it out from here and then move over to the next section. With that said, I will map over it, get an icon for each one, and then simply display a new component for each one of these. A component called logo icon. So let me define it right here, since this is the only place where it'll be used. Logo icon. It is a self-closing component that simply accepts an icon, and it returns a div with a class name of flex-none, flex-center, and a marquee item. And it'll render an image of a source icon.img path, as well as an alt tag of icon.name. So now we can loop over or map over those logo icons like this. We can give it a key equal to icon.name, and then we can pass over the entire icon equal to icon to it. So now if you save this, you'll be able to see the logos, but what we have to do is actually duplicate it one more time. And we're doing this because this trick creates a duplicate stream of logos. So when the first one sets to scroll out, the second one continues seamlessly. Hopefully it makes sense. But yeah, believe it or not, that is it. The magic here lies in this animation CSS property where you apply a specific type of the animation, choose the duration, choose whether it's linear or not, and then make it infinite. And then that'll scroll the images from left to right. Pretty cool, right? Once again, I'm totally aware that you might not have hundreds of companies you worked for in the past. So if that is the case, you can totally just comment this section out and focus on the next one to come. Because the next ones are cards that feature your strengths. To start implementing the featured cards, let's go ahead and create a new section within the sections folder. I'll call it FeatureCards.jsx, run RAFCE, and simply import it within the app. Feature cards. Now that I look at it, the logo section is also technically a section and not a component. So let me move it right here into the sections, but make sure to fix up these imports so that it's coming from sections instead of from components. Great. With that said, move over into the feature cards and let's start implementing them. The goal of these cards is to highlight your top strengths as a developer, things like the quality, communication, and timely delivery of your projects. Each card is a compact summary of one of your core abilities using an icon, a title, and a description. So first, let's create a layout by creating a div that'll have a class name of wfull, padding x of lg, and within it, create another div that'll have a class name of margin x auto, and let's split it into a grid that has 3 columns. Now, you want to map over your abilities coming from constants index.jsx. These are some of the abilities that ChatGPT thinks are important, but I want you to go ahead and change all of this text right here because you are a special individual and you have your own strengths. So change the titles, descriptions, and if needed, image paths as well to showcase what you are capable of. Then we want to map over all of these different strengths. And for each one, we can destructure the image path, the title, and the description. And then we can just map over them and automatically return them. For each one, I'll return a div. And for now, I'll make that div simply render the h3 that'll say title. If you do that and go back to your current application, you'll see quality focus, reliable communication, and on-time delivery. Let's style it a bit different to make it a card. First, I'll give it a key, since this is an element we're mapping over. I'll make it a title, since the title is unique. And I'll give it a class name of card-border. I'll also give it a rounded -XL, which will make the corners rounded, a padding of 8 to give it some space. Also, flex -call, and a gap of 4 in between the elements within the cards. Next, I'll create an inner div right here that'll have a class name equal to size of 14, flex, items-center, justify-center, and rounded-full. This is for the icon we're going to display. So let me render a self-closing image tag with a source of img path and an alt tag of title. If you save this, you should be able to see this icon appear, which already brings so much more life into it. And below it, we have this h3, to which we can give a class name of text-white, text-2XL, font-semi-bold, and margin top of 2. There we go, looking good. And below it, we can render a p tag with a class name of text-white-50 and text-LG, and it can render the description. There we go. This is already looking so much better. One thing that I noticed is that right here, I misspelled padding. So this was supposed to say padding XLG, and that'll provide some padding on left and right. And to give it some more vertical space to breathe, we need to rename this to grid 3 cols, as in columns, plural, because this will apply this grid column layout, which will nicely space them out on all different types of devices. There we go. This is looking better. Looks great on mobile and nicely complements this logo section. And if you check it out on desktop, it looks great too. Perfect. Oh yeah, I don't think I've seen the logo section on desktop. It looks even better because now you should get the idea of why we're using double the icons. So once some scroll to the left side of the screen, new ones appear on the right side. Perfect. This section is done as well. So now we can showcase not only the companies you worked for, but also your top features. But what matters even more than features is your experience. So let's develop one of the most exciting sections of this portfolio next, your work experience timeline. It has a couple of interesting elements, such as this card right here that has this cool hover effect, or this timeline that expands as you scroll down and changes colors depending on the logo of the company that you worked for. Pretty cool stuff, right? So let's do that next. Professional work experience. Or maybe it's not work experience for you, but rather you're showcasing the timeline of how you build different projects. Either way, this section will tell your career journey in a visually structured timeline, blending the clean layout with these animated transitions. On the left side, you'll have testimonial style experience cards. In the middle, we'll have a timeline. And on the right side, you'll have all of your job responsibilities. So let's start with creating this section. I'll head over to the sections folder and create a new experience section.jsx. I'll run rafce and I'll simply import it over below the feature cards. There we go. Makes sense, right? It appears at the bottom. So let me head over into it and turn it into a section. This section will have an ID of experience, so we can nicely scroll to it from the navbar. And it'll also have a class name of wfull, so it takes the full width of the screen, as well as on medium devices, a margin top of 40 to divide it from the top, and typically a margin top of 20. It'll have section padding, so we give it some space to breathe, as well as on extra large devices, padding X will be 0 because we have enough space to show it all around. Within this section, we'll have another div that'll have a class name equal to W-full, H-full on medium devices, padding X of 20, and typically a padding X of 5. Now within it, we want to display our header title. This is the title I'm talking about, My Career Overview, and then Professional Experience. We'll want to turn this into a new custom component as we will reuse it in multiple places later on. So let's do it by creating a new reusable component called title header.jsx, run rafce, and import it over within the experience section, title header, just so we can very easily and immediately see it at the bottom. Then pass over a title equal to professional work experience, and also pass a sub, which is a subtitle that can say something like my career overview. And maybe at the start of that sub, we can also display some kind of an emoji, maybe like a work briefcase or something like that. So now we can head over into that title header and we can accept those props and display them on the screen. So simply destructure the title and the subtitle right at the top and return a div with a class name of flex, flex-call, items-center, and a gap of 5. And within it, render another div with a class name equal to hero-badge, and within it, render a p tag, which will render the subtitle. And therefore, you'll be able to see this My Career Overview. If you open it up within CSS, you'll see that we're applying a black background border, some padding Y on top and bottom, and X for left and right. We are making it rounded, making it fit the screen, making the text a bit small, and making it not wrap so it stays in the single line. And then right below this div, I'll create another div with a class name of font semi-bold. On medium devices, text 5XL, typically text 3XL, as well as text center. And here we can display that big title headline, such as this one, Professional Work Experience. So now that we have the title for our experience section, let's loop over our experience cards. We can do it right here below the title by creating another div with a class name of margin top of 32 to divide it a bit from the top, and a class name of relative. Within it, I want to create a div that will act as a wrapper for our experience cards. So let's also give it a class name of relative, a z index of 50, and on extra large devices, space y of 32, and space y of 10 on all other devices. Within it, we want to map over our exp cards or experience cards coming from constants index.js. You can see here that I created 3 different cards. Each one is an object that has a review, which is just like some kind of a description of what I did for that company, an image path, a logo path, a title, date, and responsibilities. I think this gives you a pretty good idea of how you should fill in this data yourself for your previous positions. Once you do that, you'll need to map over it. So let's say .map, and for each one of these cards, we want to automatically return a div. Since we're mapping over it, this div will have a key equal to card.title, since it's unique, and a class name of exp card wrapper. And within it for now, just display a card.title so we can see something. There we go. I worked as a React Native, full stack, and front-end developer. And now we want to make it look a bit nicer. So let's first focus on this experience card right here that allows you to hover over these elements, and then you get this nice looking border. Now, you can also see that we'll reuse this same card later on in customer feedback highlights or testimonials from specific people. So of course, that tells you that this will be a reusable component. So let's create it. I'll head over to the components folder and create a new card. I'll call it glowcard.jsx because we have the glowing border. I'll run RAFCE, and within the experience section, right here, instead of rendering the title, we can render a div that'll have a class name equal to, on extra large devices, W2/6. So this will give it a specific width on larger devices. And then within it, we want to render a glow card. This will be a component that is not a self-closing component, meaning something goes into it. And what is that? Well, that can be a div with a self-closing image tag that'll have a source equal to card.img path with an alt tag of card.title. And then alongside passing that as the children into the glow card, we can also pass the card as a prop, which will contain all of the other card properties. So let's head over into the card and let's accept all of these properties that we're passing into it. First, we get the card itself, but of course we need to destructure it. And then we get the children, which refers to everything that we passed over as a child of that component. So here we can return a div that'll have a class name equal to card-border, timeline-card, rounded-XL, and a padding of 10. Within it, I'll display a self-closing div with a class name of glow. And now you can slowly start seeing how this card will glow as you hover over it. So let's try to look a bit deeper into how this glow works. Well, first of all, we remove the pointer events so you don't get the cursor pointer, so it doesn't seem the cards are clickable because they are not. We position it absolutely over that element with full width and height in the middle of the screen. And then we're focusing only on changing the border of that card as we move to it. The code for the exact border is right here. And I am applying a bit of a more complex gradient right here. I found this CSS somewhere on the internet. It could have been a really nice code pen, and I saved it somewhere, and then I ended up using it on this project. Whenever you find some nice CSS, always save it. You never know when it's going to come in handy. So now that we have this glow right here, we actually want to display something within this card. First, we want to display the number of stars or the rating that this person has given you. So let's do that within this div, where I will open up a dynamic block of code and say array.from length is 5. And then we want to get access to the index. So we're mapping over these 5 elements. We don't care about the first one. We only care about the index. So you do it like this. And for each one, you want to automatically return an image that'll be equal to a source, images, star.png. It has to have a key of index, and it has to have an alt tag of star, and a class name equal to size of 5. If you do this, you should be able to see 5 stars for each one of these cards. We can also style the div a bit further by giving it a class name of flex, items-center, gap of 1 in between the stars, and a margin bottom of 5. So now we have 5 stars within each one of these cards. We can go below this div that's wrapping those stars and create another div with a class name of margin bottom of 5. And within it, we can render a piece of text that'll render the review of the card. We can give it a class name equal to text-white 50 and text-lg. So we make it a bit larger. And more importantly, right below this div, we can render the children. In this case, the children being the logo that we're passing over right here from the experience section. But now, if you hover over it, just one side or one border actually lights up, and you can see this gradient that is being applied to the top and bottom side of this border. But now, how do we actually make it follow our cursor? Well, for that, we'll have to do some math, or rather we'll have to know about the position of our cursor. So let me show you how to do that. First, I'll create a new reference to an element, and I'll call it card refs and I'll make it equal to useRef. And at the start, it'll be equal to an empty array of references. Then I'll create a function called handle mouse move. It'll be a higher order function, which means that first we want to figure out over which card are we moving over, and then we want to get access to the event of the actual mouse, so that move event. And then once we have that, we can figure out which card we're on. So we'll say const card is equal to card refs dot current and get the index of the current card we're on. And if a card doesn't exist, simply exit out of this function. Now, of course, for this to work, we have to give this div a reference, and this reference will actually take in the element and it'll say card refs dot current index is equal to the element. So depending on which one we're currently on, we will only move for that specific card. And I'll also call the on mouse move, and I'll call the handle mouse move function and pass in the specific index that we are moving over. Make sure that we also have an index here. So we have to pass an index as a prop to this function. So I'll say index. And from the experience section, I'll also pass over the index next to the card. This index you have to get over right here as the second parameter of the map function. Great. So now that we have that, as you scroll down, you'll be able to see that no animation is happening. We're not yet tracking anything. Right now, we just know on which card we're on. So now the magic happens. First, we have to get the mouse position relative to the card. So first, let's get access to the position of the card itself by saying rect is equal to card.get bounding client rect, like this. Then we have to get the X position of the mouse by saying e.client x minus rect.left minus rect.width divided by 2. I told you we'll have to do some math. And we want to do the same for mouse Y position, which is e.client y minus rect.top minus rect.height over 2. Not only do we have to calculate the position of the mouse, but we also have to calculate the angle. So I'll say calc the angle from the center of the card. So I'll say let angle is equal to math.atan2. This atan2 is a static method that returns the angle in the plane in radians between the positive x-axis and the ray from 0, 0. Yep, I told you this requires some complex math, but I really wanted to show you how to do this cool effect on these cards. So to this, you pass the mouse Y and then the mouse X positions. Then you multiply it over with 180 degrees divided by math.pi. Then we need to adjust the angle so it's in between 0 and 360. So I'll say angle is equal to, in parentheses, angle plus 360, modulo operator, so this will give us the remainder of the division, 360. And trust me, I asked ChatGPT to help a bit with this. So no worries if it's not fully understandable in the first try. You can even copy this block of code and ask ChatGPT to explain it even further, if my explanations are not enough. And then finally, we want to set the angle as a CSS variable by saying card.style.setProperty -- start and set it to angle plus 60. So this way we have nice movement over our cards. And before we test it out, looks like I made a mistake here. I should have said if no card, then return. But if we do have a card, well, then let's do all of this math and let's make it work. So now check this out. You can actually hover over this, and depending on the angle that your mouse is pointing from the center of the card, it'll actually change. So if you very erratically move it around the center, you can see how it moves. But as you go to the outside, the angle becomes smoother, and then you can move very smoothly to different sides. Again, this is a very cool effect, and do you need to know this as a full stack developer? Not necessarily. Nowadays, you can find a lot of these cool effects online. But if you want to become an amazing CSS or front-end developer that delivers these kinds of exceptional, crazy experiences, and if this interests you, then definitely go for it. Try to understand on a deeper level how this gives us the angle, how we're applying that angle over to a CSS property, and then finally, how, once that property gets applied, it actually calculates the gradient that we're applying to the border of this card. But with that said, this is looking great. And we could have totally stopped here with the professional work experience, but I want to dive much deeper. I want to implement the full history of your work, not just the testimonial. So let's do that next. But first, it looks like I'm not passing the proper border right here. So it's card and card border. There we go. So now it makes it look like a card, and this makes the effect even better. And of course, don't forget that we're only halfway, or maybe 1/3 done with the professional work experience section. That's because this is only the left side. On mobile, it seems like we've done everything, but on desktop, well, we still have to add the timeline, and then to the right side, we have to add the full explanation of the experience. So let's do that next. Back in the experience section, right below our glow card. So still within the same div, right below the glow card and below one more div, we can create another div. This div will have a class name is equal to, on extra large devices, W is 4/6. So we have essentially split the screen into the first part, which takes 2/6 of the screen, and the second one takes 4/6. Basically, that's 1/3 and 2/3. So within this div, we can create another div with a class name equal to flex and items-start. And within it, we can do another div that'll have a class name equal to timeline-wrapper, within which we can render a self-closing div that'll have a class name of timeline. And then below that, we can create another div, self-closing, that'll have a class name of gradient -line W1 and H-full. If you save this, you won't see anything yet. And that's because we have to animate this timeline with GSAP. So for now, let's instead focus on the second part of our screen, which are going to be the experience cards. So I'll head only one div below where we have this timeline wrapper, and I'll render another div that'll have a class name equal to exp text flex, on extra large devices a larger gap of 20, on medium devices a gap of 10, and usually a gap of 5 with a position relative and z index of 20. Within it, we can then display another div that'll be a wrapper for the image. So I'll give it a class name of timeline-logo. And within it, I'll render an image, which will have a source of card.logo path with an alt tag of logo. So now we can only see Docker right here, and the other two are not yet there because we need to fix up this GSAP animation of the timeline. Next, we can go one div below and create a div for the final card for our experience section. It'll have an H1 right in between it, and this H1 will render the card.title. There we go, full stack developer. We can make it a bit larger by giving it a class name of font-semi-bold and text-3XL. So now if I collapse this just a tiny bit, you should be able to see it right here. There we go. Below it, I'll display a p tag that'll have a class name equal to margin y of 5 and text white of 50. And there we can render the card.date. There we go. So now it says when you work there, but we can also add some kind of an emoji right here and maybe make it a calendar so we can show the date. But let's not use the current date. Let's use the generic calendar. There we go. Now we can do one more p tag below this one that'll have a class name of text dash hash 839CB5. So this is a color that I like for this one. And let's make it italic. And it'll simply say responsibilities. There we go. And now let's actually say what we did there. So below the p tag, I'll render a UL with a class name of list-disk, ms of 5, margin top of 5, flex-call, a gap of 5, and text-white of 50. Within there, we can map over card.responsibilities.map, where we get each individual responsibility, and we can now show it as a list item. So this list item will have a key equal to responsibility, a class name equal to text-lg, and finally, it'll just render the responsibility. For example, developed and maintained user-facing features for the hosting website, collaborated with UI/UX designers, and optimized web applications for maximum speed. These are all AI generated, don't look that good, but here's my quick tip for how you can write these in a better way. This is basically what you have accomplished. First, use strong action verbs: developed, optimized, implemented, right? Collaborated, achieved, for example, for specific performance, right? So start with a strong action verb: led, worked, contributed. You get the idea. But then bring in some tangible metrics or achievable results. So instead of just being generic with collaborated closely or developed user-facing features, tell me how much performance have you improved. For example, improved app performance, and then try to be specific, even down to a percentage or a number. Improved front-facing app performance by 17%, or maybe improved the load speeds by 2 seconds. Whatever you do, try to be specific in what you did, as that improves the credibility. And now that we have the left side and the right side, it's time to animate the timeline, which is going to give it that final touch. So let's focus on implementing that using GSAP. We'll start at the top of the screen. So let's start implementing this GSAP scroll animation. We already have done a GSAP scroll animation when we were building these cards right here. So you know that if you want to use a scroll animation, you have to import a scroll trigger from GSAP. So right here, I'll say import the original GSAP library coming from GSAP. I'll also want to import the use GSAP hook coming from GSAP React. And finally, we want to get access to the scroll trigger, which will allow the scroll animations coming from GSAP scroll trigger. And then you want to register it by saying gsap.register plugin scroll trigger. There we go. And now we are ready to use this use GSAP hook right here. So let's say use GSAP. It takes in a callback function and an empty dependency array as a typical React use effect. Great. So what kind of animations do we want to implement here? Well, first, we want to reveal the left side cards by sliding them in from the left and fading them in. See these cards? We want to slide and fade them in. If I show you the finished application and I reload, check this out. As I scroll down, you'll notice that these cards slide in. There was the first one, second one, and third one. So let's implement that. I'll say gsap.from. We want to animate a card. So where is this card coming from? Well, even though we don't have a card on its own here, we can use a GSAP utility. Check this out. I'll say gsap.utils.toArray, and we can take a class name called a timeline card, and we can turn it into an array of cards, and then we can map over each one of these cards and get access to that card element. Then, once we actually have access to the card, we can say, get this card from these specific animations or this specific state. First, we want to move the card in from the left side. So I'll say X% is equal to -100. The opacity will also start from 0, And we want to set the origin of the animation to the left side. So I'll say transform origin will be left and left. I also want to add a duration of 1 second and ease, which is a curve of how we're going to animate it, or the speed of the animation. So I'll use the power2 dot in out. It starts slowly and then it speeds up. And finally, we want to trigger the animation on scroll. So I'll say scroll trigger. Oh, but first this ease has to be a string like this. And I can trigger it on the card. But when are we going to start? Well, we're going to start the animation when the card is 80% down the screen. So I'll say start top 80%. If you now save this and reload, you'll see how nicely it appears once you reach the bottom part of the screen, and then also another one and another one. You don't want to show it too soon because the person is still viewing the top part. But as you're scrolling down, you want to show it just as it hits the screen, so you see something happening. There we go. Now we want to animate the timeline. As the user scrolls, we want to move from top and then go down. So in this case, I'll use another GSAP functionality. I'll say GSAP.to.timeline. So that is the class name we're switching. And then we want to set the transform origin to bottom, which means that it can also start from the bottom. So see, as I scroll up, it goes away. And if I scroll down, it appears. I'll choose an ease, in this case, a power1 in out, and add a scroll trigger where we want to trigger it on the dot timeline when the start is at top center, and we want to end it when we reach 70% down the screen. I'm going to be honest, I didn't come up with these values immediately. Coming up with the specific values takes time and testing. So I might maybe set it to 50 and play around a bit and see how it behaves, and then update it later on. Also, we want to update the animation as the user scrolls. So I'll say on update, and this still goes within the scroll trigger. We'll call a function that takes a look at the self current animation, or current progress, and it scales the timeline height as the user scrolls. So from 1 to 0 as the user scrolls up the screen. So I'll say gsap.to.timeline, and I'll set the scale y to 1 minus self.progress. Now, if you reload, you'll start seeing the timeline as we hit the center of the screen, and then it'll scroll down and follow us as we go. Check this out. And then as you reach the end, we cannot go any further right now because we don't have additional sections. Later on we will. But if you start scrolling back up, you can see that it starts disappearing. This is a super cool effect, isn't it? And the last part, we could also animate the text on the right. We can make it look something like this. Considering that the text on the left scrolls from the left, we don't have to move this from left to right because then a lot of things would be moving. We can just fade this one in. So see, as we reach this point, it'll slowly fade in alongside this icon. One more time, check it out. It faded in. So let's add that fade in animation. To get started with it, I'll actually copy this entire GSAP utils to array, and then I'll paste it at the bottom just before the use GSAP hook stops. In this case, we're not working with the timeline card, but rather the experience, so exp text. And for each piece of text, we want to run the GSAP from. We want to move it from 0 opacity, 0% because it's not moving. Throughout the duration of 1 second, we're not moving the origin, so we can leave it as it is. Ease can be as it is. Scroll trigger will be text, and start can be top 60. So we show it a bit later than we actually show the left side card. Now, if I reload and I scroll down, notice how it nicely appears alongside this icon. Perfect. Oh, but I was looking at the finished website, so let's go to the current one, reload, and same behavior. It's only that we cannot see the bottom one yet because we can't scroll any further yet. but as soon as we add the next section on our list, we'll be able to see it. And how does it look like on mobile? Well, check this out. We still get this timeline where it nicely appears, and then it starts scrolling. We see the hostinger, we see the testimonial, we continue scrolling down, and it looks wonderful. Here, we can even see the Docker one because it has more height. Perfect. Alongside the hero section, I think this is the second most interesting section in this portfolio and the second toughest to build. So great job on coming this far into this portfolio. The next section is also super cool. And here we'll develop these cards that have 3D tech icons that allows you to move them in space and time. Pretty cool, right? So let's focus on the tech stack that you know and you use to build your websites with next. I'll collapse it so we can nicely get started on it, close all of the currently open files besides the app, and let's focus on the tech stack. Let's talk about the tech stack. In this case, we're talking about what you can bring to the table, and we'll show it by using these animated 3D logos for each tool that you're proficient in. And of course, if we cannot find a 3D icon, I'll provide you with the alternative so you can just put an image right here and it'll still look great. So let's create it by creating a new section within the sections folder, and let's call it TechStack.jsx. Run RAFCE and import it straight within the app below the experience section. Perfect. That's looking great. So if we head back over here, we can see the tech stack. And we can start by creating the layout. We'll wrap everything with a div that has an ID of skills so we can easily scroll to it. Then we can give it a class name of flex-center and section-padding. And right within it, we'll render another div within which we will reuse our title header component for the consistency of different sections. This title header requires two different params or props. The first one is title. So I'll say my preferred tech stack. And then below, we'll pass a sub. I'll enter some kind of an emoji right here, maybe like a deal hands emoji, and say what I bring to the table. Or we can say the skills I bring to the table. And there we go. We can immediately see it right here. So now we can render the skills grid with these 3D models. We can do that right below the title header. But first, let's give this div a class name of wfull, age-full, on medium devices, a padding x of 10, and typically a padding x of 5. And now, right below the title header, we can create another div with a class name equal to tech-grid. Within this div, we'll want to loop through the tech stack icons array and create a component for each item. So let's open up a dynamic block of code and say tech stack icons dot map, where we get each individual icon. And for each one, we want to automatically return a div that'll have a key equal to icon.name. And within it, we can also, for now, just display that icon name. So if you save it, you should be able to see React, Python, backend, interactive, and project management. Perfect. Now to make it look a bit better, we can style this div, which will basically be a card. So we can give it a card border. We can give it a tech card class name as well. Overflow of hidden, group, and on extra large devices, we can make it a rounded full and typically rounded LG. Now, what matters the most is what we show within it. Instead of rendering the icon name, I'll first render a self-closing div that'll have a class name equal to tech card animated BG. What this will do is once you hover over it, it'll actually animate it a bit, which is not mandatory, but I think it has a cool effect. After that, we can render another div that'll contain the content. So let's give it a class name of tech card content. And within it, we can create a wrapper that contains the tech card experience, which will render the 3D model of that specific tech stack icon. So let me create a div with a class name equal to tech icon wrapper, and directly within it, we can render a new self-closing component. So let's create it under the components folder, and we can create a new folder and call it models, as in 3D models. And then within it, we can create another folder, which we can call tech logos. And within it, we can create a new tech icon.jsx and run RAFCE. Perfect. So now we have this tech icon, and we can import it right within the tech stack where we have the tech icon wrapper. I'll call it tech icon like this and pass in the model right into it by getting it directly from the icon. So we're mapping over these tech stack icons, and each one of these icons has a name, a path to the model that is within our public models folder, a scale, and a rotation in case you want to change it by default. And then we're passing it over here. So now if you compare it, you'll see that we have different tech icons and they're not yet in 3D, but they soon will be. Right below this div that's a wrapper for the tech icon, we can have another div that'll have a class name of padding X and W full. And we use these classes to add horizontal padding to the text and to make it take up the full width of the component. So within it, we can display the name of that icon. So I'll say icon.name. Perfect. So now we have React developer right here, and then we have the icon which we want to display in the middle. And let's just make sure to wrap it in a p tag. So if we close it like this, you can see that it'll nicely get centered. Now we can head over into the tech icon and start implementing that rotating 3D model for each one of the tech logos inside of a canvas. Remember, whenever you have a 3D experience, you can show it within a canvas. So before we get started, let me explain how it works. In simple terms, this is exactly what we want to do. First, we want to load a GLB model in a GLTF format. Then we want to add basic lighting to it so we can see it. We want to apply environment reflections for realism, wrap the model in a floating animation, and then optionally tweak the material, like setting the color on a mesh. And then we want to disable zoom because there's nothing to zoom into here. We just want to be able to move it around. So let's do just that. We'll start by loading in the models. Right here, I'll say const scene is equal to use GLTF coming from React 3 Drei, and I'll just get in the model from the props that we're passing into the function. So I'll say model. Keep in mind, we're passing it right here. Model is the icon. And then I'll simply load in model.model path. Perfect. We just loaded the GLB model using Drei's useGLTF hook. And the file path comes from the model path, which is right here within our constants file. So if you want to compare it, check out the public folder and then head over to models. And then you'll be able to see Python, Three.js, React, Node, and Git. Perfect. Now that we have loaded in the model, we want to set up the canvas. So think of the canvas as the starting div in the 3D world. You cannot display Three.js properties within a div. If you tried putting some ambient lighting here, like this, it wouldn't work. But if you render a canvas right here, coming from React 3 Fiber, then you can start using all of these properties. So let's add a basic fill light with an intensity of about 0.3. Once again, we can play with that very soon. And right below it, I'll add an environment coming from React 3 Drei with a preset set to city. So there are actually a couple of presets that you can choose from to load your elements within. This city environment will add specific ambient lighting to achieve a realistic scene reflection. It makes metal and glossy surfaces look real with minimal setup. Then we're going to wrap everything in a floating animation. So I'll say float coming from React 3 Drei. And within it, I'll wrap a group. And within that group, I will render a primitive specifically an object of scene.scene. There we go. So we can already start seeing some logos right here, but you can see that they're not looking that good. It's bad, actually. So let's modify the float. I'll give it a speed equal to 5.5. And now you can see they're moving around, kinda. I'll also set the rotation intensity to 0.5, so they're moving a bit slower. And I'll also give it a float intensity of around 0.9. So now they're floating even more subtly. But again, you can totally change this. You can increase the rotation intensity to 1 or maybe even 2 if you really want them to move around, or keep it a bit more subtle. Next, we can also play with the group by giving it a scale equal to, you can make it 2, you can make it 3. Of course, it's going to be too big. So I decided to provide a scale already within the model. So you can just say model.scale, which is going to scale all of these accordingly because some are bigger and some are smaller by default. So this is coming directly from the index of the constants, where you can see that scale is 1 for React because it's just the right size. But for example, Python was too large, so I lowered it down a bit. And the Node.js was too small, so I had to increase the scale significantly. We can also do the same thing with rotation. So I'll say rotation is equal to model.rotation. Perfect. So now they're all facing right toward the user. As you can see, the float component is pretty cool. It's a utility from React 3 Drei library used to create a simple animation of the model floating in space. And what do you say that we also apply some additional light to make it look a bit more intentional, let's say. Below the ambient light, which you can see, we can also play with it. If I lower the intensity to 0, well, you cannot really see the difference. But if I do it to 1, they're going to shine really bright, which we don't really need. So I'll keep it very low. But next, we can add a directional light, position it around 555. Of course, we have to spell it correctly so our app doesn't break. Directional. And I'll set the intensity to 1. Again, makes a little difference. You cannot really see it a lot with the React logo, but if you pay attention to the Node.js logo, you'll see how the corners shine just a bit brighter. And you'll see it even more once we allow you to move the model around or orbit it around. For that, we'll use the orbit controls. We have already used it before, so you can just say orbit controls and just pass the enable zoom set to false because we don't want to zoom in. We just want to be able to move them around. And check this out. Just like that, you can move this logo around and see it in all different lights. Great. Now there's just one tweak I want to do, and that is to change the color of this Three.js logo. Originally, it is black, but it's not really looking good alongside our background. So what do you say that we tweak it just a tiny bit? I'll add a use effect, which will allow us to apply a specific effect as our components load, just initially on mount, and we want to do it whenever the scene changes. So if we load the scene later on, then we want to apply it to a specific scene. I'll then say if model.name, oh, and don't forget to import use effect coming from React. That's very important. So now if model.name is triple equal to interactive developer, in that case, we want to set the scene.traverse. So we want to traverse a child element of that scene, and we want to check if child.isMesh and if child.name is triple equal to object_5. It took me some time to find it, but basically we're targeting that specific model of Three.js. Then I want to set the child material to be equal to new 3.mesh standard material. And I want to pass in a color of white. And to be able to use this 3, make sure to import everything as 3 from 3. Perfect. So if you do this, you can see that we can now change the color, or we can specifically target the material of this specific mesh. You can change it to red, but you have to reload the screen. There we go. But of course, we're going to go with white. It looks very good on our background. There we go. This is nice. Now, it's possible that maybe you don't know Python and you're wondering how you can replace this for some other technology that you want to include here. Don't worry, I'm going to teach you how to do just that very soon. But before that, there's just one little part missing from this section. And that are, of course, animations. So let's go back to the TechStack component and let's animate these icons one by one. I'll of course use the use GSAP hook coming from GSAP React. We will target it like this, and within it, I'll say GSAP, which we have to import, of course. So import GSAP from GSAP. Oh, I think it has to be within curly braces, actually. So I'll say GSAP.from to. What do I want to animate? I want to animate the tech card. At the start, I want to move the card down by 50 pixels and set the opacity to 0. And then at the end, I wanted to move the card back to the top. I want to reset the opacity to 1 throughout the duration of 1 second. Ease can be set to power2.inout, which we used before as well. Stagger can be 0.2, which means that each animation will happen 0.2 seconds after the other. And then we can also add a scroll trigger. And we want to trigger it once we get to the skills section. And we want to start it once we reach the top center part of the screen. So now if you reload and start scrolling down, you can see how they will all load one after another. But of course, that looks even better on desktop. So if you reload and go to the bottom, check this out. 0.2 seconds for each one. Let me show you one more time. There we go. So they all load from the bottom to the top, and they also go from opacity 0 to opacity 1. And you can see them all like this. This is looking great. You can also spin them around super fast. That's cool. And I guess the question is, what if you don't know Python? Well, I prepared an additional part of this section for you, so you can replace this with any other static image. Or no, it doesn't have to be static. If you want to take some time and search the web for some other 3D icons of technologies that you know, go ahead. Maybe go to Sketchfab and search for something like, I don't know, Next.js. But it might be hard to find the white version of the Next.js logo. Or maybe you want to add something else. If you can find a 3D model for it, just plug it in, point to its path. So head over to the constants, index.js, and just add it to the models, point to that 3D file, most likely with a GLB extension, and load it in. But maybe you won't be able to find 3D icons for all of these different technologies. So let me show you how we can make it work with the regular images. I'll head back to the tech stack, and I want to go after we finish mapping over these icons, and I'll add a new part. I'll once again map over the tech stack images this time, because I also prepared some images for you. I'll say .map, we get an individual icon, and for each icon, we want to display a div. This div will have a class name equal to, very similar to what we had above. So let me actually copy it, this div right here, and I will paste it here. Within it, we can display a self-closing div with a class name equal to tech card animated BG as before. And we can open up a div that'll act as the content wrapper. So I'll say tech card content. And then within it, a div that'll have a class name of tech icon wrapper, still the same as above. But the only difference is that here, now we can display a regular image. So source of icon dot image path instead of a model. And then right below it, we can render another div that'll have a class name of padding X and W full. And it'll render a p tag that'll render the icon dot name. So if you save this, you'll see that just below, we have an image variation of the same thing. Now, is this one better? Well, of course it is. And for some, you can have 3D models, but for others, if you cannot find the logo in the 3D format, then you can use this section right here, because this is much easier to replace. You can go to Constants, TechStack Images, and just download the PNG image, put it in the path, and then change the name, map over it, and you're good. I got you covered. I know that you guys know so many technologies, and I wanted to make this portfolio as customizable as possible for you. So for now, I'm going to use my TechStack 3D models, but you can opt for using just regular images in case you want to have a consistent showcase of the tech stack that you specifically know. And that brings us to the end of the tech stack section, which looks great on mobile as well as it does on desktop. So in the next section, let's focus on the testimonial section, allowing you to brag yourself a bit, not by saying good things about yourself, but by showcasing what other people have to say about you. The testimonial section is pretty simple, yet as you start hovering over it, you'll see that it is pretty cool. I mean, the goal of your websites is not to be flashy. Things don't need to jump around. They have to be minimal, but still they have to showcase what you're capable of, which is exactly what we do with this simple testimonial section. A cool thing about it is, of course, this border that we have implemented, and an even cooler thing is just how quickly we'll be able to get it implemented now that we already have this reusable card. Let me show you. I'll create a new section within the sections folder, and I'll call it Testimonials.jsx. I'll run RAFCE and import it within our app.jsx right below the tech stack. I'll head over into it and start implementing the layout. First, I'll wrap everything in a semantic section tag with an ID of testimonials so we can scroll to it from the navbar, and I'll give it a class name equal to flex-center and section-padding so it has some nice space to breathe. Next, I'll render a div that'll wrap our title. So let me give it a class name equal to wfull, hfull, on medium devices, a padding x of 10, and typically a padding x of 5. And within it, I'll render a reusable title header component with a title of what people say about me. And then I'll add a subtitle. Maybe we render an emoji of a star and then say client feedback highlights. And if you scroll down, looks good and is consistent with other sections we have on the screen. But now is the time that we render the grid of these cards. We'll use a multi-column layout, similar to this masonry style card layout that you often see on these websites like Pinterest, where you have images coming in at different heights within different columns. It creates this visually interesting layout that says, hey, look at how much content there is. It is basically infinite because you can only see half of this card here, which means there's more at the top, and you can only see half of this card here, which means that there's more at the bottom. And you want to have a similar feel with your testimonial grid as well to let people know that there's just so much good things to say about you. So below the title, I'll render a div that'll have a class name equal to on large devices, give me 3 columns, on medium devices, give me 2 columns, otherwise give me 1 column, and give me some margin top of about 16. Within it, we can say testimonials.map, where we get each individual testimonial. And for each one, for now, we can render, well, let's do testimonial.review. So I'll say p tag and render testimonial.review. Of course, make sure to import testimonials from the constants index and give each one a name, a mention, maybe to their socials, their actual review, and a path to the image. Of course, you'll have to take some time to go through these and actually change them to the feedback that you were given. Hopefully working with you was even better than working with me. So if you do that, you'll be able to see this scattered feedback right here. But now we want to display it in a very nice layout. And doing that will be super easy. We just have to reuse the glow card. Remember that card that we used right before? Here. We'll just reuse it. Let me show you how. I will wrap everything in a glow card, and I'll pass in some children, specifically a div that has a class name of flex, items-center, and a gap of 3. And here I can say test for now. If you do that, the website will break because you also have to pass a prop to the glow card of card is equal to testimonial so that it knows what to render. Now, if you scroll down, you'll be able to see 5 different cards that all say test at the bottom, but already half of it is done. We have 5 stars and the reviews from the testimonial are getting passed over to the card. The only remaining part is to show who gave us that feedback. So I'll create another div within this inner div that'll contain an image with a source of testimonial.img path with an alt tag equal to testimonial.name. There we go. So we can see different people right now. We can create another div right below it that'll render a p tag with a class name equal to font-bold. And this one can say testimonial name. I now see that we're repeating ourselves too much. Testimonial, image path, name, and so on. So let me just destructure those values. Image path, name, and mentions. And now you don't have to repeat yourself here. You can just say image path. Here you can say name. Here, where you're rendering a p tag, you can also render a name. But now you'll have to pass all of these within an object to the card because we no longer have access to the original testimonial. So we have to pass all of them. Name, mentions, review, and image path. But I think the glow card itself only uses a couple of things. It uses the review. Yeah, that's it. So we just need to pass over a review right here, which we get over from the card. If I save this and scroll to the bottom, you can see that we still have 5 stars, the review, and now we also have the photo and the name of the guy. But to increase the credibility even further, we can render another p tag here with a class name of text white 50, and we can render the mention of that guy or gal, which gives us their socials. So if somebody wants to verify whether this guy is a real guy, well, then they would have to maybe check them out on Twitter or something like that. Most developers nowadays have active Twitter profiles. Also, I noticed that we're missing some space in between the cards vertically on mobile devices. So if you head over into the glow card, we can add some additional classes to it, such as a margin bottom of 5, and also break inside a void column. This is a special CSS property that sets how page, column, or region breaks should behave inside a generated box. It is perfect just for this use case where you have different cards, one on top of another. So this is great. And with that, we're actually done with the testimonial section. So far, we have only seen it on mobile, but now check it out on desktop. We have this nice layout where this card appears to be taking some more space than this one and so on. And the more cards you add with different heights of the content, the better it'll look like. Remember that masonry Pinterest grid? If you head over into the testimonials and maybe duplicate a couple of these right here and save it, you can see how it adapts to the amount of content we have. So go ahead and collect those positive testimonials. It's always great to have some experts vouch for you. With that said, we're getting very, very close to the bottom of our page. Nonetheless, it's going to be an amazing finishing touch, where we'll implement this fully functional form that'll allow other people to contact you, and then we'll implement another super cool artistic 3D model that basically says, hey, I'm going to be at my desk, feel free to send me an email. So let's do that next. Last but not least section of the portfolio, and maybe the most important one, because without it, how would people be able to reach you to hire you? So let's get started with implementing the contact section. Back in our project, the last section we implemented was the testimonial section. So now we have to add the contact section just below. And recently, I saw that JetBrains released a new coding agent that can speed up our workflow. So I wanted to test it a bit when creating this contact section. I'll press Command-Shift-P and open up Junie. That's the name of our assistant. If you're using WebStorm and you want to test it out with me, I'll leave the link down in the description. But for now, let's try to be precise. Let's say create a new section called Contact, import it within the app, and within it, use the class names that we typically wrap all of our sections with, and also add a title header component right within it that says something about contacting us. I'll turn on the Brave mode and give it a go. It is working right now, and it actually outlined a plan. Examine the current structure, look at the title header component, since we need to use it, create a new contacts file in the sections directory, implement the contact component with appropriate class names and title header, and then import and add the contact component to app.js. So right now, it's actually doing all of that. It's opening all of these things, editing different pages. It looks like it actually created a new contact section right here within sections, contact. And it ended up using the title header right here, alongside with some other information. Pretty cool. Now it's editing the app and adding the contact section right within it by following the same structure we used before. And it told us exactly what it did right here. So we can roll back or just call it a day. Now, if I save this and give Junie some time to rest, let's see what we have. So it looks like it did exactly what I asked it to do. It created a new section right here within the sections directory called Contact. It gave it an ID so we can scroll to it alongside some default class names. And it also used our title header component with a title as well as a sub. And it even added an emoji because it noticed that that's exactly what we're doing for other sections. And then, since I wasn't precise on what we want to see below, it created a generic structure where somebody can actually copy this email and send it to us. Pretty cool stuff that it was able to do all of this, not just generate code, but also create files for us. If you didn't end up using Junie just yet, that's totally fine. You can pause this video and copy this code right here where it generated this title header. But can we take it a step further? Can we maybe get it to create a layout right here where we're going to have a form, and then also it'll create a new component on the right side that'll allow us to display this great looking 3D model? Well, let's give it a shot. I'll once again open up Junie and say something like, within the contact section, just below the title header. And by the way, I haven't used Junie before, so I don't know how precise I have to be, so better to be as descriptive as possible. But maybe it works with less info as well, I don't know. So right here, I'll say within the contact section, just below the title header, create a layout with a grid 12 calls class, where on the left side, we'll have a form that has labels and inputs for the name, the email, and the message, and of course, a submit button. You can find some classes within the index.css to keep it consistent. And then on the right side of that form, create and display a new component called Contact Experience, within which we'll later on display a Three.js canvas by importing a computer optimized .glb file and immediately add some lights and meshes so we can see it on the screen. This is a super hard task, and I'm not expecting Junie to get it right on the first time, but who knows? Let's see. I love testing these AI tools as they just make you that much more efficient of a developer. There we go. It's researching everything just to get some context, and then it'll try to create stuff. Okay, looks like it started editing the contact experience part. So if we head over to our components, we can see the contact experience, and it is writing code right now, already putting in the canvas and some lights and meshes in the environment. Looks like it's keeping in mind what we did for the hero section, and it's done. Junie says, a grid layout was implemented in the contact section featuring a form on the left for name, email, and message inputs, alongside a new contact experience component displaying a 3D computer model using Three.js on the right. The implementation is error-free, and all components function as intended. This is super cool, but let's see if that is really the case. It looks like it actually generated a form that is super similar to the one on the final application. Just a couple of tweaks and it'll be there. And it also left some space right here on the right to display our canvas, but we'll have to make a couple of tweaks to actually get it to show. So let's explore what it did within the code. If I head over to the app, we still have the contact section. It created some states, handle changes as well. Oh, so actually we can already type within this form. That's super cool. And we have a form where we can actually submit that data. And after that, we have our div for the left side of the form. Let's go through it together. So if you haven't used Junie, we can actually go ahead and write it together ourselves manually. Okay, first things first. Right below our title header, we have a div that has a class name of margin top of 16 and grid 12 columns. Then we have a contact form left side that has a div where we have on extra large devices call span of 6. In this case, we can maybe make it 5 so that then the right side takes a larger portion of the screen. And I'll also remove this part. We won't need it, as later on, as we continue developing our layout, we'll make sure that it all fits nicely if we're on mobile devices. So within this div, I'll create another div that'll have a class name equal to flex-center, card-border, rounded-XL, and a padding of 10. And within it, I want to bring my form. So let me copy the form and just bring it a couple of steps up right here within this div. If you now save this, you'll notice that it looks something like this. Make sure to give it a class name equal to w-full, flex-call, and a gap of 7. And let's look into the top part. We have an ID of contact, flex center, section padding. We have a div that has a class name of w-full, h-full, on medium devices padding x of 10, and typically padding x of 5. Then, just below the title header, we have this div that then contains the left side of the form. Let's just make sure that the right side is not included within that div. So for the 3D experience, I'll give it an extra large call span 7, so it takes a bit more space. I'll remove the call span 12, and I'll set the min h to 96. So now you'll see that this will take 7 out of 12 spaces, and this form will take 5 out of 12. But on mobile devices, it'll actually take the full width of the screen. I can actually explain that by providing a border 2 and border solid red. And you can see that this takes this part of the screen right now. But if I do the same thing for the bottom one, so for the right side, it'll look something like this, where now it takes the bottom part of the screen. But as soon as you expand it, you can see that this takes 5 out of 12, and this one takes 7 out of 12, which means that our layout is great. So I'll remove those borders, and we can continue with the rest of the code. I know that it's possible that you might not have had this code at the bottom. So if this is getting a bit more complicated, I'll also provide a complete contact.jsx file within the video kit, so you can copy it and have this form right here. But with that said, don't worry, because we can also type it out together. Next, we have the form that has a class name of w-full, flex-call, and a gap of 7. And within it, we have a div. I don't think this div will need a class name for a margin bottom. We can just use the gaps to provide that spacing. We have a label for HTML4 for the name. We have an input that has a type of text, an ID of name, a placeholder of your name, and some parameters that we need to manage its value. After that, we have another div that has a label for email and also some properties for the email. And finally, we have another one right at the bottom that's managing the message property, which is actually a text area. Finally, After that div containing the text area, we have the button with a type submit. And in this case, we can style it a bit differently by rendering a div right within the button that'll have a class name equal to CTA button group. Within it, we will display a div that'll have a class name of BG circle. And you can notice that I'm recreating the button we had at the top. That's because this one will be an actual submit button, whereas the previous button was not really a button. Technically, it was an anchor tag that we used to scroll to some places. Right below this div that says BG circle, I'll render a p tag. That'll render a text of send message. And it'll have a class name equal to text. And below it, I'll render a div with a class name equal to arrow dash wrapper. And it'll render a self-closing image with a source of /images /arrow dash down dot svg and an alt tag of arrow. If you save that, we'll once again have this beautiful button that allows you to send a message. Then, if we go a bit down below the div, below the button, and below the form, and below two more divs, we get to the second part of the screen. Just a simple div with a min height taking 7 out of 12 spaces on extra large devices, and within it, we can display another div within which we'll put this contact experience, which you might not have yet if you haven't used Juni, but don't worry because we're going to create it together. This div will have a class name equal to wfull for full width, hfull for full height, and a background color. Let's make this a bright orange color that you saw in the preview of CD7C2E. If you save it, oh, it looks like we already get some kind of a canvas right here, or at least a background color. Let's make it a hover cursor grab. So we give a user an indication that they can actually move around this 3D experience. Let's round up the corners a bit by saying rounded 3XL, and let's set the overflow to hidden. If you save this, this is looking great, but it looks like nothing's on the screen. What if I expand it? Oh, still nothing. But if I drag and drop, oh, would you look at that? The 3D model is actually here, but we are at the bottom of the table. So it looks like Juni was actually able to find a 3D model within our public folder and set up Three.js, React 3 Fiber, and React 3 Drei with orbit controls to allow us to see this model. It messed up the positioning a bit, but that's totally okay because we can easily fix that. So let's head over into the contact experience or create it for the first time if you haven't already. And let's see what we have over here. As before, I found this model on Sketchfab completely for free, so you can download it and use it from here. But this time, I'll actually teach you another strategy of how you can auto-optimize your models. Check this out. If you head over to the public folder and head over to models, you'll see that we have a computer optimized as well as the computer optimized transformed. If you right-click it and open it within your file system, you'll notice that the computer optimized has 486 kilobytes, whereas the computer optimized transformed only has 40. That is more than a 10-fold optimization. Huge. So let me show you how you can achieve that. As before, we'll use this GLTF JSX package, but this time we'll also apply a T flag, which transforms the asset for the web. Draco prune resize. It'll automatically optimize the model. So within our code, just open up a terminal, cd into public, and then cd into models. Then run npx gltf jsx computer-optimized.glb-t and press enter. You'll see that this will create a new computer-optimized.jsx file. So move it into components and then models. Then head over into it to see what was generated and rename it over to computer. You'll see that it's getting the nodes and the materials by using the use gltf computer optimized transformed, but make sure to add /models right here before it. So models computer optimized. And then we want to do the same thing right here at the bottom, /models/computer optimized. And now it has two different meshes to which we can also add some shadows. So say cast shadows as well as receive shadows. This will have that special animated effect on our model. Now head back over to the contact experience file and import that model. Even though what Junie created was totally working, I'll delete it just because we now optimized this 3D model even further. Maybe Junie would have been able to do that as well if I told it to. But for now, within this canvas, simply create a group, give it a scale of like 0.03 because it is a big model, and let's change the position to something like 0, -1.5, and then -2. I found this position to work the best. And of course, let's say cast shadow. Within this group, you can render the computer model coming from components models. So in my case, if I go back to the application, I can now see this beautiful model right here with a lot of light and not too many shadows, at least not yet. But hey, it's here. For you, it might not be there yet as we haven't added those additional things, but don't worry as we're gonna do that right now. First, I wanna look into orbit controls. We will set enable zoom to false and set the min polar angle to math pi over 5 and max polar angle to math pi over 2. This one limits how far the user can rotate down, and this one limits how far the user can rotate up. So we don't want to allow them to go too much up or too much down because then the scene doesn't make any sense. And now, of course, we want to play with the lights. I'll remove this environment as we don't need it in this case. There we go. So now this looks a bit more dull, but we want to create a cozy and warm environment. So let's play with the ambient light with the intensity of 0.5, a color of hash FFF 4E6. That's going to give it that warm tone. Let's also play with a directional light of something like 553 with an intensity of 2.5 and a color of hash FFD 9B3. Okay, we're getting there. And instead of this spotlight, I'll add another directional light, this time with a position equal to 591. There we go. Cast shadow will be turned on to true. Intensity will be also set to 2.5. And we'll add a color of hash FFD 9B3. These lights will add that warmth. And finally, to actually cast shadows, we cannot do it in this universe because this is just a orange background, right? So it's not reflecting any shadows. To actually receive shadows, we need to create a large flat surface under the model. So we have something to cast the shadows on. So right below this computer, below the group, create another group with a scale property of 111 and a mesh that will receive shadows with a position of 0, -1.5, and 0, and a rotation of minus math.pi over 2, and then 0, 0. I found those values to work the best. And within it, we can display the plane geometry. You can kind of see it right here at the bottom. So we're basically adding the floor. I'll give it args of 30, 30, which is going to make it much larger. So we have more space to cast shadows. And I'll also give it a mesh standard material with a color of hash A46B2D. Check that out. That's much better. And you can kind of see it in the distance, right? Where it ends. But if you're just looking at the middle of the screen, you won't be able to tell the difference. But we still can't see any shadows, can we? Let's head over into our computer model to see if maybe we didn't cast the shadow somewhere. I'll actually zoom it in so we can see it better. Oh, I made a mistake. This was supposed to be cast shadow, not shadows, because a mesh can only cast one shadow if it's a singular object, and also receive shadow. So you'll have to fix this on a couple of places. So now that we know that that is good, we can also take a look at our lights and everything that we have within this canvas. This ambient light looks good to me. Besides, the light is maybe a bit too yellow. So let's say 4E6. There we go. So now we have this more natural white color. And you can see the shadows are being applied on this computer right here, or rather on the table. It's just that they're not being applied on the floor. Looking at the directional light, we have a position of 553, intensity of 2.5, and some nice color. This is looking good. And another directional light, which is also looking good to me. Finally, we have a group for the computer with the scale and its position, and it says cast shadow. Below it, we render the floor. So here I see receive shadows. No, this was supposed to be receive shadow. There we go. So now this scene really pops and comes to life because something in our minds is telling us, hey, this cannot be right. This is flying in the air. We need to see some shadows because the light is so bright, so there has to be shadow. Which just shows you how important shadows are. But with that in mind, we have now developed this Get in Touch with Me session with a form, as well as this nice looking 3D desk setup, which has this some sort of a cartoonish look with nice shadows. So what do you say that in the next lesson, we make the form functional? So people looking at your portfolio can actually send you emails. To make our form functional and to allow other users to email us, we'll use email.js. It is completely free and super simple to set up. So just head over to email.js, create a free account or sign in if you have an account already. And once you're in, you should be able to see something that looks like this. Add a new service, choose your email provider. In this case, I'll go with Gmail. Give it a name and copy the service ID. Head back over to your app and create a new .env file. Within it, say vite underscore app underscore email js underscore service underscore ID and paste the service ID you just copied. Then click connect account and continue. It'll ask you whether you want to allow it to send emails on your behalf. Select yes. It'll say connected and click create service. Once the service has been added, head over to email templates, create a new email template. You can leave it as a simple contact template. Click create, and you'll have to head over to settings and copy the template ID. Then within your env file, create another environment variable called vite app email.js template ID and simply paste the ID you just copied. Then head over to account within the sidebar and copy your public ID. This one you can add as vite app email.js public key. So you should have 3 keys in your envs. Now, back within our contact section, we'll have to somehow get access to the values within our form fields. And thankfully, Juni has already done that for us. We have created a new use state with name, email, and message fields. And we're also handling the changes whenever user types anything on these fields. Just to make it a bit more responsive, we can also add the loading state. So const loading, set loading, at the start set to use state false, and then we can update the button with the loading state. So right below where we have our button, which is right here, the button can be disabled if we're currently loading. So I'll say disabled if loading. And we can also change the text to say if we're loading, then display sending ... else display send message. Finally, we can head over to handle submit. First, you have to prevent the default behavior of the browser to reload once you submit a form. We don't want that within modern applications. And now that we have collected all of these values within form data, what do you say that we go ahead and hook it up to email.js keys that we just got from their dashboard? To do that, you'll have to install a new package by running npm i @email.js/browser. And then you can import it at the top by saying import email.js from @email.js/browser. And then within handle submit, we want to take the data that we have, but we'll make it into an asynchronous function because sending an email does take some time. So instead of console logging, I'll just open up a try and catch block. In case something goes wrong, we'll get an error, and I'll say console log email.js error, and maybe we can also display that error right here next to it. And then we can also add a finally block, which will be executed no matter whether we succeed or fail with that request. And here we can just reset the loading to false because we want to stop it even when there's an error. And then in the try, we want to use email.js functionality to send the form. First, we will trigger the loading. So at the top, I'll say set loading is set to true. And then here, we'll say await email.js dot send form, and you want to pass all of the keys that we saved. Import dot meta dot env dot vite app email.js service ID. That's the first one. You want to duplicate it. The second one is the template ID. So how do you want your email to look like? And the third one is the public key. That's everything you need to send over an email. Finally, we want to reset the form after submission. So I'll bring this up right here. And that's more or less it. This should successfully send an email. So what do you say that we go ahead and test it out? I've already filled in some information right here, but the question is, where are we actually taking in this form data and passing it into the send form? See, the way in which it works is first you pass the service ID, then the template ID, then the form, and finally the options. So right here, after your second parameter, you want to pass in the form data. Specifically, you want to pass a reference to the form. So let's create a new reference right at the top by saying const form ref is equal to use ref coming from React at the start set to null, and we can attach this reference to a form. So just scroll down to where we start with our form and give this form a ref equal to form ref. And now right here, we can pass form ref dot current, which will contain all the information from the form. So reload the app, head over to the contact me. Let's say that your employer is contacting you from john@doe.com, and they're going to say you're hired. Finally, click send a message. It says sending. And what happened? It looks like I passed the wrong template ID. So back on email.js, maybe I didn't proceed with fully completing my form. I'll click create. Oh yeah, I didn't save it. So I'll have to head over to settings, copy the ID one more time, re-add it to my envs right here, and then don't forget to click save. Yep, this is what matters. Now, if you reload the page, scroll to the contact, and try to send out the email, the autofill also works. We're going to say you're hired and send the message. Sending, you can see that the form actually get cleared, which means that it successfully got sent. And if you head over to your email provider, you'll see a new email saying a message by Adrian has been received. Respond at your earliest convenience. You are hired. And the only problem that we have right now is that we don't know who to respond to. What is the email that they left? So if you head over to your template content, alongside displaying the name and the message, right below, we can also render the email. So just use a double curly brace and render the email variable right here, save it. And if we once again try to send out an email, this time on the big screen, testing, the email arrives in a second, and now it also contains the email that you can respond to. Perfect. We've got it all covered. So to finish it off, let's also add a simple footer, because this form and the 3D model really need some breathing room at the bottom of the screen. We'll do something super simple that looks like this, where people can maybe read a bit more about us. I would suggest that you point this to your blog and then go ahead and implement it. Write about your learning journey, because you don't really have terms and conditions. Also, put your professional profiles, okay? I wouldn't actually advise going for Instagram or Facebook, but X or LinkedIn or the links to your blogs totally go for that, and then put your name here. To implement this footer, I'll head over into the sections folder and create a new file called footer.jsx, run rafce, and import it right within our app by simply rendering a self-closing footer component. We can then head over into it and wrap it in a semantic footer tag that'll have a class name of footer, which will automatically give it some room to breathe. Within it, we can render a div that'll have a class name equal to footer-container. And then within it, another div that'll have a class name of flex, flex-call, and justify-center, within which we can display an anchor tag with an href pointing to just /. And this one can say, visit my blog. So if you really want to take this portfolio further, try implementing a blog section as well, or point to your Medium blog maybe. Below that div, render another div. This one will have a class name of socials. And here you can map over your social images by saying social images.map, where you get each individual image. So I can say img, and for each one, render an anchor tag, which will then render an image with a source of img.img path. If you do that, you should be able to see those 4 icons. And these social images are coming from constants, so you can totally change their name or even delete or add some new platforms that you're using. And of course, put your URL right there. Let's give this anchor tag a class name equal to icon, a target of _blank, so it opens up within a new tab, an href pointing to the img.url, and since we're mapping over it, also a key of img.url because it's unique. Finally, we can head below this div of socials and add another div for the right side of the footer with a class name of flex, flex-call, justify-center, within which we can have a p tag that'll have a class name equal to text-center, and on medium devices, text-end, and within it, we can display that copyright sign, and then create a new date and get the current full year. So that way, even the next year, this will be updated. You can put your name right here and say something like all rights reserved. Well, I give you the rights right here to use this as a portfolio. Now we could also align this visit my blog to the center. So I'll say items center. There we go. So it looks good on mobile devices. But if we expand it, it gives just the right amount of space right here for desktop devices too. But here I actually want to keep it on the left corner. So I can say on medium devices and larger, items start, which is going to put it here, but on mobile, it'll be centered. And that brings us to the end of the footer and almost to the end of the entire build. One thing that I don't like right now is that we haven't changed the favicon nor the title. I want it to look something a bit more like this. So to change it, head over to the index.html file right here and change the title to something like your name and m dash semicolon, do 2 of these, and then say portfolio. This will form this nice Adrian longline portfolio. Also, we just have to replace this favicon, which is the default v1, which everybody has, with the updated favicon. So point the path of the link to /images/fav.png. If you save it, you will see my initials right here. But of course, I don't want you to use my initials. So on the right side of the design, I prepared this part right here that says icons, where you can change some of the logos or some other aspects of your portfolio. For example, you can change your initials right here. So to be able to change it, you'll have to duplicate it. So just say duplicate to your drafts, and then you'll be able to edit and export this icon. Once you do that, you can just put it to your public folder, point to it right here, and then it'll update for your portfolio. And with that said, we are done with building our amazing portfolio. So the last step we have to do is to get it deployed to the internet so we can share it with everyone. And we're back on Hostinger's dashboard. I already got the domain name with my hosting, and if you purchased and selected yours, you should be able to see a page that looks something like this. If you didn't get the hosting or the domain name yet, you can do that by clicking the link down in the description. Once you find your website or your domain name, click File Manager. Then head over into your public HTML and delete the default PHP because here we're going to upload our website. So go back to your application, stop it from running and close all of the terminals, and just run npm run build. This will build an optimized production build of your application. There we go. Took just 3 seconds. If you check out your project, you'll notice that there's a new dist, as in distribution folder, that contains everything about your website. So right-click it and open it up within your Finder or File Explorer. Then go into it, select everything within it, and drag and drop it right here within your H panel. There we go. Now close the H panel. You'll be redirected back to your domain and click on it. And that's it. It loaded instantly with the proper favicon, title, and even an HTTPS certificate. Just try reloading it and see how fast it is. And take a second to admire everything you've built. Having this custom domain name, SSL certificate, and fast load times definitely makes you stand out in the crowd. And let's also test out our email functionality. Test from production. I'll go ahead and send it. And I got it in a second. Perfect. And there you have it. You have successfully built your own 3D personal portfolio. Congratulations. Oh yeah, and let's not forget that it is fully mobile responsive. I mean, just look at it with these nice looking timeline animations. It is just amazing. Since you came to the end of this one, I know you love Three.js and I know you want to get better at it. So the only next step that makes sense for you right now after watching this video is to check out the ultimate Three.js course, live right now on JS Mastery Pro. Here, we'll dive super deep into every single Three.js property that we covered in this video and so much more. From different geometries, planes, modifying the 3D world and lights and shadows and so much more, we'll explore everything that Three.js has to offer. So check it out, the link is in the description. With that said, thank you so much for watching, and I'll see you on JS Mastery Pro.